Buonasera a tutti e benvenuti in questa nuova diretta. Questa sera vedremo un po' di eventi molto importanti e interessanti soprattutto. Come prima cosa, prima la sigla e poi vi spiego il programma. E vai con la intro. Ok, allora, questa sera dov'è? Allora, qua. Allora, questa è la copertina del video in cui dice semplicemente che alle 22 inizia la diretta, che è appena iniziata e che voi state ascoltando, e che alle 23:14 ci sarà un lancio di un Electron, un piccolo razzo, e che alle 4:55 ci sarà l'atterraggio della Sojuz MS-16. Ciao Brian. Allora, poi vediamo. Porco cane, ok. Vediamo il programma con le date date da NASA e Rocket Lab. Quindi alle 22 inizia la diretta, è appena iniziata. Alle 22, tra le 22:10 e le 22:30 verranno sigillati i portelloni tra Sojuz MS-16 e il resto della ISS. Cioè, praticamente avviene un cambio di equipaggio sulla Stazione Spaziale Internazionale. E poi tra le 23:14 e mezzanotte 3, quindi c'è una finestra di lancio di poco meno di un'ora, partirà un Electron, 15° volo per l'Electron, con a bordo 10 satelliti e la missione si chiama In Focus e la vedremo meglio dopo. All'1:30 la Sojuz MS-16 si separerà dagli SS e alle 4:55 di domani mattina la Sojuz MS-16 atterrerà in Kazakistan. Ma io quando parlerò starò seriamente sveglio 7 ore.
While continuing to be quiet today as the crew on board the International
Ciao
Space
Emma.
Station prepares to say their final
E
farewells
quando
and split
parlerò,
up
stavo
with
dicendo,
Chris
alle
Kasky,
22 la diretta è
Anatoly
iniziata e ve
Ivanishin,
l'ho
and
detto 3
Ivan
volte e
Bogner
l'avete capito.
on the
Poi tra le
Sojuz
22 e le
MS-16, while Kate
22:30
Rubins,
parliamo
Sergei
della
Ryzhikov, and
chiusura
Sergei
dei
Konspichkov
portelloni.
stay behind on the International Space Station.
Tra le 23:05
Should
e
be getting
mezzanotte e
close to
mezzo parliamo
today's
del lancio
hatch closure. That's
dell'Electron.
scheduled for
Chiaramente
3:10
gli
p.m.
orari
Central
possono
Time, though the
variare
time can
da
fluctuate
quando
a little
parte il
bit as the
razzo.
crew completes their
Tra
steps
l'1:20 e l'1:45
in
parliamo
preparation for
della
it.
separazione della Soyuz dagli SS. Alle 4:20 fino alle 5:15 parliamo dell'atterraggio della Sojuz MS-16, che vedremo meglio appunto alle 4:20, anche se non penso ci sarà qualcuno che mi segue. Ok, quindi torniamo a noi. Quella che state vedendo è la diretta di NASA.
On Space to Ground 1 regarding the camcorder.
Brian, fino a che ora stai in live? Allora, io starò in live fino a domani mattina alle 5. E solo che non ci sarò sempre a parlare.
Space to Ground 1 for the camcorder.
E gli orari li ho appena detti prima di quando parlerò.
Go ahead. Could you please check if camcorder is connected? We do not see the video.
Vabbè, e nel mentre vi spiego un po' quello che sta succedendo adesso. Allora, il 9 aprile 2020 sono partite 3 persone che si chiamano, adesso ve lo dico,
And the camera is on. Copy.
allora, che si chiamano Anatoly Ivanishin, un astronauta di Roscosmos, Ivan Vanier, un altro astronauta di Roscosmos, entrambi russi, e l'astronauta Christopher Cassidy. E appunto sono partiti il 9 aprile dalla Sojuz MS-16. Hanno fatto parte dell'Expedition 63, tutta l'Expedition 63, che è durata ben 6 mesi. Oggi è il 179esimo giorno che sono a bordo, quindi la missione, in quanto atterrano domani, durerà 180 giorni. Anatoly Ivanishin di Roscosmos era il suo terzo volo ed era il comandante, e insieme a Christopher Cassidy, lui era un ingegnere di volo che era anche lui al terzo volo, e Ivan Vanier, lui invece era al primo volo, era un novellino. Non scrivete il mio cognome in chat. Comunque ciao Gioia. Quello che state vedendo adesso è il Mission Control Center in Russia, a Korolev, di Roscosmos, l'agenzia spaziale russa. Ciao Astroterri e Giulia, che sei Lemma in realtà. E domani vengo a scuola dormendo, sì, molto probabile come cosa. Ciao Lanfranco.
Station Moscow on Space to Ground 1.
Beh, adesso che vedo Lanfranco mi viene in mente
4 camera settings.
subito di ringraziare il gruppo Astrofili Polesani di cui faccio parte, che sono i miei maestri e che mi hanno anche condiviso in questi giorni, hanno condiviso queste due dirette. La diretta di ieri sera è stata abbastanza scrausa, non ero tanto pronto e è stata una giornata abbastanza tosta. Avevo anche 2 interrogazioni stamattina, invece oggi ho dormito prima di mangiare, sono sveglio, sono pronto. Sveglio insomma. Sono sempre comunque un po' ritardato, però ci sono.
4 camera settings.
Oltre al gruppo Astrofili Polesani, come maestri ho i ragazzi dell'associazione ISA, Italia Space and Astronautic Associations, chiedo scusa per l'inglese, che insomma è un'associazione no profit che ha vari siti, tra cui un forum, forumastronautico.it, un sito di notizie, Astronauti News, un podcast che fanno il giovedì sera qui su YouTube, si chiama Astronauticast. E cosa mi dimentico? Beh, i siti principali li ho detti.
Moscow calling on Space to Ground 1.
Ieri sera ho visto, non è andata male come dici. Stasera hanno parlato della missione di ieri sera a SkyTG24. Grazie Terry.
Station Moscow on Space to Ground 1.
Ваш МКС, СУПу Москвы, ВСГ-1.
Station Moscow on Space Ground 1.
Still listening in, waiting for the hatch closure that should be coming up any time now. Crew on board is going to be splitting up, with Chris Cassidy, Anatoly Ivanishin, and Ivan Bogner heading home tonight on their Soyuz MS-16. Scheduled to be closing those hatches about this time, leaving behind Kate Rubin, Sergei Ryzhikov, and Sergei Kuzbechkov. Right now, the space station is passing 260 miles above the Philippines and will be skirting just along the coast of Japan in the next few minutes as it moves into the daylight portion of this orbit, hopefully giving us a little bit better exterior views, and if we get lucky, perhaps some interior views as the hatches are closed as well.
See the video now. Yes, we have just checked it out on a different camera, and we still have the same image. Okay, so you have installed a different camera, and you're still getting the same image.
Stiamo aspettando il collegamento tra Terra, Mosca, e ISS. Ciao Simone e ciao Emma con il suo account.
Still standing by for tonight's hatch closure. That was scheduled to take place about 3:10, about 5 minutes ago. That does fluctuate a bit as the crew works through the timeline, the steps that they need to do before those hatches are closed between the space station and the Soyuz. Also heard a little bit of talk between the crew and the ground about some trouble with the video that would normally give us the views that we would see inside the space station of hatch closure. Stand by and hope that they're able to get that sorted out, but we'll continue giving you updates as we get them on the status of the hatch closure.
Иркуты ответит СУПу Москвы.
Irkut, this is Moscow.
Ваш МКС.
Station Moscow on Space Ground 1.
Ваш МКС ЦУПа Москвы, ВСГ-1.
Station Moscow on space to ground 1.
Иркут. Ваш МКС. Ответьте ЦУПа Москвы.
Irkut,
Station Moscow on space to ground 1.
Nel mentre vi dico che l'ISS ha qualche problema al generatore di ossigeno che ogni tanto si rompe e lo aggiustano, si rompe e lo riaggiustano.
Ваш МКС ЦУПа Москвы, ВСГ-1.
Station Moscow on space to ground 1. Sergei Ryzhikov, please respond.
Иркут, ответьте ЦУПа Москвы, как нас слышно? Ваш МКС ЦУПа Москвы.
Station Moscow on space to ground 1. Go ahead,
Сергей,
Sergey.
по настройке камеры.
For camera settings. Yes, go ahead on space to ground 1.
ВСГ-1.
Space to ground 1.
Аудио. Страница.
Video and audio ODF, page 176. Could you please implement step 3? Send the commands per your onboard instructions.
Приняли.
Did you copy? Please repeat the pages. Could you please repeat page numbers? 176. 176.
Пункт номер 3.
Step 3.
Allora, mentre aspettiamo che che arrivi il collegamento
Once Chris Cassidy,
all'ISS, vi
Anatoly
mostro il
Ivanishvili, and
lancio di
Ivan Wagner
queste
do
tre
close the
persone
hatches. That'll be the next step
che
before they then undock
questa
from the
sera
International
torneranno.
Space Station. That's scheduled for 6:32 p.m. Central tonight.
Anatoly, one more time.
176, step 3.
Step 3. Which page?
What page is it?
Page
10,
10.
10.2. And this is sheet
Video,
Ecco, questo era il
audio.
lancio.
Video and audio of
Thrusters
SM.
are working nominally and the vehicle is nominal.
Service module.
Crew still troubleshooting the video camera that normally would provide us a view of tonight's hatch closing. That was scheduled to take place about 10 minutes ago, but we're still waiting for the crew to get those hatches closed. Once they do, again, that'll be the first step on tonight's journey
Mentre la
for
partenza
landing in
dell'altro
Kazakhstan
razzo
at
sarà
9:55
alle
p.m. Central Time.
23:17 e
Once
non
they've
alle
undocked, they will have
23:14.
spent 196 days at the International Space Station over the course of Expedition 63. Chris Cassidy was commander of Expedition 63 and just yesterday handed over the keys to the space station to the Expedition 64 commander, Sergei Ryzhikov. Ryzhikov arrived at the space station just a week ago, along with NASA's Kate Rubins and Roscosmos's Sergei Kuzbirchkov.
Please close the hatches for the specified time. It must be done. Copy.
Иркуты ответит СУПа Москвы.
Irkut, this is Moscow.
Экипаж МКС СУПа Москвы.
Station Moscow.
СГ-1.
On space to ground 1.
Команда на закрытие люков. Сейчас.
Send the command to close the hatches now.
Sono un po' in ritardo, infatti doveva avvenire alle 10:10 e invece 9. Questione di pochi minuti
Экипаж
comunque.
МКС СУПа Москвы.
Station Moscow on space to ground 1.
Отзовитесь. Мы ждем квитанцию.
Please respond. We're standing by for your confirmation.
Crew on board the space station continuing to have trouble with the video camera that would normally be providing us video of tonight's hatch closure. The team on the ground in Moscow just telling them to go ahead and forego that for the night so they can get on with the actual process of closing the hatch. So we will be standing by to hear the updates from the teams on the ground as they watch those watch
vi dico che
their systems
le
that they
bandacce
can
nere
see
qua
here
a
on the ground
lato
for
non è
confirmation that those
colpa
hatches are
mia,
closed, and
sono
we'll
i
let you know
russi
as
che
soon as
sono
we've
ancora
got
in
that.
4 terzi.
Hatch closure. The team on the ground in Moscow just telling them to go ahead and forego that for the night so they can get on with the actual process of closing the hatch. So we will be standing by to hear the updates from the teams on the ground as they watch those
Vi
watch
dico che
their
le
systems that
bandacce
they can
nere
see
qua
here
a
on the ground
lato
for
non è
confirmation that those
colpa
hatches are
mia,
closed, and
sono
we'll
i
let you know
russi
as
che
soon as
sono
we've
ancora
got
in
that.
4 terzi.
Иркуты СУПа Москвы. Как нас слышно?
Irkut, this is Moscow.
Nel mentre le 4 persone che mi stanno guardando le
Go ahead and
saluto
space
e
to ground
vi
1.
abbraccio virtualmente.
Квитанцию закрытие.
We're
Se c'è
standing
qualche
by for your
domanda fatemela in
confirmation
chat e
about
se
hatch
so rispondere vi
closure.
rispondo molto volentieri.
Экипаж люк закрыл, закрываем функционный люк.
Crew has closed the hatches and we're closing ISS hatch now. Copy.
And we do have confirmation here on the ground now that the Sojuz side of the hatches are closed. That took place 3:24 p.m. Central Time, as the the Sojuz and station were flying 262 miles above the Pacific Ocean
Il
east
portellone
of
lato Sojuz, da
Japan.
quel che ho capito, è chiuso.
Again, the Soyuz
È
side of the
stato
hatches are
chiuso.
now closed. We're waiting to hear also that the space station side are closed, but that is a good step forward on tonight's timeline.
Solo che non abbiamo il video.
Иркут от СУПа Москвы. Как нас принимаете?
Отвечаем. Да, хорошо.
Мы так понимаем, что люк БОСу закрыт, да?
Люк БОСу закрыт. Экипаж.
Moscow station on space to ground 1. ISS hatch is now closed.
Принято, спасибо.
Copy, thank
We're
you.
working per page.
Принято.
Inaudible.
Репортаж по выдаче команд.
Please
And
report
please-
on the commands you sent.
Almeno se ho
Will do.
capito bene.
And that confirmation that hatches on both sides of the vehicles are now closed, but the
Sì, ok,
Soyuz
sì, ho
hatch
capito bene,
closing
sicuro
officially
al
coming in at
100%
3:24
adesso.
p.m. Central, and now the space station hatch is closed as well. That again is the first step of tonight's journey with Expedition 63 Commander NASA astronaut Chris Cassidy on the Soyuz side of the hatch, along
Nel
with
mentre vi
his
mostro una
crewmates
foto
from Roscosmos, Anatoly
di loro
Ivanishin and
prima,
Ivan Wagner, now ready to undock from the space station and begin making their way home for landing at 9:55 p.m.
che
Central
prima hanno
Time.
caricato la Sojuz con tutti i rifiuti, roba sporca, diciamo i bagagli,
We
hanno
are
fatto i bagagli
activating
e si sono
F-15.
fatti questa foto. Al centro vedete, mi sembra sì,
232730.
Anatoly Ivanishin,
But we
di qua
had a lot of
vedete
interference.
l'altro russo, come si chiama? Perché ho problemi di memoria. Sì, Anatoly Ivanishin,
D7
Ivan
command.
Wagner
Oh no,
e
not yet.
l'americano Christopher Cassidy.
232755. Gas 7 command. Copy. Indicator for hatch closed is illuminated. D8.
Ok, è tutto molto
Yes.
più noioso di quello che pensavo.
2328.
Se riuscite a resistere, resistete fino alle
D8 command has been
11:17 che
sent.
lì c'è un lancio bello da vedere.
Copy. S11 is not illuminated. S16 now. 232838.
Now that we have confirmation that the hatches between the two vehicles are closed, and again the Soyuz hatch closure came at
Chiuso anche il
3:24 p.m.
portellone
Central
lato
Time,
Sojuz
we'll be
e
taking a
lato
break while
ISS,
leak checks are
scusate.
performed until closer to the time for the Soyuz undocking from the station's Poisk module. The slight delay in the hatch closure is not unusual and won't affect the schedule for tonight, so we are planning for an undocking at 6:32 p.m. Central Time, which means we are going to be planning to come back
Ecco qua,
for our undocking coverage at 6 p.m. on the dot.
ecco qua la timeline.
After that, the Soyuz will perform a few systems tests and fire its thrusters to move away from the space station and out of view, so we'll take another break and come back at 8:30 p.m. Central for the Soyuz's 5-minute and 20-second deorbit burn. That's scheduled for 9 p.m. Central Time, and from that point we'll stay on until the crew has landed and is out of the vehicle.
Ecco,
Landing
vedete?
again is scheduled for 9:55 p.m. Central Time.
Ecco,
So
questo è
that is
quello
the
che vi ho
lineup
detto
for
all'inizio, diciamo la
tonight. So we
timeline.
hope you'll stick with us and come back at 6 p.m. Central for the undocking coverage of Soyuz MS-16. This is Mission Control Houston.
E questo è il meraviglioso logo di NASA. Ok, allora, i portelloni sono stati chiusi e da Twitter mi arrivano notizie da più persone che hanno avuto qualche problema, non si sa che problema, però hanno avuto un problema. Non grave ovviamente, perché altrimenti non avrebbero chiuso i portelloni, ma penso problemi tipo con la videocamera. E quindi noi ci vediamo verso le 11:10 verso le 11, che alle 11:17 partirà questo razzo di Rocket Lab. Ci vediamo dopo.
The Cold Atom Laboratory is in many ways the coolest thing and the coldest thing we've ever done on the International Space Station. It is allowing us to investigate cold quantum gases and make breakthroughs in areas of physics that up until now have been unavailable to us.
NASA built the International Space Station to do the kind of research that we're doing in the Cold Atom Lab. This is the first time we're able to study this fifth state of matter in space.
Bose-Einstein condensation is an amazing feat of engineering in itself, but this type of physics is difficult to do in ground-based experiments. And so doing this in microgravity is going to allow us to really see what's going on. So you have something cool, how do you make it cooler? You put it in space.
Our ability to study cold atoms is really going to advance our knowledge in areas that will help us in quantum computing, quantum communications, and learn even more about gravity and how it interacts in our universe.
There is orange soil. Well, don't move it till I see it. Hey, it is! I can see it from here. It's orange. Wait a minute, let me put my visor up. It's still orange. Sure it is. Crazy. Orange. I've got to dig a trench, Houston.
Rieccomi qui, buonasera a tutti e quasi buonanotte. Allora, ci siamo quasi, eh? Allora, adesso ci sarà il lancio di questo razzo, anche se nel mentre da mostrarvi ho una cosina che riguarda quello di cui stavamo parlando prima. Cioè, Chris Cassidy ha messo queste foto qua su Twitter e lui è Chris Cassidy, l'astronauta americano, in cui dice che si sta mettendo la tuta per il ritorno. Quindi in mancanza di immagini live abbiamo almeno questa cosa qua. Ok, allora, nel mentre vi dico che allora vi dico cosa volerà in questa missione. Allora, la missione è commissionata da Planet e Canon, quella che fa le videocamere, e verranno rilasciati 10 satelliti in 10 orbite diverse, 10 nanosatelliti direi, in 10 orbite diverse. E è il 15° volo del lanciatore Electron e partirà dalla Nuova Zelanda e dal pad Launch Complex 1, complesso di lancio 1. A bordo tutti i 10 satelliti sono per l'osservazione terrestre. Infatti il nome della missione è In Focus, cioè a fuoco. E ci saranno 9 super DAV di Planet e ad un'altezza di circa 500 km. E poi ci sarà il satellite più grande, diciamo, che si chiama CE-SAT-2B, che è di Canon, quella che fa le videocamere, proprio lei, e commissionato da Spaceflight Inc. E insomma a bordo ha un medio piccolo telescopio e una fotocamera sensibile, e una fotocamera molto sensibile direi. L'Electron con 15 voli diventa il secondo lanciatore più lanciato dall'America nel 2020. Adesso vi mostro una foto dei satelliti a bordo che è stata postata poco fa da Rocket Lab. Rocket Lab è quella che costruisce il razzo, ricordiamoci. Eccoli qua. Tac. Ok, la novità direi, la cosa più importante di questi satelliti, di quelli piccolini dei 9 satelliti della Planet, non sono i satelliti in sé, ma i suoi, oh mio Dio, come si può tradurre? Il suo case, ecco, i suoi deployer, cioè i contenitori che li contengono e che apriranno lo sportellino e li lanceranno fuori, perché sono i più leggeri che ci sia in commercio di questo tipo qua. Quindi qua sotto vedete il satellitone della Canon e quelli di Planet. Anche qua vedete 3, 3 e 3 che fa 9 e 1 che fa 10. Siamo in attesa della diretta di Rocket Lab. Boh, dai, questa sera sono felice di quello che sto facendo. Per ora spero di questa notte quando vengo giù di non sparare troppe cavolate. E spero di non sparare troppe cavolate. Che come diretta sta andando bene. L'unica cosa che mi ha dato fastidio è stato prima che non si è visto niente perché era bellissimo. Bellissimo vedere. È triste anche perché vedi delle persone che, oddio, in questo caso, che ci sono le expedition in questo periodo un po' sballate e sono stati a contatto poco con gli altri tre, ma normalmente dopo 3 mesi che stai a contatto solo e solamente con quelle 3 persone, li vedi, non dico piangere, però insomma non li vedi assolutamente felici. Nel mentre dalla chat ditemi come mi si sente, se mi sentite basso, alto e via così. Ok, abbiamo un ulteriore ritardo per questo lancio. Questa sera proprio la diretta, io sono bravo e non mi vogliono fare andare bene fare una diretta decente e il razzo partirà a mezzanotte e 2 minuti. Al posto delle 11:17 si va a mezzanotte e 2 minuti. Ci sentiamo tra poco. Nel mentre l'astronauta Chris Cassidy, che era sugli SS, prima di entrare nella Sojuz, si è fatto ben 7 provette di sangue e, indovinate, se ne dovrà fare un'altra perché NASA ne vuole 8 da analizzare a terra. Quindi poverino gli tocca di bucarsi per una provetta. Ma poi porco cane, 8 provette, rimane senza sangue questo, poverino. Ma boh, io sarei già svenuto tipo 70 volte.
came off the surface of Bennu, and that has all now cleared. So coming up, we have a series of spacecraft activities that's going to help inform us on how much sample we've collected and give us a little more insight into the spacecraft subsystems. Our first event will actually happen tomorrow, and we've got an animation showing what sample imaging looks like. So we're able to articulate our arm and the tag SAM head over our SAM cam, which will take a series of images. We are hoping that we can see lots of sample entrained inside the sampler head. We'll also be able to see evidence of sample on those contact pads, any dust that may be on the arm or the sampler head. So that'll be the first activity to help us determine just how much sample we've collected. Then our second activity is our sample mass measurement, and we have a second animation showing that. We'll extend the arm and spin the spacecraft. Now we've done this activity before, so we've got a pre-tag, and this will be our post-tag. That way we can compare the moment of inertia, which will help us determine how much mass is actually in the sampler head. We do also have a spacecraft checkout planned early next week, where we'll get an opportunity to do some engineering checkouts of some of our redundant components as we continue to trend the spacecraft, which looks just absolutely amazing after what we put it through yesterday. I'm going to turn it back over to Nancy.
Okay, thank you, Sandy. We're now ready to take questions from the media by phone. Operator, please patch through our first question.
Thank you. We will now begin the question and answer session. If you would like to ask a question, please press star 1, unmute your phone, and record your name. Your name and your associated press is required to introduce your question. To withdraw your question, please press star 2. Again, to ask a question, please press star 1. The first question comes from Marsha Dunn from Associated Press. Your line is open.
Congratulations. I heard Mr. Bridenstine say that contact was actually 15 seconds, which is a little longer than anticipated. I guess that's a good thing, right? And when do you think might be the soonest that you can declare success and have at least a pretty good hunch that you got what you were going after? Thank you.
Great question. I'll tell you, the 15 seconds I got in open media reports, so I'll let probably the experts tell us exactly what they know occurred. If Dante, if you'd like to take that.
I think I'll let Sandy answer that. She's our spacecraft engineer and analyze the telemetry that gives us that information.
Yeah, so our preliminary analysis of the telemetry shows that we were in contact with the surface for about 6 seconds. And our collection time, about 5 seconds. It takes just about a second after we make contact before that gas bottle is fired, which is that 1 second difference.
So I read an article and it said 15, so I guess I was wrong. Marsha, I apologize.
Oh, that's quite all right. And when do you think the soonest might be that you'll have, if not an exact measurement, a pretty good idea that you that you can that the pressure might be down?
Yeah, so we're continuing. Oh, go ahead.
I just was going to say I'll defer.
Oh. Yeah, so we're continuing to analyze all the engineering data that we have on the ground so that we can better correlate all the data sets together and get an exact timeline of everything that happened here on the surface, how fast the bottle pressure went down, and all of that is being looked at very closely here as we look to analyze the sample we've collected. So hoping to have good solid timelines here in the next few days.
And I think the sample mass measurement is planned for Saturday.
Yes.
That's when the spacecraft will execute that maneuver, and the team needs some time to analyze that information. And so, Sandy, remind me, when do we expect the final report from GN&C on that value?
Yes, we are expecting a final sample mass measurement report on Monday.
Thank you.
Operator, we're ready for the next question.
Thank you. Tariq Malik of Space.com, your line is open.
Hello. Thank you so much for the update here, and congratulations, as it appears, so far on the sampling. My question is for Dante. I'm just curious. You know, it's been a long road reaching Bennu with OSIRIS-REx, and you know, very unexpected circumstances to try to actually collect samples of the asteroid last night. And I'm wondering, kind of what you and the team are feeling or were feeling when you saw those images come down after, making lots of precautions for, the ongoing pandemic or, every other challenging situation that we're facing right now. I'm just curious kind of what that tone was like when you saw those images there.
Of course, that's a great question. So we stayed here at the MSA at Lockheed Martin fairly late last night. I stuck around to get to the point where we made the high gain antenna contact with the spacecraft, and we started to get the initial telemetry back down. And we actually had a spacecraft status meeting about 9:30 p.m. here local Denver time. I got back to my apartment here in Denver around 11 o'clock last night, and I couldn't sleep. As you could imagine, I knew we were expecting those images around 2 a.m., so I got on to the chat. We have a chat feature with our science team. And the images get processed through the Science Processing and Operations Center in Tucson, Arizona. So our imaging scientists at U of A were busy downloading and analyzing the images, and the science team was analyzing them in real time through the chat feature. And we were producing the animated GIFs, looking at various aspects and timing in the sequences. And as you can imagine, the chat was filled with emojis and wows and all kinds of celebratory remarks. Science never sleeps in these kinds of conditions, so we immediately started assessing how far the TAGSAM head penetrated into the surface. Overall, the mood was jubilant because everything looked better than we expected. And I could say the best piece of information we got was that TAGSAM head looks like it pushed down into the asteroid surface. With all the laboratory testing that the team at Lockheed Martin did here to assess TAGSAM performance, some of the best test results occurred when TAGSAM gets down underneath the surface just a little bit and is able to fire the nitrogen gas with regolith all around it. So I know we're going to hear at another event later today from our TAGSAM scientist, Bo Bierhaus, so you can look forward to that. I know he is literally over the asteroid at this point with excitement about how his device has performed, and that spread throughout the entire science team. The only thing I'm looking forward to is maybe being able to sleep tonight knowing that we got a job really well done.
Thank you, Dante. Operator, next question.
Thank you. Stephen Clark of Space Flight Now, your line is open.
Hi, congratulations on the success. My question's for Dante. Are you at any point in the next few days or few weeks expecting to get any images inside the TAGSAM to see maybe an image of the sample that you collected? And I was wondering also if you have any estimate of the error bars that you'll have on your mass estimate from the spin maneuver this weekend. Thanks.
Yeah, thank you, Stephen. Absolutely. So I think the next major flight activity for the spacecraft is using the SAMCAM to image the TAGSAM head. Sandy showed an animation of what that sequence looks like just a little bit earlier. We will be able to look at the base plate. We'll be able to look at those contact pads. Based on what I've seen so far with the asteroid surface crushing underneath the TAGSAM head, I'm anticipating that we see contact pads coated in dark black asteroid regolith. But of course, we need those images down to verify that. We hope to be able to see inside the TAGSAM head, but that's not guaranteed. For one thing, the TAGSAM head may be so full of regolith that no light is able to penetrate inside that. I'm going to take that as a win. But it does require just the right lighting conditions for us to see inside that TAGSAM head, and we don't require that to take place. But those images will be acquired tomorrow. Downlinked over the next day or so, and obviously we'll be analyzing those intently. Remind me what the second part of your question was?
Yeah, just how precise is this moment of inertia measurement going to be in terms of estimating how much mass, how much sample you collected?
Thank you. So the mission requirement is to bring back 60 grams of regolith. And we have done a lot of work with this team to determine what the precision on that measurement is. And in fact, we rehearsed it during the checkpoint rehearsal and the match point rehearsal. Right now, we're carrying a 3 sigma uncertainty of about 20 grams on that measurement. So we've actually worked through this with our stakeholders at NASA headquarters, and 80 grams is kind of the magic number. If we see SMM coming in At 80 grams or higher, we have a 90% confidence of having collected 60 grams of regolith. So that's a key number that I'm looking for. If it's below that, it's a conversation that we have with the team, with NASA headquarters, Dr. Zurbuchen, to decide what do we think the best path forward is. But 20 gram 3 sigma is the number that we have agreed to with the agency.
Thank you. Operator, next question.
Craig Smith of KGUN Tuscan, your line is open.
Thank you. A question for Dante. How is it decided just which organizations get which share of the collected material? What share do you expect University of Arizona to get? And please give us an idea of, I guess, the researchers who are lined up to get a look at that material.
Thanks, Craig. Great to hear from you. So first, the sample belongs to NASA and really to the American taxpayers. So the only transfer of sample that's been authorized is that 4% goes to the Canadian Space Agency. That's by mass. And then 0.5% goes to the Japanese Space Agency to reciprocate for their contributions to the success of this mission. The science team, which is what I lead, will be allocated 25% of the return mass and also 25% of the contact pads for our scientific analysis. But in all cases, that material still belongs to the agency and is under the control of NASA. And it's allocated to me and to the science team through what's called a loan agreement. But all that aside, we're basically planning right now on analyzing 25% of the return mass. And a lot of my activity lately has been in writing my sample analysis plan. And this has been really exciting to get to this stage in the program where we can lay out in detail the different analysts that will be looking at the material. Of course, the University of Arizona will be a central organization in the analysis of the return material. We've got new laboratories that we've installed over the last couple of years, a new instrument being developed right now that we're really looking forward to analyzing that material with. But the science team really spans the entire globe. We've got key organizations in the United States like NASA's Goddard Space Flight Center, Johnson Space Center that are going to play central roles in the sample analysis program. And then we've got team members in Canada, in Japan, and Australia, throughout Europe that are going to be involved in the program as well. And we'll be able to talk about that and roll that plan out over the next year or so as we finalize the details on that. But I can tell you, based on what I've seen today, we're looking at hopefully a lot of material and a lot of great science coming out of the sample analysis phase of OSIRIS-REx.
Great.
Great. Thank you. Congratulations.
Operator, next question.
Leo Enright of Irish TV, your line is open.
Thanks very much for doing this, and congratulations. A couple of questions. One for Rich Burns. You mentioned the possibility of maybe less of a sample than you had hoped for. Now, I realize this is unlikely, but if you found that you had less of a sample than you expected, is there a plan B? Can you go back, or is that it? And also for Dr. Loretta, can you talk a little bit about the rocks that we saw? You mentioned that the rocks seem to fragment very easily. What can you say about the nature of these rocks, and whether, for instance, if I picked one up, would I be able to crumble it in my fingers?
Thanks very much for that question. It's a great one. If we for some reason decided not to stow this sample, if we determined the mass was not sufficient, that we wanted to go back, we can in fact go back. We have 3 nitrogen bottles, which allows us to touch the surface 3 times. Of course, we've disturbed, as you saw in the animation, or not the animation, but the images that Dante showed, we've disturbed the surface of Nightingale in a radical way. So we won't be going back to Nightingale, at least for our second attempt. We would go to our backup site, which is called Osprey, which is a near equatorial site, and we're prepared to do that in the mid-January timeframe. I'll turn it over to Dante to answer the second question.
Yeah, the rocks on the asteroid surface have turned out to be fascinating scientifically, and the team has done an amazing job processing all of the remote sensing data that we've acquired starting in late 2018 and throughout 2019. I can answer the question that, first of all, the surface seems to be dominated by two distinct rock types. We see a very dark, kind of hummocky rock, which looks like the one that we crushed underneath it. And from recent analysis using the thermal data, how the rock heats up and cools off, we actually inferred that these rocks might be very weak compared to what we're used to dealing with here on Earth. And most exciting, I think, for me as a sample scientist, very weak compared to the meteorites that are currently in our collections here on Earth. So I think what we've seen is that our meteorites are possibly a biased sample, that they're only the most sturdy and strong material that survives passage through the Earth's atmosphere. And it looks like the material that dominates the surface of Bennu might be much more fragile and friable. And with this interaction of TAGSAM with the asteroid surface, that seems to be playing out. I can tell you the science team is already excited about the possibility of getting a direct strength measurement through detailed analysis of this image sequence, especially these two images right before and right after contact. The second kind of rock that we've seen on Bennu is a little brighter. It tends to be shot through with bright white veins or white inclusions that we've identified as a mineral carbonate. This is a mineral people are probably familiar with. It forms a kind of white crud around your faucets and sinks if you live in an area with hard water. It's basically an evaporite, and those rocks seem to be a little stronger, probably because of that material that has cemented them together. We do see maybe some hints that there was some of that brighter material, smaller fragments of it, underneath the TAGSAM head, but the team is going in for detailed analysis to determine if that's in fact the case. And then I'll just add, mineralogically, we've done a pretty good job understanding what these rocks are made out of. They're definitely dominated by hydrated minerals, that is, clays that have water contained in their crystal structure. That's very exciting scientifically. We've also seen an iron oxide called magnetite, abundant organic material, particularly carbon-hydrogen bonded material, which is really what this mission is all about, bringing back home, and then that carbonate material that I mentioned earlier.
Thank you. Operator, next question.
Nova PBS, your line is open.
Hi, everyone. Firstly, congratulations. This is just super exciting, and I know that we're all, to use your point earlier, over the asteroid for all of you guys. And so I'm wondering, from the images that you have currently, I know during Monday's press conferences there was a lot of conversation about diversity in regard to the size of the sample pieces as well as material and everything. So is there any clue from the images that you have currently that we have a good diversity of really small pieces, or maybe pieces closer to that 2 centimeter mark, and maybe of different types of material as well? I guess that's for Dante, or really anyone who can answer.
Yeah, I'll take that. I can say just within the past hour or so, I got the analysis from my image processing team about the exact location where we think the TAGSAM head made contact. So I haven't had time to process that information. I know that team is busy analyzing that. But from that quick look assessment, it does appear that we made contact with an area that had already been mapped out and verified to contain abundant sampleable material. Rich mentioned the imaging resolution during the Recon-C characterization of Nightingale, where we got down to that 4 millimeter per pixel scale. So that this region does look really sampleable, lots of small particles, and then the fact that the material just crushed underneath the TAGSAM is just going to add more smaller particles for us to collect. But I don't want to answer the question just yet about the diversity of the rock types there, because the team is still processing that right up to the beginning of this media briefing.
Operator, next question.
Thank you. Let's see. And Ryan of Arizona Republic, your line is open.
Thank you. I wondered if you could explain a little bit more about how you will measure how much sample you've collected besides the possibility of images.
Yeah, so we've got a sample mass measurement activity. So we've been practicing this, as I think Dante or Rich mentioned, around our checkpoint and our match point burns, or activities where we can extend the arm and rotate the spacecraft, and we can measure the moment of inertia. And by doing that before tag and doing that same activity after tag, we can take the difference in those measurements to estimate the mass. So we did perform our pre-tag sample mass measurement activity about 10 days ago, and we'll do our post-tag one this Saturday, and we'll be able to take those two measurements and look at the difference of them to get that estimate of how much mass we believe is inside of the tag SAM head.
Operator, next question.
Thank you. Chuck Fields of Your Space Journey, your line is open.
I thank you, everyone, for taking my call, and just congratulations to the entire team. I was just wondering, what are the reasons for waiting until January for a second collection attempt? And if a third attempt is required, have you determined when will that take place and at which site?
So, yeah, great question. The reason that we would do a second attempt at Osprey in January, as you saw, we're backing away from the asteroid right now. And I mentioned that we'd be about 80 kilometers when we make a maneuver to arrest that drift away on Friday. That will put us on a trajectory that goes to a waypoint where we can re-enter orbit. You see the orbit in that animation that was just shown is a tenuous trick to get into. Bennu is only 500 meters in diameter, so its gravity field is extraordinarily weak. Just getting into orbit takes weeks of maneuvering to get there, and we also have to phase the orbit appropriately so we depart for the next sample collection attempt at the right latitude. All that takes weeks of planning and preparation. We also have to prepare the spacecraft to tag at a different site, which involves generating the spacecraft commands, testing them, and so forth. So that runs out the timeline to January. And then the third sample attempt would be to be determined date, most likely in March, when we'd be attempting a third attempt. But it largely depends on what happens at Osprey. If we were to go to Osprey in January and wave off, abort for some reason, and not touch the surface and not disturb Osprey, as we've seen the dramatic disturbance of Nightingale, we go back to Osprey. If we did disturb Osprey, that's a contingency that we would have to either perform more reconnaissance over one of the two, Nightingale or Osprey, or follow some other path. And the reason I'm saying that is we use optical navigation to get down to the surface. So much as you're driving to some location in your local town and you know where you are, where a gas station is or a supermarket, the spacecraft knows where it is by features on the surface. So groups of rocks that cast shadows or just clusters of rocks that have distinctive features are recognized by the spacecraft in its imagery as it descends, and it knows where to go. It knows to take the right turn at the supermarket to get to the center of the site. So once we disturb all those features, that means we're going to need to take more images and build a new set of feature catalogs to teach the spacecraft where the grocery store is.
Great. Thank you, Rich. Operator, next question, please.
Joshua Ortega of Corncut News, your line is open.
Thank you for having me, and congratulations to everybody involved in this mission. What was one of the biggest discoveries that you made in making contact with the asteroid Bennu that you didn't expect? And my second question is, what is the future applicability for future projects with some of the technology utilized on the spacecraft?
I guess I'll take the discovery question. I can say we've had the data down for just a little over 13 hours, so the discoveries are still to come. What I was looking at this morning, 2 o'clock here, Denver time, after being up through a very exciting event, was how does it look in terms of getting the sample? So the science is something that we're going to think of down the road a little bit. But I can tell you that I was hopeful that the surface was going to be soft and crushable, and that was confirmed by our contact with the TAGSAM and analysis of the images that we've seen here so far. So that is really good news. So I'm pretty focused on sampling success right now. I will tell you the science team is busy in a couple of different areas. They are working through a detailed analysis of this entire image sequence, along with additional data from the spacecraft guidance, navigation, and control team about exactly what happened when the spacecraft was in contact for those 6 seconds. That'll tell us a lot about TAGSAM performance, and there's also follow-on science that we'll be able to do with that information. But right now, I would say the big discovery is that it looked really sampleable, that the TAGSAM head pushed into the surface, and that it was in a very good position when that gas fired to collect a lot of material. So we still have all the confirmation activities that Sandy walked us through earlier in the briefing to verify all of that. But the trend right now is that we have sample and that we were successful here based on analysis of this image, this set of images.
Yeah, I'd love to speak to the second part of that question if possible. Yeah, so the question was what technologies on board the spacecraft can enable future missions, and I think one of the most amazing technologies is the optical navigation system I talked about, what we call natural feature tracking, and it has actually an amazing story. The spacecraft was originally designed to use a LiDAR to measure the altitude to the surface as its primary sensor to do the navigation to the surface. But natural feature tracking or optical navigation was added around the critical design review time period in order to have a backup solution. And as I mentioned, what it does is recognize features on the surface of the asteroid and then update its own sense of its position so it knows where to go in the future. Now, this technology being added late in the game was done by our colleagues at Lockheed Martin, and it was an amazing accomplishment amazing engineering accomplishment, and one of the most amazing performances of the system yesterday was just how well that system performed relative to our simulations of it. Optical navigation systems are notorious for not performing as expected, and this one performed exactly as expected and allowed us to hit that center of the target within a meter. So our colleagues at Lockheed Martin deserve a lot of credit for that. And how that gets
Buonasera a
applied in the future
tutti.
is it will
Nella
allow
diretta di Nada TV,
for
se
autonomous
qualcuno stava guardando,
navigation
sono
for other
uscite le prime
space
immagini
missions, to small bodies or not,
da Osiris
for
Rex,
landing
la sonda che ieri sera ha
or
catturato dai campioni
navigation
da un
around
meteorite, e
hazardous
il
or
lancio
non-hazardous
della
environments.
Rocket
So
Lab
I don't know if Sandy, do you want
è
to follow on
stato
to that?
appena rinviato a
Yeah,
domani.
definitely. I would
Quindi noi ci
for
vediamo
sure
più
point out
tardi
natural feature tracking
per
as a
la
capability that I
separazione.
can see can be useful in the future. I'll also point out that TAGSAM is new technology flying on board the spacecraft, and you can see that going forward for future sample collection, sample return missions.
And one more quick question for the NASA representatives. What is this? Is this the first time working with the University of Arizona? And what does this say about the school and future projects with the school as well?
It's Thomas here, head of science. No, this is not the first time. I think of the University of Arizona, and it's kind of partner university up the street, so to say, Arizona State, to really be kind of meccas of planetary science and exploration. The University of Arizona has had the principal investigator of multiple missions and continues to compete very well in many different areas. And really, especially in planetary science, the University of Arizona is one of the top leaders in the whole country.
What did you say about Arizona State University as well?
Arizona State University, frankly, is if you just lined up kind of the top universities in planetary science, both the University of Arizona and Arizona State rank in the top part of such a ranking list. So Arizona State also at this moment in time, for example, has a principal investigator of a discovery mission called Psyche. There's instruments that are being built there for other missions. So also Arizona State is a really critical partner for NASA in this and also other disciplines.
Thank you. Thank you very much for your time.
Thank you. Operator, next question.
Mark Sass, Magazine, your line is open.
Hi, thanks very much for taking my question, and congratulations to everyone. I just had a couple of questions on the series of images that was released and the really impressive rubble cloud that this kicked up. Just wondering if you're able to glean anything scientifically about the surface material from the dynamics of that cloud and the rocks and particles that make it up. And then obviously you expect it to make a mess, but what kind of safeguards or system checks are in place to make sure that the craft wasn't damaged by that? And then finally, I was just curious, what is the time step between those images? So what's the effective frame rate of that video?
So I'll answer the imaging questions, and I'll hand it over to Sandy for the safety assessment of the spacecraft. So right to your final question, those images are about 1.25 seconds apart. So the first version I showed, which was the larger image sequence, was sped up by quite a bit relative to that frame rate. In terms of the debris cloud, absolutely. It actually is kind of impressive. The fragments that we see flying around, there's some pretty large particles. One of the things the science team has already started doing is tracking the trajectories of the particles as we see them mobilizing across the images here. They're going by pretty fast right now, but obviously we're slowing those down, identifying individual particles. There's other images, too, that we collected with a different camera called the NavCam, the one that was used for the natural feature tracking. I was getting a quick look at those right before the media conference. Those are fresh off the spacecraft, so we're still processing those and analyzing those, and those will be released a little later on this week. But those give us a wider field of view as well, so we're kind of getting this great point of view of the SAMCAM contacting the asteroid surface and all the particle debris that we see. And then we have the NavCam 2, which is off-pointed a little bit in a wider field of view, so they're going to be a nice image pair. And I think the final thing to point out is that the initial ejection of particles actually comes from the TAGSAM gas as it was blown down through that sample collector head. But you got to remember, we were only in contact with that asteroid for 6 seconds. After that point, the back-away thrusters fired, and those kicked up a second set of cloud and debris. So we're still disentangling that whole history. What was liberated by TAGSAM, what was kicked up by the back-away thrusters, and the NavCam images are pretty fresh right now on the ground, so we got a quick look at those. They're very impressive, just to get everybody excited, but we're not ready to release those because we haven't really had a chance to process them ourselves quite yet. And I'll hand it over to Sandy about the safety assessment.
Yeah, so the spacecraft was designed for this. We knew when we made contact that we were going to stir up a lot of regolith. There was a large backscatter study done during development to make sure that we would keep the spacecraft safe. Now, just by monitoring this spacecraft over the last close to 24 hours now, we've been able to see a number of components, and we're trending, as our subsystems do throughout, making sure that things are going as planned. And they're not seeing any changes in their measurements. Now on next week, early next week, I believe Monday, we'll be doing a spacecraft checkout where we'll get a chance to take some star camera images on both of our primary tracker and our redundant tracker, and we'll get to do some other engineering activities to better inform us if we've had any sort of degradation on the vehicle. And we're trending, as our subsystems do.
Next question.
Making sure that things are going as planned. And they're not seeing any changes in their measurements. Now on next week, I believe Monday, we'll be doing a
Hi, thanks for taking my question.
We'll get a chance to take
I was wondering if you knew if any of the regolith that got disturbed, any of the stuff that got tossed up into space around the new would end up at Earth, and if maybe you just created a new meteor shower.
Next question.
Hi, Lisa. I'll answer that one. I think you read my mind. I certainly have been thinking about that. We have thought about that, as I mentioned yesterday, and we've talked about for quite a while on the mission. Bennu is already kicking particles off the surface, and one of the things that we are doing is monitoring for a meteor shower, which would occur in the southern hemisphere in the third week of September, which is when Bennu's orbit crosses that of the Earth's orbit. We actually had data that we just recently received from that meteor campaign, and we're still processing that to see if there's maybe a small signal, but maybe not, of natural Bennu meteors. So that idea is already in place. That kind of study is something that we're already pursuing. So I'm going to go back to that team that's responsible for that investigation with your exact question. I haven't had a chance to ask them that. I didn't dare to hope that we would kick up as much debris as we're seeing here. So I'm not sure. But it's definitely a question I've asked myself, and we've got team members who are thinking about that based on Bennu's natural particle ejection events. So it is a natural line of inquiry, but we just need some time to push through this very exciting operational phase of the program and start to think about some of the long-term science implications. We do have a phenomenal scientific data set. TAG was a great science experiment. And so there's going to be a lot of work that comes out of it, but we need time to get the data down, to get it calibrated, processed, and to just spend some time thinking about it without all these critical operational decisions in front of us like we have over the next couple of weeks. Push through this very exciting operational phase of the program.
Next question, operator.
Think about some of the long-term science implications. We do have a phenomenal scientific data set.
Right now, your line is open.
Great science experiment. And so there's
Hi, thanks for taking another question. Dante, the material that we see in the imagery that was disturbed and picked up with the TAG event, any estimate yet on how big some of those particles might be? They look kind of small, but it's hard to tell from the scale.
Next question,
and also, if you did collect the required sample of 60-plus grams, what is the flight plan for OSIRIS-REx over the next few months, and do you have a date for departure for Earth? Thanks.
Yeah, great question, Stephen. Can we bring up the third set of images that I was showing here where we were looking at some of the debris and maybe slow it down a little bit? I know we talked about that. So just remember, for scale, we're looking at this TAG SAM head, which is 30 centimeters in diameter. This is the full-scale model here. So you can get a sense, the spacecraft's only a little over 2 meters away, or 6 feet away, so not much farther than my span here. So you can actually kind of estimate the particles. So we're looking at things, that's probably on the order of centimeters to several centimeters. And then we've got this guy here. This is a pretty amazing looking particle. So if it was to scale with the TAG SAM head, it would be on the order of 15 centimeters. It's probably a little closer in our field of view, so it's going to be a little smaller than that. But this is the biggest one that I've seen so far in my assessment of the data. Of course, the team is going through with much more careful analysis. But I'm guessing this is multiple centimeters, maybe up to 10 centimeters across here. And this guy kind of comes shooting off from the right side of the field of view and moves over off the image to the left. So there's certainly a lot of work to do to really get a sense of how far away, what's the depth of field of view of the image that we're seeing here, and to do some real precise measurements of the sizes of these particles. But this one alone shows me we picked up some things that are pretty big, but for the most part we're looking at centimeter, sub-centimeter scale particles just from a quick look assessment. But there's a lot more detailed analysis to go. This is all preliminary, and the image processing team at the University of Arizona is busy as we speak answering that exact question right now. And then I think over to Rich for the departure date and the return cruise.
Right, so if we stow the sample, we'll be doing so in the first week of November, and we'll follow continue to drift away from the asteroid after we make that maneuver on Friday, rather than attempting to reinsert into orbit. Our departure window opens in March. That's when the orbital mechanics say it's fuel efficient to get back to Earth, and our designated date in September of 2023. We'll depart the asteroid in early March at the opening of that window. We'll follow, continue to drift away from the asteroid.
We have time for one final question. Operator, please patch it through.
Attempting to reinsert into orbit. Our departure window opens in March. That's when the orbital mechanics say it's fuel efficient to get back to
Operator,
Earth.
do we have another question?
And our designated date in September of 2023. We'll depart the asteroid in early March.
I do
at the opening of
apologize for
window.
that technical issue. Michael Gresko with National Geographic, your line is now open.
Please patch it through.
Hi, thank you so much, and congratulations to the team. I had a question about sort of the aftermath of this tag. What are the plans, if any, to do any sort of remote sensing on Nightingale site, sort of see the hole you all left? And then more generally speaking itself, I mean, this moment has sort of captured the world's attention. Anything at this time you want to say to, people around the world who are watching this and sort of taking this in along with you?
Sure, I'll answer that. It's a tough question, Michael, because there was a lot of interest from the science team on more data, more characterization of Bennu after the sampling attempt. But, we gathered together as a management team and we evaluated that exact question very thoroughly. And we agreed unanimously that this mission is about safe return of this sample. And we do not want to do anything to put that sample at risk. So the plan right now is we're going to go through these verification activities on the flight system. We're going to check out the state of the vehicle. If everything looks positive and we meet with Thomas on October 30th and make that decision to stow, that is the end of the science campaign at Bennu. We are then solely focused on the return cruise, and quite honestly, the real scientific payoff, which this mission is designed to do, is that sample return and the sample science, and we'll be putting our focus and our resources into that. It wasn't an easy decision, guarantee you. It was tough, especially the scientist in me always keeps asking those questions, but it's the right decision to maintain that focus on the level 1 requirement. Because I can tell you, right before we kicked off the tag activity, I went through all of our publications and all of our data, and I mapped them to the level 1 requirements of the mission, which is what I agreed to with Thomas and Lori that this program would deliver. And we have met, and in most cases vastly exceeded, all of the science requirements associated with the remote sensing campaign of Bennu. So all we have left to do to deliver on our promise to the agency is get that sample safely back to the Earth, get it into our laboratories, and answer the fundamental questions about the formation of our solar system and why Earth is a habitable world. And then you gave me a chance to promote a message, and I'll just say, OSIRIS-REx, in my opinion, is the culmination of human activity as a species. We built this mission for peaceful purposes, out of curiosity and our desire for knowledge. It's a team that comes from a variety of backgrounds and viewpoints, but none of that matters because we work together, united in a common vision and a common goal. And when we do that, we achieve amazing things. And so I told the team, I know we focus so much on the details and the technical implementation of this program, but we serve as a model for what we can do as human beings when we unite in a common vision. When we're united, we're strong. When we're divided, we're weak. And so I hope that message of unity and common purpose, and that we're all in this together, right? We've got this precious planet Earth that we're the stewards of, that we're responsible for. And when we come together and unite, we achieve amazing things.
Could I follow on to that, please? Yeah, I think one additional thing to add on to that, beautifully put, words from Dante, is, we're hoping to serve for an inspiration for future scientists and engineers. This mission is as much fun as you can have and get paid to do, right? So I had one of our instrument scientists was examining the images from our navigation cameras as it came down this morning. He said, his subject line, his email he sent to me, the image was, "This is so cool," right? And it is. And what he finished his email with was, "I love this job." So we're hoping that, there's 5, 6, 10-year-olds out there that get inspired by this mission, the amazing achievements of this mission, and it's the people the engineers and the scientists on this mission that made it happen. So we need our future generations to be inspired by this, and that's what we're hoping to do. I think the other thing is, Dante mentioned the sample allocation. A large fraction of the sample is going to be reserved for study of future generations. So we're hoping that future sample scientists are inspired by this. And, you know, kids at home today could be the ones studying this sample in 10 or 20 or 30 years and make new discoveries that aren't even possible with today's technology. To be inspired by this, and that's what we're hoping to do.
Well, that was a great way to wrap the show up. And as your engineer said, the images, they are cool. So before we close, we'd just like to invite everyone to tune in to the NASA Science Live that's going to follow this press briefing at 6:15. So go on over to nasa.gov/OSIRIS-REx. You'll see a presentation from various OSIRIS-REx scientists. They'll talk a little bit more about the images and about the overall OSIRIS-REx mission. I just want to say congratulations to the team. Go OSIRIS-REx, and thank you for tuning in. We'd just like to invite everyone to tune in to the NASA Science Live that's going to follow this press briefing at 6:15. So go on over to nasa.gov/OSIRIS-REx. You'll see a presentation from various OSIRIS-REx scientists. They'll talk a little bit more about the images and about the overall OSIRIS-REx mission. I just want to say congratulations to the team. Go OSIRIS-REx, and thank you for tuning in. We'd just like to invite everyone to tune in to the NASA Science Live.
When we are called to do an experiment, sometimes it's a very short lead time. We get a 12-hour call, and we're in.
My advisor and I, we have to work together. He's talking to the astronauts, I'm talking to the cadre, and so it's really difficult to take it all in.
Very nice. Very good. Try not to break them up, but that's a very good disturbance. And now back and forth the opposite direction.
What's funny is I forget who I'm talking to sometimes. I'll have conversations where it's like, oh yeah, you know, we had an experiment yesterday. It was on the space station. We were talking to the astronaut, Doug, and it's so casual. And it's like most people are like, what do you do?
Throughout this season of NASA Explorers, you've seen what it takes to send science to space through the eyes of one team of researchers. But they aren't the only ones. For 2 decades, the International Space Station has hosted science from thousands of researchers across the globe.
The importance of the ISS to the research community is huge. From the very basic phenomenon of taking gravity out of the equation is that the ISS is really the only platform we have right now. It gives you long-term access to a microgravity environment.
You can do the experiments, on Earth, but those are almost a precursor to, okay, now let's remove gravity and see what happens. Does it change?
If you're like me, you're a scientist who's trying to unravel the mysteries of science, and someone shows you a shiny new tool, which is microgravity, which can, make science different. And different is what we constantly shoot for.
And different can take time. Before new scientific discoveries could be made, we had to transform an orbital outpost into an orbiting laboratory.
In the early days, it was so focused on building, constructing station and making things safe. And then we started stepping up the number of hours a week that we can use crew time.
More violence in the Hayabusa 2 back away, which I think says something about the flyability of the 2 asteroids. They have stronger thrusters and they're not canted, but ours looks a lot more violent. But we have to compare the cameras. So that's my gut feeling.
Okay, everybody, a few things for I'm sorry to interrupt. We're 5 minutes out, so if everybody wouldn't mind just staying silent until we start at 6:15. Good luck to everybody.
but please don't mute your mics. Good luck, everyone.
For the first time, NASA has touched the surface of asteroid Bennu to collect the agency's first ever asteroid sample, which will one day shed new insights on the history of our solar system. So what's next? I'm your host, Lauren Ward, and hello. If you haven't heard, we made history yesterday. So let's bring you up to speed. At 6:12 p.m. Eastern Time, NASA attempted to collect a sample from a near-Earth asteroid named Bennu. Since arriving at Bennu in 2018, our OSIRIS-REx spacecraft has been orbiting the asteroid, mapping it, and studying it closely. And yesterday, the spacecraft descended on an asteroid surface, and its robotic arm touched down for a few seconds to collect the sample of an asteroid's rock and dust. This precious rock and dust that the spacecraft will safely enclose in a capsule could tell us more about the history of our solar system. And that's why in 2023, the sample will have made its way back to Earth so we can study it. So the question is, what happens next? Today we are joined by three experts: Danny Della Justina, OSIRIS-REx lead image processing scientist at University of Arizona, Jason DeWorkin, OSIRIS-REx project scientist at NASA Goddard, and Bo Bierhaus, OSIRIS-REx TAG-SAM scientist at Lockheed Martin. Thank you so much for joining us, you guys. It has been a wild 24 hours.
Thanks, Lauren.
Great to be here. Thank you.
We're so excited to have you. So, Danny, let's get into it. I understand there's a new video taken by the spacecraft as it actually descended to the surface of asteroid Bennu. Could you walk us through how that was even created?
Sure, Lauren. So this is a video created from SAMCAM images, and SAMCAM is one of 3 cameras that was built by the University of Arizona specifically to acquire scientific data of asteroid Bennu. So what we see in the video is the TAG-SAM arm. It's extended out and TAG-SAM is observing it as the spacecraft translates across the surface of Bennu, arriving at Nightingale, the sample site. And then you see right as we make contact with the surface and our nitrogen gas bottle fires to collect that sample, there's a huge spray of material that's just lofted from the surface of Bennu. And this is a great sign. It looks like we kicked up a lot of material, and that means that some of it likely made it into that sampling mechanism. So we are really happy to see this result, and the movie from SAMCAM is quite promising.
That is amazing. And it's so astonishing that your team was actually able to put it together so quickly. For our viewers at home, these guys have been up all night. So, Bo, your team will use this video to assess the response of TAG-SAM head to the surface. Could you walk us through exactly what we're seeing in this amazing video?
Absolutely. So the first part of the video, you'll see the TAG-SAM head centered in the SAMCAM image as Dan was saying. And as the spacecraft descends towards the surface at a leisurely 10 centimeters per second, about 15 times slower than walking speed, eventually the spacecraft senses contact with the surface. We sense contact with an accelerometer on board, and that told the spacecraft to fire the gas bottle, which then released nitrogen gas under the TAG-SAM head, which mobilized material, we hope, into the TAG-SAM head as well as outside the TAG-SAM head. The 2 things that we're really examining in detail now that we have these incredible images is the response of the TAG-SAM head to the surface and the response of the surface to the TAG-SAM head itself. So of course, the surface is very interesting and very dynamic, and that tells us that the material is probably very weak and doesn't have a lot of cohesion, and so therefore is easily mobilized and potentially easily collected inside the TAG-SAM head. The second piece of information we're trying to understand is the geometry of the TAG-SAM head against the surface. So we want to know whether it was tilted or flush when it fired the gas. Preliminary signs suggest that it had a minor tilt at most, which is very good for sample collection. There's a great image now. You're seeing a pair of images of just before contact and just after contact. And you can see the TAG-SAM head tilting just a little bit. And in fact, you can see surface material moving in response to the contact of the TAG-SAM head. And we thought that this might happen based on some of the experiments that we had done with reduced gravity flight. And the final thing that we're doing is we're assessing the arm in the images as we back away just to make sure that there was no damage to the arm. And so far, that all looks great too.
Absolutely spectacular. It is so interesting to watch OSIRIS-REx descend on the surface, to the surface of the asteroid Bennu, especially when you consider that these images are coming from over 2 million miles away. So fantastic. Jason, the team will analyze the sample once it's delivered to Earth, but before then, there is still a ton that has to happen. Can you explain how the sample will be handled from now until it lands on Earth?
Absolutely. So the next step is to take images of the material inside the sample head, inside of the TAGSAM head. This weekend, we'll be taking measurements of the mass of the material by extending the TAGSAM arm and rotating the spacecraft slowly around and measuring the change in moment of inertia. After that, we will assess whether or not we think we have enough material, and then if we do, we'll be opening up the sample return capsule and stowing the material inside, at which time we cut off the sample head, close up the sample return canister. You can see happening right here. Then in March, the spacecraft departs orbits around from Bennu, and then heads to Earth. The sample return capsule is jettisoned from the spacecraft, landing in the Utah desert at the Utah Test and Training Range outside Salt Lake City, the morning of September 24th, 2023. The spacecraft diverts, goes into orbit around the sun, and the sample return capsule is collected by the team of scientists and engineers and brought to a clean room in the Utah Test and Training Range to make sure that the pyros and batteries are disarmed, flown to Houston, to Johnson Space Center, where the curation team will open it up and then distribute the samples to laboratories around the world, including my own, to study the sample for decades to come.
That is fantastic. And I want to rectify something I said before. It's not 2 million miles, it's 200 million miles away. That is so much farther and more impressive than 2 million miles. So I understand that Bennu was far more rocky than we expected, making yesterday's maneuver more difficult than we had ever imagined. One thing that I think everybody is wondering is, was that experience watching Bennu, do the tag, was that nerve-wracking? And I really want to hear from everybody, starting with Jason.
So I've been anticipating this moment since 2004 when I started working on the predecessor to the OSIRIS-REx mission, OSIRIS. It's been an amazing journey, a lot of really talented scientists, engineers, managers, technicians, admins. It's been an incredible journey, and that these few seconds mean so much, and that the sample will be distributed as a legacy of this team that the world can enjoy, that scientists not yet born, using instrumentation not yet invented, can answer questions that we don't know how to ask yet.
Wow, what an amazing gift for the entire world. Danny, I'd love to get your thoughts too.
Yeah, well, so I got my start on OSIRIS-REx, also on the precursor to the mission named OSIRIS, as an undergraduate student in the early 2000s. And as we were leading up to this event, it occurred to me that I've been waiting my life to gather a sample for you. So I went into the event with a lot of cautious optimism, because this team is exceptional. And I know we had done everything possible to minimize the risks associated with gathering the sample from Bennu, even though you mentioned, Lauren, it was more challenging than we were expecting. The surface was far rockier than anticipated when we designed the mission. So I felt confident that we had done everything in our control to achieve mission success, and the rest was up to Bennu. And it turns out Bennu complied, and it looks like we've achieved what we were hoping for, but there's a little more work to go to verify the amount of sample we collected.
Bennu definitely did an outstanding job, and it did exactly what we intended. Bo, what were you thinking during the tag event?
I was thinking a lot of things, so many things that it's probably hard to put in a small number of words in a short period of time. Of course, incredibly excited. Been waiting for this moment also since 2004. I started working on the mission in 2004. Have done 890 collection tests with TAG-SAM, multiple reduced gravity flights. And the team was incredibly well prepared. We couldn't have done anything more. We had rehearsed the tag twice before in real life with the spacecraft around Bennu, and many, many times before in simulations on our computers. So we had a pretty good idea of what to expect and what could go wrong and how to handle things that they might have gone wrong. The one thing we had not tested was the actual TAG-SAM collection event at Bennu. So even though we have done hundreds of tests on the ground and on reduced gravity flights, we had never done this sample collection event at Bennu before. So that was the last piece we hadn't done. It's an important piece, but as Danny said, fortunately, Bennu complied. It's one of the few ways in which Bennu actually worked in our favor. It was rockier than expected. There were particles being ejected off the surface that we didn't expect. But in this particular case, Bennu seems to have fallen in our favor. And after having worked 16 years on this program, to have all of that time collapse down into just a few seconds, it's a weird, surreal juxtaposition of time scales. But I'm incredibly happy and proud and excited for everybody involved.
Well, this team is second to none, and you guys were adaptable beyond any imaginable scope. So it's worth being extremely proud about. So we've been able to study asteroids that have come through Earth's atmosphere before. Danny, what is different about this sample in particular?
Yeah, that's a really good question, Lauren. So you're right. We do have meteorites that come from asteroids in our sample collections on Earth. But you know, those meteorites only represent the material that is strong enough to survive what is a very warm entry through Earth's atmosphere, as well as an impact on the Earth's surface. And so the data that we've obtained so far from Bennu using the OSIRIS-REx spacecraft, it indicates that the asteroid has water-bearing minerals and organic molecules. And this material might be pretty fragile, and thus it wouldn't be represented in our meteorite collection. You know, it likely wouldn't survive that atmospheric entry onto Earth's surface. But additionally, by going to Bennu to acquire a sample directly from its surface in a very controlled way, putting it in a safe and clean sample return capsule, we know that that material, it's not going to be contaminated by, you know, the Earth's surface in the same way that meteorites are. And so it really offers an unprecedented opportunity to study material from an asteroid that we might not have in our meteorite collection, and that is pristine and hasn't experienced contamination.
Fantastic. Okay, so let's get down to it. The internet is buzzing with excitement around yesterday's events, and many people have questions. So let's take a few now. If you're watching this and you have questions, submit them online by using the hashtag #ToBennu&Back, or comment on the stream wherever you're watching this. Okay, our first question is from Anna2, who is an 8th grader at Mesa Verde Middle School, and she asks, is there a possibility that this sample can change the design of future bots made for this same purpose? That is an engineer in the making. Does anyone have a good answer for that?
We can try to answer that question. It is an excellent question, and we hope the answer is absolutely yes. One of the major challenges we had for this mission was trying to design a sample collection device for material that we didn't know what it was like. We didn't know what the mechanical properties might be. We didn't have a good understanding of what really the size distribution of the particles might be. And by that, I mean how many there are of any particular size. We didn't know if the material was strong or weak. And now that we've done this sample collection event at Bennu, all of the data that we've collected both during this tag event now, but as well as examining the sample itself when it comes back to Earth, we'll actually be able to make direct measurements of the strength of this material. How electrically conductive is this material? How magnetic is it? And these will inform ways that we can design systems in the future to interact with other asteroids for future missions. So absolutely, the answer is yes. It's a great question.
So speaking of material, Molly on Twitch asks, why did the rocks on Bennu crumble so easily? Are they very loose, or was there an impact? Was it because of the impact of the TAGSAM head being very forceful?
Danny, you talked about that a little bit.
Sure. Yeah, I can explain that. So, all of the indications that we had from the instruments on board the OSIRIS-REx spacecraft were telling us that boulders on Bennu are exceptionally weak. So even though the surface looks really rocky and jagged, we think that these boulders are almost like balls of mud and likely crumble very, very easily under even small forces. So while we weren't necessarily expecting the TAGSAM head to crumble rocks on the surface of Bennu when it was designed, we think that might be what took place during the sampling event.
Wow, yeah, I had that question too. That is a lot of debris, it looks like, but all very safe. So Joe on Twitter asks, will the spin to measure the mass collected cause a loss of material collected?
So the spin is very slow. Actually, Bo, you looks like you're about to say something. You're more expert than I am. Want to take it?
Sure. Okay. Yeah. Jason's making an excellent point. So the spin is very, very slow. It's a very gentle movement, and the way that the collection device is designed is there's actually basically a flap that prevents material from leaving the collection device after it's been sampled. So the material can go in when we collect it, but it can't come out after it's inside the sample container.
Okay, there you have it. Okay, so Nathaniel on Twitter asks, it was mentioned that there was a possible carbonate, that there's possibly carbonate on Bennu. If this is the case, is there any hypothesis on how the carbonate was formed? Any papers describing that?
Sure, I can answer that. Yeah, so there's actually a paper that just recently came out by our colleague Hannah Kaplan, who is a scientist on the team, who analyzed the composition of these carbonates. And so I would encourage you to check out her publication. But our leading hypothesis for how these carbonates formed on Bennu's parent body actually is that there was a large-scale hydrothermal system. So there was water flowing in the interior of the asteroid that percolated through cracks in rocks and eventually precipitated carbonate. And this is really exciting because it indicates that Bennu's parent body was a water world. And so Bennu is what we call a rubble pile asteroid, and we think it accumulated from the fragments of a giant impact on its parent body. And so by studying Bennu, we start to get pieces and clues about what took place on this water world in the early solar system before it was catastrophically disrupted.
And speaking of that, JL on Periscope asks, did you find any fault lines during your scan, or is this asteroid pretty much solid?
Jason, do you want to get that?
Well, I was going to say this is Bo's expertise, but I can answer for him. So there are lineaments, there are lines that run around Bennu in some spots.
but there's macro porosity. There are holes, empty spaces inside Bennu based on the gravity model that we've developed from watching those particles fly around Bennu and from our close observations. So it is not a solid rock. It's very fluffy, and that's also consistent with the crumbliness of the surface that we saw.
So it looks like we have a lot of people really interested on how they can see these photos eventually. Dutch Steam Machine on YouTube asks, I would love to enhance and look at these photos once they arrive. Is there a website to download the raw photos as soon as they are received?
Yeah, so I can get this question as the image processing lead for the mission. So many of the images that were recently acquired for the sampling event itself are going to be available on the OSIRIS-REx website, which is asteroidmission.org. And then data, as it becomes publicly available, is released to NASA's Planetary Data System. And that's where you can access all of the raw images that haven't undergone any processing. And that is available as a resource to the entire world to access the incredible data we've acquired with the OSIRIS-REx mission.
Absolutely. We've got one interesting question here. Was the impact to the asteroid so strong or strong enough to change its actual location?
The contact was imparted a very small force relative to the size of the asteroid. So the motion of the asteroid would be imperceptibly small. The spacecraft is the mass of a fan of a SUV, and touched it briefly, and the asteroid is the size of a hill. So dropping a car on the hill is not going to move the hill. So no.
All right, good to know. Okay, this is a great name. Out of Cheese on Periscope asks, what do you hope to actually learn from this sample collection? What are the implications?
Oh, I'd like to take this. So I'm on the sample analysis team, and this is what I've been waiting for, is to look at the samples. So we have over 50 hypotheses we want to test. Many of them involve understanding and verifying the observations we've made on the asteroid. I'm personally interested in the origin of organic compounds in the early solar system that maybe contributed to origin of life. And so looking at the ancient chemistry, like the amino acids, their chirality, their left versus right-handedness, so many questions, we need hours to discuss it. In fact, we have weekly meetings where we discuss it for hours.
It sounds like big questions and really big implications too. So
that's why we're here.
Ion, yes, absolutely. And we're so glad that you're doing this work. Ion on YouTube asks, how fast was the spacecraft going to collect the sample? And how can we guarantee we got a good sample that can actually give us data?
I'll take that one. We are just getting our telemetry back from the TAG event. We had a high gain pass over last night and through this morning. We've got just a treasure trove of data that we're digging through now to understand the spacecraft performance. One of those pieces of data is the contact velocity. And we came down right around our expected 10 centimeters per second. And for reference, walking speed is about 15 times faster than 10 centimeters per second. So we really were coming down at a very, very gentle, slow pace, and that was on purpose. And then in terms of how much material we collected and how well we know that, the official mission process for estimating the sample mass is going to happen later this week, actually on Saturday. And it's the sample mass measurement technique that we discussed a little bit before. And that's where the spacecraft stretches out its arm and spins slowly around. And it does that after TAG. We did that once before TAG as well, where we didn't have any sample inside the TAG-SAM device. And we'll do it again after TAG with sample in the TAG-SAM device. And the difference in the measurement between those two spins should give us information about how much mass we actually collected. We have other indirect techniques for evaluating how much sample we might have collected. In particular, using the SAMCAM, which is the same image or the same camera that we use to collect the images of the tag event itself, we can reorient the TAGSAM head to actually be facing with the bottom into the field of view of the SAMCAM. So we can look directly into the TAGSAM device itself, and we hope to have direct measurement of the material inside TAGSAM by virtue of looking inside it. But that can only show us some, just because of limitations of the geometry. We can't see the entire collection volume inside the TAGSAM device itself. So while that will give us some information, it's not the most accurate measurement. So we really are waiting for the sample mass measurement on Saturday.
Whew, Saturday seems like such a long time from now. Okay, moving right along, we've got so many questions. Thank you all for submitting your questions. Sam on Facebook asks, how fast would the material be ejected, and is that capable of damaging OSIRIS-REx at all? So I guess maybe, you know, when the material was, you know, impacted, could that actually damage our little spacecraft?
I'll take that one again. I actually led up a study to address that very specific question, because we knew that was a possibility when we were designing the mission. So we actually did a very exhaustive study to look at the speeds and masses of material that we might pick off the surface. And the short answer is no, we don't feel like there's any risk to the spacecraft at all. Otherwise, we would have chosen a different technique to collect the sample. So there are some speeds of potentially 10 meters per second or 15 meters per second of material coming off the surface. But that is not fast enough to damage any of the equipment on board the spacecraft.
Well, thank goodness for that. All right, Amy from Facebook asks, is there any analytical data sent back to Earth regarding the sample, or do we really have to wait till 2023?
You really have to wait. Part of designing a mission is you need to design for what you require. And so it would be fun to add a whole bunch of instruments to interrogate the samples to give us a quick look. That would be not as good as what we have on the Earth, which is the whole reason we're bringing it back. But that costs a lot of money and costs a lot of time and space and mass. And it's better to invest that time in having the fantastic camera and spectrometer and LiDAR suite that took the data we can compare with the sample when we get back on Earth, and having the talented team to be able to solve these problems that we had on board, and that Ben literally threw at us.
Yeah, can I add to that, Lauren?
Yes, of course, please.
Yeah, I think, so Jason is right. We won't be able to directly interrogate the sample using anything on board the spacecraft, but I think it's important to note that we gathered a lot of data of the sample site before we collected that sample. So we do have some great indications that where we gathered a sample from on Bennu is relatively young. It looks like it has a color that's reddish, and that might indicate a more recent exposure age. And there was also evidence of the presence of organic molecules and carbonates around the sample site. So we believe it will have some carbon-bearing material. So while that isn't, data directly taken of the sample itself, it gives us, it allows us to make some inferences about what the sample will look like, and they are all very promising.
Oh, love to hear it. That sounds great. And that is all the time we have for today. Thank you so much for joining us, Danny, Jason, and Bo. We know you're busy, and we've loved having you.
Thanks, Lauren.
Thank you.
Thank you. Great to be here.
And thank you for joining us at home. We've loved having you too. For more updates on OSIRIS-REx journey back to Earth, visit nasa.gov/OSIRIS-REx or follow @OSIRIS-REx on Twitter, Facebook, and Instagram. Check back with us in the first week of November when we hope to make an announcement, especially regarding whether or not sufficient sample was collected. So that's very exciting. Check that out. Be sure to check that out. Until next time, I'm Lauren Ward. Thanks again for joining us, and this has been NASA Science Live.
feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather.
Hey everybody, this is Beck, and I'm a maker of music. And like the great Sun Ra said, space is the place.
And I'm Farah. I work at NASA, and I use AI to explore Mars.
And I brought a few friends along who know something about artificial intelligence.
Hi, I'm John.
Hi, I'm Isabel. We are both artists working with NASA using artificial intelligence.
This is Ask NASA.
Yeah, so Beck, you just released a set of new music videos using a lot of NASA imagery, and I grew up loving space, and obviously those images are used by scientists. What inspires you about space, and how you came up with this idea?
Well, the title of the record came from a video game, a really primitive video game from the 80s called Asteroids. When the asteroids were going to kill you, and they were just about to collide with your spaceship, that you would hit this button and it would make you disappear and reappear somewhere else in the galaxy. And I always wondered what that button was called, and I looked it up one day, and it was called hyperspace. So I sort of, it got my mind thinking into music and song ideas. Because I think in some way, I think of music as sort of a hyperspace button. You know, it's something that we press play on a piece of music and it takes us somewhere out of our lives, out of our circumstances. But I did like the feeling of the music, that there was this sort of thread of outer space, kind of wide vista of space and time, existing in the songs.
Artificial intelligence is the ability for machines or computers to make autonomous and intelligent decisions. That can look like recognizing patterns or analyzing images or learning certain behaviors and then mimicking them.
I mean, right away when we heard hyperspace, we thought we have to use AI for this. Beck was already creating a sonic environment that went to like the edges of our understanding and the way that we see. And that's something that we're most excited about working with AI with, that it expands our modes of thinking. And then just the title, hyperspace, literally means to go beyond 3 dimensions. The one that we use for this particular project, it literally works in a 512 dimensional space. The process begins with the AI training on the images. So if we showed it just a few hundred, it wouldn't know that much. But what was so great about working with NASA's decades deep, archive of knowledge is that it could really learn. So for weeks and weeks, the AI trained on as many images as we could show it. I think in the end, it looked at over 25 million images. Sometimes that was multiple times looking at the same images to try and understand these images.
Yeah, basically imagery of anything in our solar system is how we get started in the process of exploration, right? And so when we first went to Mars or when we sent Cassini to Saturn, we had some thoughts about what we might find based on that imagery, and that's what allows us to really focus down on the type of science we're going to do.
I worked a lot on the database creation, and I feel almost like I could draw a picture of the galaxy now just from going, like anyone can do, just by working with the NASA websites and going through the archives. Like the AI was then able to take that and recognize colors that were happening a lot, recognize shapes that were happening a lot. I remember when it first showed us what it thought Saturn looked like, I was blown away.
Yeah, and even then, seeing these images and getting all the info, it is overwhelming, isn't it? I mean, we're talking about other worlds, we're talking about other realities we probably won't ever get to experience in our lifetimes. This is the closest we'll come to touching the unknown. This project is so interesting because it really came out of the theme of the record. I would have loved the idea of taking sounds from these missions in space and putting them into the music itself.
The coolest thing that we have coming up, which we can point you to when it comes out, is that Perseverance actually has 2 microphones on board. It's the first time we'll have real audio from Mars. So we'll have audio as well landing on the planet, so that during entry, descent, and landing. And then we'll have audio when we're driving, or the rover has a laser, and so you'll be able to actually hear that laser zap on another planet, which is kind of something that's kind of hard to even wrap your mind around.
And that hasn't been recorded before?
No, not with a microphone, not this way. We've never had a microphone on the rover like that.
Okay, well, send those audio files my way when you get them.
Absolutely. So on Perseverance, we actually have an extra computer, and so that extra computer allows us to make the rover smarter, and we actually self-drive on Mars. So the rover has to take imagery of the area in front of it, literally build its own map. It can then identify different types of obstacles and slopes, and based on that and its knowledge of where it's able to drive, it decides on the path.
The Mars database was in one of the easiest ones because it's where we have the most high resolution imagery. It's been so well captured from so many different points of view.
We've seen the soil on a terrestrial level, and then we also have imaging of Mars from above, and looking through this data set of massive data set of incredible images. Once we trained the AI on that, it was able to kind of produce such vivid, strange imagery, because Mars itself, I think, is so much more complex and so much more deep and varied than we imagine it is.
Okay, so one more cool feature about the Perseverance rover is that it can also act as a scientist. The rover can look at the environment around it, look at all the rocks, and say, hey, this rock over there looks really cool. Let me image it, use my laser to zap it, and figure out what's under that surface, send all of that data back to the scientists. So it allows us to essentially have scientists on Mars making decisions without having humans in the loop here on the ground.
I think, to me, the idea of space is a bit overwhelming and awe-inspiring. Just the idea of listening to a piece of music and we go somewhere else, our lives change. You know, it's a mirror to this other idea of space and space exploration, and letting the imagery of these other worlds, these unknown places with this music, I think has been really satisfying to me.
Good evening and welcome back to the International Space Station Flight Control Room. The MS-16 Sojuz is currently still docked to the Russian Poisk module of the International Space Station, but not for long. Here in the Space Station Flight Control Room, the team is preparing for undocking of the Sojuz MS-16 and the 3 crew members it's carrying inside. But that is still a few minutes away. That's coming up at 6:32 p.m. Central Time. And I'm Brandy Dean. NASA's Expedition 63 Commander Chris Cassidy, along with Soyuz Commander Anatoly Ivanishin and flight engineer Ivan Wagner, both of Roscosmos, closed hatches between the rest of the International Space Station at 3:24 p.m. Central. Since then, the station has maneuvered into undocking attitude, and the crew has been working through the last leak checks, getting into their so-called spacesuits that they'll wear for landing, and working through the other activities that have to happen before today's undocking. Despite a slight delay in the hatch closing, while the crew did some troubleshooting with a video camera, all the work since then has gone pretty smoothly, and we're now standing by for the Soyuz's undocking, again scheduled for 6:32 p.m. Central Time, coming up in just 31 minutes. That undocking will be followed by their deorbit burn at 9 p.m., which will put them on course for a landing southeast of Jeskiskan, Kazakhstan at 9:55 p.m. Central Time today. That's going to wrap up a 196-day stay at the space station and mark the official transition from Expedition 63 to 64. As Expedition 63 Commander Chris Cassidy transferred authority to Expedition 64 Commander Sergei Ryzhikov ceremonially on Tuesday, but that won't be official until they undock. It's still Expedition 63 until the Soyuz MS-16 has left the space station. And it was a very busy and historic mission. Over the course of those 196 days, the crew welcomed 5 visiting vehicles, including the first commercial vehicle to deliver crew members to the space station, the SpaceX Dragon, with NASA astronauts Bob Behnken and Doug Hurley on board. They joined Cassidy, Ivanishin, and Wagner for 2 months of the expedition during their flight test of the spacecraft, which launched on May 30th and landed on August 2nd. Other than that, the 3 astronauts have been on their own, except for about a week at the very beginning of their stay in space, before they relieved the Expedition 62 crew members, Andrew Morgan, Jessica Meir, and Oleg Skropochka, and also for the past week when they've been handing over to their own relief. Expedition 64, made up of NASA's Kate Rubins and Roscosmos's Sergei Ryzhikov and Sergei Kudskirchkov.
The next measurement.
In addition to all those spacecraft carrying people on board, they saw the arrival and departure of a number of cargo vehicles as well. They were on hand to say goodbye to Russian Progress 74 and Northrop Grumman Cygnus 13, and to greet their replacements, Progress 76 and Cygnus 14. They were also present for both the arrival and departure of the Japan Aerospace Exploration Vehicle's HTV, or Exploration Agency HTV vehicle number 9. Amidst all that traffic, the crew still managed to get a great deal of work done. While the Crew Dragon was at the space station, Cassidy conducted 4 spacewalks with Bob Behnken, spending a total of 23 hours and 37 minutes outside in the vacuum of space, while the 2 replaced aging nickel-hydrogen batteries with new lithium-ion batteries. That brought Cassidy's spacewalking total to 54 hours and 51 minutes over 10 spacewalks that spanned his 3 missions. With that, he is tied for most spacewalks by U.S. astronaut and is 9th on the all-time list of time spent spacewalking. Cassidy also worked on a number of science experiments during his time at the space station. Just to name a few examples, he helped to investigate cancer therapies using microgravity as part of the OncoSelectors experiment. He also contributed to research on water droplet formation and water flow as part of the droplet formation study, and worked with the cube-shaped free-flying robots Astrobee to test out their use as an astronaut assistant for routine duties. With his landing coming up at 9:55 p.m. Central today, Cassidy will have spent a total of 378 days in space over his 3 space missions, putting him at 5th place on the list of most time spent in space by a U.S. astronaut. And just a reminder for those of you following along at home, we'd love to answer some of your questions over the course of our coverage tonight. If you have a question about Expedition 63's undocking and landing, you can send it to us on social media using the hashtag AskNASA. We'll try and answer a few of those over the course of the night. So again, go ahead and start sending those to us using the hashtag AskNASA, and we'll be watching for them. Here in the Space Station Flight Control Room, Flight Director Chris Edelin is leading the team for tonight's activities, with Dave Marshke beside him manning the Capcom console. Team here is getting ready to perform their go, no-go poll for the Soyuz undocking, ensuring that they are ready to support from here in Houston. And in Kazakhstan, a number of officials and vehicles are standing by in preparation for the landing. A total of 12 Mi-8 helicopters will be deployed for Soyuz landings to various areas to await touchdown. 8 are at the expected landing site southeast of Zhezkazgan. 2 more will be ready about 250 miles away in the area where touchdown would occur if a ballistic entry occurred. And a final 2 helicopters will loiter midway between the 2. We are, of course, not expecting a ballistic entry, but as always, we will be prepared for one. Also deployed for landing are 6 all-terrain vehicles and 3 Antonov airplanes that serve as flying command centers. They'll have direct communication with the crew and will relay those communications back to the flight control team outside of Moscow. That whole team should have pretty good weather for all of their activities. The weather forecast at the landing site is for temperatures around 45 degrees Fahrenheit. And they'll have a few clouds at 5,000 feet, scattered clouds at 20,000 feet, and winds out of the west at 14 knots. Visibility should be about 6 miles or more at the landing site by the time the Soyuz arrive. Again, that's scheduled for 9:55 p.m. Central Time. So definitely not a bad day as temperatures go in Kazakhstan in the fall. However, the crew won't have to spend a great deal of time outside regardless. As usual, the landing team will quickly erect a medical tent at the landing site so that the crew can work through their regular post-landing checkouts before boarding helicopters to Zhezkazgan, where they'll get on airplanes to take them home. Final wrap-up of Expedition 63 began on Tuesday afternoon when Expedition 63 Commander Chris Cassidy handed authority for the space station over ceremonially to Expedition 64 Commander Sergei Ryzhikov. That handover will become official when Soyuz undocks from the space station in about 24 minutes. But in the meantime, let's take a look back at that change of command ceremony.
Welcome aboard the International Space Station to the Expedition 63 to 64 crew change of command. I'm NASA astronaut Chris Cassidy here, and with all 6 of us, it's an honor to be with this event with you guys right now. You know, Expedition 63 has gone by super fast. We joke around that there's only Mondays and Fridays, and it's a big blur of time between. And when we started the mission, the pandemic on Earth was just starting, and now we are returning to Earth, and our fellow crewmates here had to train through those 6 months. Our time on board has been very interesting. We've had some time as a 3-person crew. We had some time as a 6-person crew, both at the beginning with Drew and Jessica and Oleg, and now with Sergei and Kate. And then in the middle, we had a time as a 5-person crew with Bob and Doug, and we had the privilege of welcoming the SpaceX demo mission on board the International Space Station. Sprinkle in there some spacewalks and some Progress cargo vehicles and some American cargo vehicles and some crazy situations with the space station systems. It's just been an incredible 6 months of our lives. But experiences are nothing without the people that you enjoy those experiences with. And I must say it's been really an honor to be with my friend Tolia and Yvonne couldn't have asked for a better team of people to be here with. And when we had just a crew of 3, we spent several cozy days in just the service module, and it was just a wonderful, wonderful time. I also want to give a shout out, as I mentioned, to Drew, Jessica, and Oleg. It was great to be with them. Bob and Doug, certainly we had 2 wonderful months, and then this week has gone by super fast with Sergey, and Kate. Thank you for being part of it with us. And so with that, we have this small tradition where there's a key to the International Space Station, which didn't exist when I was here 7 years ago. I don't remember this, but now we have this, and I think it's very cool. It symbolizes the tool that we use on the Russian hatches to open and close the hatches, and it's a very appropriate key of the space station. It symbolizes the camaraderie that we have between all of the space agencies. And Sergey, it's with great pleasure and honor that I present you this key and command of the International Space Station. Congratulations.
Thank you. Thank you very much. It's a great day. It's an unforgettable event, and this key reminds me time when I was a pilot and we kept key of sky, and now we keep key of space, and it's very interesting, very honorable for me. And we are very happy to join our crewmates and left this week together. And our mission is going to be very to have many events, many activity, and we are ready to continue tradition to show how on board people have example for people on Earth, how we work together, how we help together, and how we like to be on board station. So thank you very much, whole ground team, and we are looking forward to work with you upcoming 6 months. Thank you.
Thank you very much, Houston. We appreciate your support, and over to you.
Station Houston, we are thrilled to be with you today as we mark the end of this amazing increment. Expedition 63, thank you for your hard work and accomplishments. You've all set an impressive example with your work ethic and dedication to the mission. Chris, Anatoly, and Ivan, safe travels home tomorrow. And Sergey, and Kate, we are looking forward to a great increment with working with you.
That again was video from yesterday's change of command ceremony. The next step for the crew was this afternoon's hatch closing, which occurred at 3:24 p.m. Central Time. We weren't able to see that video in real time because of a misconfiguration on orbit, but that issue has since been fixed, and the crew was able to send down recorded video of those final moments together. That's what you're seeing here.
Pressure now. 4.2 is the CO2.
Kay Rubin's in the foreground getting some photos with Chris Cassidy just floating up next to Anatoly Ivanishin there in the hatch of the Soyuz. Again, this is recorded video from just around 3:20 p.m. Central Time, and you can see the hatch being closed. Again, that occurred this afternoon at 3:24 p.m. Central Time. That is the Soyuz hatch there that you see closing. The next step was also to close the space station side of the hatch, so that when the Soyuz moves away, the space station will also be protected. That occurred just a couple minutes later at 3:26 p.m. Central. And there's the new space station commander closing the space station side of the hatch. That's Sergei Ryzhikov there. Again, the Soyuz hatch closure took place at 3:24 p.m. Central Time today, with the space station hatch following at 3:26, and that was some recorded video of those activities that we weren't able to see real time. That activity set the stage for Expedition 64 crew members, NASA astronaut Kate Rubins and Roscosmos cosmonaut Sergei Ryzhikov and Sergei Kudzverchkov to stay behind today as their Expedition 63 crewmates return to Earth. The next step on the journey will, of course, be undocking. Again, that's coming up at 6:32 p.m. Central Time, just about 14 minutes away now. Once the appointed time arrives, Soyuz Commander Anatoly Ivanishin will send a command to open the hooks and latches between the Soyuz and the Poisk Mini Research Module 2, where it's been docked to the space station since April. Once the two vehicles are disconnected, the Soyuz thrusters will automatically fire and back the spacecraft away from the Poisk at a speed of just over a quarter mile per hour. Within 3 minutes of undocking, the Soyuz will be about 50 feet away from the space station, at which point Ivanishin will be able to conduct the first separation burn, firing the Soyuz jets for about 8 seconds to begin moving away from the space station at a rate of about 1.2 miles per hour. You can see a graphic here of how that will look. When it's almost 200 feet away, in about 4.5 minutes after undocking, the engines fire again for 15 seconds, speeding the spacecraft up to 3.5 miles per hour. That should get it to a point about 20 miles away in time for the scheduled 9 o'clock deorbit burn. As you can see, after that deorbit burn, the descent module of the spacecraft will be separated from the rest of the spacecraft for the final portion of the landing. Parachutes and then soft landing jets will slow it down for its landing in Kazakhstan at 9:55 p.m. Central. Since the hatches between the Soyuz and the Poisk Mini Research Module were closed at 3:24 p.m., the crew inside the Soyuz has been steadily making their way through their checklist in preparation for their landing tonight. Soon after that hatch closure was confirmed, they took their Soyuz off of the space station's power and put it on autonomous power, then started entering the settings needed for deorbit, such as their state vectors and the change in speed for the deorbit burn. They also depressurized the vestibule between the Soyuz and the Poisk module and performed a series of leak checks. And then they got themselves ready by getting into the so-called spacesuits that they'll be wearing during the journey home. With that done, they're ready to move into the descent module of the Soyuz, which contains the custom seats that they use during launch and landing to soften their touchdown. It also has all the controls and displays necessary for flight, as well as the life support systems, batteries for re-entry and landing. And of course, it also has the parachutes and soft landing rockets that will slow the Soyuz just before its touchdown. It's the only portion that will stay with the crew all the way back to Earth. The orbital module, which is what is directly connected to the station's Poisk module, will separate from the descent module about 28 minutes after the deorbit burn, when the Soyuz is about 87 miles above the Earth. We're about 10 minutes away from today's scheduled 6:32 p.m. Central Time undocking. is the view coming from the Sojuz, looking out at the space station, and it's what the crew will be seeing as they
Buonasera a
move away from
tutti.
the space station. Again, that undocking is
Buonanotte.
scheduled to start in
Ok, abbiamo le
about
riprese
9
da
minutes
bordo, le
now
stiamo vedendo in questo momento.
at
Come
6:32
potete
p.m.
vedere,
Central.
ISS e Sojuz
That will set the
sono
crew on their
già
way for
attaccati.
undocking for a deorbit burn at 9 p.m. and landing at 9:55 p.m.
Москва 22400, включили передачу плюс.
Moscow at 22400. We activated the closed transmitter. Copy.
Передатчик основной.
The main transmitter.
Включаю дисплей.
Принято.
And activating display plus TV. And I'm ready to issue the E2 command.
Да, подтверждаем выдачу команды 0225.
We confirm at 022500. We confirm the command.
Выдал 2022500.
022500. Command has been sent. We have pressurization, accelerometer.
Принято.
We copy.
Так, есть цепка. Индикаторный режим.
We have indicator mode.
Принято.
Copy.
Разворот. Весов пока нет.
We don't have KSO yet.
Параметр КДУ.
Not in attitude yet. The KDO parameters.
I promised earlier that we would try and answer some of your questions over the course of the night, and we've had a few people sending those in using the hashtag AskNASA. You can keep doing so on social media if you have a question about the Expedition 63 undocking and landing, but we're going to go ahead and take a few of the ones that have already come in now. The first one is coming from Caitlin, who's asking what happens between hatch closure and undocking. There are a number of things that the crew needs to do once they get the hatches between the two vehicles closed. One of the main things is they need to get into their spacesuits, the SOCOL launch and entry suits that the crew wears both when they launch into space and for their return home. It would protect them in the case of an emergency, and is one of the key things that they have to do before they get into their seats to come home. Also conduct a number of leak checks between the two vehicles to make sure that both of them are going to be safe once they separate from each other, and then begin entering some of the information that they'll need for today's deorbit, leading to that 9:55 p.m. landing.
And 022930 is the next command.
Next up, we have Jake, who is asking how many G-forces would the crew feel on re-entry. That is about 5 Gs for Soyuz landing. It can vary a little bit, but in general, crew members seem to say that the harder part is the actual touchdown. That has been compared to a soft car crash. Even with the parachutes and soft landing jets slowing the Soyuz down, it can be a bit of a wild ride once they do land on the steppes of Kazakhstan. Jonathan Haley is asking, with Expedition 63 returning to Earth, who is going to be staying behind on the space station? That is the Expedition 64 crew. They are going to be alone there for a couple of weeks at least. That is NASA astronaut Kate Rubins, as well as Roscosmos cosmonauts Sergei Ryzhikov and Sergei Kuzbirchkov. They'll have the space station to themselves
qua
for
stiamo
just a little
vedendo i
while
membri
until
dell'Expedition
the SpaceX Crew
64, cioè
1
i tre che
arrives. That is going to
rimarranno
be
su,
the
cioè
4 astronauts coming
quelli
up
che
on
non
board
scenderanno
the first operational SpaceX Crew Dragon mission.
e che fanno
They
parte
are scheduled to
dell'Expedition
launch in
64,
November.
mentre quelli, beh, adesso
And
li
they will
fanno
be
vedere.
that will be bringing up Mike Hopkins, Victor Glover, Shannon Walker, and Soichi
E
Noguchi.
fanno parte della Sojuz MS-17.
Kat is asking, is there anything specific or exciting that the Soyuz is bringing back to Earth from space station? And the main thing that the Soyuz brings back to Earth is the astronauts themselves. There's not just a whole lot of room. As I mentioned earlier, the two modules that actually we'll see backing away from the space station will separate, and only the descent module will return to Earth with the crew members inside. So there's not much room for cargo, but the astronauts do manage to bring back a little bit of science and research, in particular their own science and research, since they are one of the main guinea pigs on board the space station. So that is one of the first things that the teams on the ground will do once the crew is safely off and out of the Soyuz, is pick up those science samples and make sure that they get safely returned. And if you follow Chris Cassidy on social media at astro_seal, you can see a picture of some of the science that he personally collected earlier today.
29:30, docking and internal transfer system power on.
And final question for now is from Jason, asking when will the next SpaceX Crew Dragon arrive at the space station? As I mentioned, that is going to be bringing up Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi, and it is currently scheduled to launch in November. We'll be taking a look at that mission and making a final call on the launch date sometime soon.
And the time is 02:30:30. Transfer hatches are closed. The indicator is also illuminated.
Eccola qua vista dall'esterno. Vi ricordo, anche se domani mattina lo ripeterò, che atterra solo questo pezzo qua, mentre il periscopio, modulo di servizio e modulo orbitale verranno separati prima dell'atterraggio. Si chiama modulo di atterraggio o modulo di comando questo. Quindi, per farla breve, modulo di servizio, modulo di comando, atterraggio, modulo orbitale, la palla che sta sotto. 1 e 1 2 e anche tutte le varie strumentazioni qua vengono separate e atterra solo questa parte qua che è il modulo di rientro o di comando.
Electrical connectors mated. Zero 2:31:41. Mechanical connection is no longer illuminated at 02:31:41.
And there you see, undocking right on time at 6:32 p.m.
Ecco
Central,
qua.
while the Soyuz station are
Undocking.
263 miles above Russia. Expedition
Quindi
63
si è
crew officially on
ufficialmente
its way home now. They arrived at the
separata
space
dalla
station
stazione
on April
spaziale
9th and have spent 196 days
internazionale.
living and working there, greeting the first commercial spacecraft to launch
Questa
humans
è
into
una
space and
bellissima
completing another
notizia,
link in the almost
non
20-year
perché
long chain
abbiamo
of
le
continuous
notizie
human
da
presence at the
bordo,
space station.
ma perché io adesso vado a letto, ecco, devo stare zitto, ecco, ma perché io adesso vado a letto
And this view coming from the
e dormo.
crosshairs
E ci rivediamo
from the
domani
video
mattina alle 4:20.
camera on board the Sojuz itself. Looking at that poise module as it grows further and further away. This view coming from the International Space Station.
Sono esattamente l'1:33 e siamo a 3 ore e 33 minuti di live. Gli spettatori che stanno guardando questa diretta sono io ed io e solamente io. In chat ci sono io e solamente io. E la qualità dello stream è buona. Perfetto. Dopo che vi ho detto queste cose che non ve ne frega niente a nessuno, direi che già posso andare a dormire. Vediamo se capita qualcos'altro.
Short drop out of video as the signal is heading over
Chiaramente
from one
il
satellite to
segnale
another,
video
but we
è
should be getting
andato
that back in
perso,
just a moment.
ma questo lo stavamo aspettando.
Coming up in
Lo
just a moment,
dovrebbero aver
3 minutes
ripreso
after
perché se vedete
undocking,
qua,
we'll have that
beh,
first
insomma,
separation
circa
burn.
sta tutto scattando, però è
That'll
qua.
begin moving the Soyuz further out from the space station, getting it to a safe distance.
Eccola
And there's
qua.
our video back. This again coming from
Guardate.
the Soyuz itself, a view of what the crew sees as they back away from the space station.
We are standing by for thruster activation plus X. And we confirm dipole thrusters.
There's that
Guardate
first
che
separation
bello.
burn. Soyuz jets firing for just 8 seconds to ease it further away from the space station at just over a mile per hour.
Data is no longer illuminated, and we confirm the maneuver, start of the maneuver.
NASA su Twitter ha messo il replay con scritto: il nostro astronauta Chris Cassidy, Anatoly Ivanishin e Ivan
Team on the ground
Vanier
reports a
dei
good separation
Roscosmos
burn.
si
Soyuz
sono
MS-16 now moving away from the space station, about 1.2
andoccati,
miles per hour.
sono
And coming up,
separati dalla stazione spaziale alle
the second
7:32
separation burn.
ET, PMT, quindi fuso orario americano. E stanno facendo 250 miglia sulla superficie terrestre. E non so se quello che ho appena detto abbia senso.
Five, six, unintelligible. All right, the thruster firing time is 15 seconds. Burn is 15 seconds.
That second separation burn lasting, as you heard there, 15 seconds. That'll speed the spacecraft up by 3.5 miles per hour. Still not moving too fast, but certainly will be coming up later in their journey.
And we sent the E1 command, unintelligible. Moscow, how do you copy?
You can see the Soyuz moving out there. That second burn puts them a safe distance away from the space station for the ultimate deorbit burn
getti
that
che
will drop them
vedete è
back
del
into Earth's atmosphere at 9
monopropellente,
p.m. Put them on a
cioè
return course for
ci
Kazakhstan,
sono
landing
dei
at
piccoli
9:55
cosi
p.m.
che
Central.
sfiatano e che con la forza di questo sfiato riescono a muovere e insomma il satellite in questione. Infatti vedete che ha buttato fuori all'alto, si sta spostando. Ok, anche adesso vi lascio guardare la diretta di NASA e noi ci vediamo alle 4:20 con le fasi di atterraggio di questa Sojuz. Siamo a 3 ore e 38 minuti di live. Buonanotte a tutti. Questo è il pannello di controllo della Sojuz, quello che vedono gli astronauti. Almeno mi sembra, poi non mi vorrei sbagliare.
And the translational hand controller is in transport position.
Everything continuing to go smoothly as the Soyuz MS-16 backs away with Chris Cassidy, Anatoly Ivanishin, and Ivan Wagner in tow, setting them on their final section of this journey of their mission, the 196 days in space.
170, 171. And then 466. Do we want to deactivate Vizir?
Секундочку. Пока не отключаем. Ждем указаний.
Приняли до указания. We're standing by for your recommendations, Moscow.
Another view from the International Space Station cameras of the Soyuz getting further and further away. Two vehicles are now about 263 miles above the Pacific Ocean, east of Japan, and just about to begin heading southeast on this orbit around the Earth.
Отключаем телевидение, Иркутск.
Да, принято. Отключаем телевизор. We are deactivating the TV system. At 2:41:30, I sent the command to deactivate the TV system and display. Affirmative. All right, and rotational hand controller is in transport position.
Иркуты заложили уставки на спуск, и признак спуск на борту есть.
Да, наблюдаем признак спуска.
Принято.
Что у нас со связью? What's with the comm? Guys, what's with the comm? Помеха каждый раз. There is so much interference. Okay, and where are we at? We are moving on to page 47.
Иркуты, напоминаю, следующая команда у нас 03:45:00, включение видеокамер GoPro в режим видеозаписи.
Приняли 3:45. Unintelligible.
Ну и до этого нужно провести подготовку к работе по 48-й.
Still seeing good views of the Sojuz moving further and further away from the space station. These coming from the International Space Station's exterior cameras. Inside that Sojuz MS-16, the Expedition 63 crew now on their way back to Earth for a landing that's scheduled for 9:55 p.m. Central Time today. Again, they undocked at 6:32 p.m. Central, slowly backing away from the International Space Station now, with the aim of getting to a good spot for their deorbit burn that will be taking place at 9 p.m.
Давайте ближе к времени 03:40, наверное, там.
Хорошо, в 3:40.
We'll ask again. We're starting to work for page 48 at 0340.
The Sojuz MS-16 is now safely backed away from the International Space Station following that 6:32 p.m. Central undocking, and right now the space station itself is maneuvering into its post-undocking attitude. So at that point, we're going to take a break in our coverage. We are going to be back at 8:30 p.m. Central Time for the Sojuz's 5-minute and 20-second deorbit burn that's scheduled for 9 p.m. Central Time. And from that point, we'll stay with you until the crew has landed and is out of their vehicle. Again, that landing is scheduled for 9:55 p.m. Central Time. So we are hoping that you'll be back with us in just about an hour and 45 minutes for our continuing coverage of the Sojuz MS-16 landing today at 9:55 p.m. Central. We'll see you back at 8:30 p.m. for continuing coverage, and this is Mission Control Houston. back to the International Space Station Flight Control Room. The MS-16 Sojuz is currently still docked to the Russian Poisk module of the International Space Station, but not for long. Here in the Space Station Flight Control Room, the team is preparing for undocking of the Sojuz MS-16 and the 3 crew members it's carrying inside. But that is still a few minutes away. That's coming up at 6:32 p.m. Central Time. And I'm Brandy Dean. NASA's Expedition 63 Commander Chris Cassidy, along with Soyuz Commander Anatoly Ivanishin and flight engineer Ivan Wagner, both of Roscosmos, closed hatches between the rest of the International Space Station at 3:24 p.m. Central. Since then, the station is maneuvered into undocking attitude, and the crew has been working through the last leak checks, getting into their so-called spacesuits that they'll wear for landing, and working through the other activities that have to happen before today's undocking. Despite a slight delay in the hatch closing, while the crew did some troubleshooting with a video camera, all the work since then has gone pretty smoothly, and we're now standing by for the Soyuz's undocking, again scheduled for 6:32 p.m. Central Time, coming up in just 31 minutes. That undocking will be followed by their deorbit burn at 9 p.m., which will put them on course for a landing southeast of Jeskiskan, Kazakhstan at 9:55 p.m. Central Time today. That's going to wrap up a 196-day stay at the space station and mark the official transition from Expedition 63 to 64. As Expedition 63 Commander Chris Cassidy transferred authority to Expedition 64 Commander Sergei Ryzhikov ceremonially on Tuesday, but that won't be official until they undock. It's still Expedition 63 until the Soyuz MS-16 has left the space station. And it was a very busy and historic mission. Over the course of those 196 days, the crew welcomed 5 visiting vehicles, including the first commercial vehicle to deliver crew members to the space station, the SpaceX Dragon, with NASA astronauts Bob Behnken and Doug Hurley on board. They joined Cassidy, Ivanishin, and Wagner for 2 months of the expedition during their flight test of the spacecraft, which launched on May 30th and landed on August 2nd. Other than that, the 3 astronauts have been on their own, except for about a week at the very beginning of their stay in space, before they relieved the Expedition 62 crew members, Andrew Morgan, Jessica Meir, and Oleg Skropochka, and also for the past week when they've been handing over to their own relief. Expedition 64, made up of NASA's Kate Rubins and Roscosmos's Sergei Ryzhikov and Sergei Kudskirchkov.
Irkut, the next measurement.
In addition to all those spacecraft carrying people on board, they saw the arrival and departure of a number of cargo vehicles as well. They were on hand to say goodbye to Russian Progress 74 and Northrop Grumman Cygnus 13, and to greet their replacements, Progress 76 and Cygnus 14. They were also present for both the arrival and departure of the Japan Aerospace Exploration Vehicle's HTV, or Exploration Agency HTV vehicle number 9. Amidst all that traffic, the crew still managed to get a great deal of work done. While the Crew Dragon was at the space station, Cassidy conducted 4 spacewalks with Bob Behnken, spending a total of 23 hours and 37 minutes outside in the vacuum of space, while the 2 replaced aging nickel-hydrogen batteries with new lithium-ion batteries. That brought Cassidy's spacewalking total to 54 hours and 51 minutes over 10 spacewalks that spanned his 3 missions. With that, he is tied for most spacewalks by U.S. astronaut and is 9th on the all-time list of time spent spacewalking. Cassidy also worked on a number of science experiments during his time at the space station. Just to name a few examples, he helped to investigate cancer therapies using microgravity as part of the OncoSelectors experiment. He also contributed to research on water droplet formation and water flow as part of the droplet formation study, and worked with the cube-shaped free-flying robots Astrobee to test out their use as an astronaut assistant for routine duties. With his landing coming up at 9:55 p.m. Central today, Cassidy will have spent a total of 378 days in space over his 3 space missions, putting him at 5th place on the list of most time spent in space by a U.S. astronaut. And just a reminder for those of you following along at home, we'd love to answer some of your questions over the course of our coverage tonight. If you have a question about Expedition 63's undocking and landing, you can send it to us on social media using the hashtag AskNASA. We'll try and answer a few of those over the course of the night. So again, go ahead and start sending those to us using the hashtag AskNASA, and we'll be watching for them. Here in the Space Station Flight Control Room, Flight Director Chris Edelin is leading the team for tonight's activities, with Dave Marschke beside him manning the Capcom console. Team here is getting ready to perform their go, no-go poll for the Sojuz undocking, ensuring that they are ready to support from here in Houston. And in Kazakhstan, a number of officials and vehicles are standing by in preparation for the landing. A total of 12 Mi-8 helicopters will be deployed for Soyuz landings to various areas to await touchdown. 8 are at the expected landing site southeast of Jezkazgan. 2 more will be ready about 250 miles away in the area where touchdown would occur if a ballistic entry occurred. And a final 2 helicopters will loiter midway between the 2. We are, of course, not expecting a ballistic entry, but as always, we will be prepared for one. Also deployed for landing are 6 all-terrain vehicles and 3 Antonov airplanes that serve as flying command centers. They'll have direct communication with the crew and will relay those communications back to the flight control team outside of Moscow. That whole team should have pretty good weather for all of their activities. The weather forecast at the landing site is for temperatures around 45 degrees Fahrenheit. And they'll have a few clouds at 5,000 feet, scattered clouds at 20,000 feet, and winds out of the west at 14 knots. Visibility should be about 6 miles or more at the landing site by the time the Soyuz arrive. Again, that's scheduled for 9:55 p.m. Central Time. So definitely not a bad day as temperatures go in Kazakhstan in the fall. However, the crew won't have to spend a great deal of time outside regardless. As usual, the landing team will quickly erect a medical tent at the landing site so that the crew can work through their regular post-landing checkouts before boarding helicopters to Jezkazgan, where they'll get on airplanes to take them home. Final wrap-up of Expedition 63 began on Tuesday afternoon when Expedition 63 Commander Chris Cassidy handed authority for the space station over ceremonially to Expedition 64 Commander Sergei Ryzhikov. That handover will become official when Soyuz undocks from the space station in about 24 minutes. But in the meantime, let's take a look back at that change of command ceremony.
Welcome aboard the International Space Station to the Expedition 63 to 64 crew change of command. I'm NASA astronaut Chris Cassidy here, and with all 6 of us, it's an honor to be with this event with you guys right now. You know, Expedition 63 has gone by super fast. We joke around that there's only Mondays and Fridays, and it's a big blur of time between. And when we started the mission, the pandemic on Earth was just starting, and now we are returning to Earth, and our fellow crewmates here had to train through those 6 months. Our time on board has been very interesting. We've had some time as a 3-person crew. We had some time as a 6-person crew, both at the beginning with Drew and Jessica and Oleg, and now with Sergei, and Kate. And then in the middle, we had a time as a 5-person crew with Bob and Doug, and we had the privilege of welcoming the SpaceX demo mission on board the International Space Station. Sprinkle in there some spacewalks and some Progress cargo vehicles and some American cargo vehicles and some crazy situations with the space station systems. It's just been an incredible 6 months of our lives. But experiences are nothing without the people that you enjoy those experiences with. And I must say it's been really an honor to be with my friend Tolia and Ivan couldn't have asked for a better team of people to be here with. And when we had just a crew of 3, we spent several cozy days in just the service module, and it was just a wonderful, wonderful time. I also want to give a shout out, as I mentioned, to Drew, Jessica, and Oleg. It was great to be with them. Bob and Doug, certainly we had 2 wonderful months, and then this week has gone by super fast with Sergey, and Kate. Thank you for being part of it with us. And so with that, we have this small tradition where there's a key to the International Space Station, which didn't exist when I was here 7 years ago. I don't remember this, but now we have this, and I think it's very cool. It symbolizes the tool that we use on the Russian hatches to open and close the hatches, and it's a very appropriate key of the space station. It symbolizes the camaraderie that we have between all of the space agencies. And Sergey, it's with great pleasure and honor that I present you this key and command of the International Space Station. Congratulations.
Thank you. Thank you very much. It's a great day. It's an unforgettable event, and this key reminds me time when I was a pilot and we kept key of sky, and now we keep key of space, and it's very interesting, very honorable for me. And we are very happy to join our crewmates and left this week together. And our mission is going to be very to have many events, many activity, and we are ready to continue tradition to show how on board people have example for people on Earth, how we work together, how we help together, and how we like to be on board station. So thank you very much, whole ground team, and we are looking forward to work with you upcoming 6 months. Thank you.
Thank you very much, Houston. We appreciate your support, and over to you.
Station Houston, we are thrilled to be with you today as we mark the end of this amazing increment. Expedition 63, thank you for your hard work and accomplishments. You've all set an impressive example with your work ethic and dedication to the mission. Chris, Anatoly, and Ivan, safe travels home tomorrow. And Sergey, and Kate, we are looking forward to a great increment with working with you.
That again was video from yesterday's change of command ceremony. The next step for the crew was this afternoon's hatch closing, which occurred at 3:24 p.m. Central Time. We weren't able to see that video in real time because of a misconfiguration on orbit, but that issue has since been fixed, and the crew was able to send down recorded video of those final moments together. That's what you're seeing here.
Pressure now. 4.2 is the CO2.
Kay Rubin's in the foreground getting some photos with Chris Cassidy just floating up next to Anatoly Ivanishin there in the hatch of the Soyuz. Again, this is recorded video from just around 3:20 p.m. Central Time, and you can see the hatch being closed. Again, that occurred this afternoon at 3:24 p.m. Central Time. That is the Soyuz hatch there that you see closing. Next step was also to close the space station side of the hatch, so that when the Soyuz moves away, the space station will also be protected. That occurred just a couple minutes later at 3:26 p.m. Central. And there's the new space station commander closing the space station side of the hatch. That's Sergei Ryzhikov there. Again, the Soyuz hatch closure took place at 3:24 p.m. Central Time today, with the space station hatch following at 3:26, and that was some recorded video of those activities that we weren't able to see real time. That activity set the stage for Expedition 64 crew members, NASA astronaut Kate Rubins and Roscosmos cosmonaut Sergei Ryzhikov and Sergei Kudzverchkov to stay behind today as their Expedition 63 crewmates return to Earth. The next step on the journey will, of course, be undocking. Again, that's coming up at 6:32 p.m. Central Time, just about 14 minutes away now. Once the appointed time arrives, Soyuz Commander Anatoly Ivanishin will send a command to open the hooks and latches between the Soyuz and the Poisk Mini Research Module 2, where it's been docked at the space station since April. Once the two vehicles are disconnected, the Soyuz thrusters will automatically fire and back the spacecraft away from the Poisk at a speed of just over a quarter mile per hour. Within 3 minutes of undocking, the Soyuz will be about 50 feet away from the space station, at which point Ivanishin will be able to conduct the first separation burn, firing the Soyuz jets for about 8 seconds to begin moving away from the space station at a rate of about 1.2 miles per hour. You can see a graphic here of how that will look. When it's almost 200 feet away, in about 4.5 minutes after undocking, the engines fire again for 15 seconds, speeding the spacecraft up to 3.5 miles per hour. That should get it to a point about 20 miles away in time for the scheduled 9 o'clock deorbit burn. As you can see, after that deorbit burn, the descent module of the spacecraft will be separated from the rest of the spacecraft for the final portion of the landing. Parachutes and then soft landing jets will slow it down for its landing in Kazakhstan at 9:55 p.m. Central. Since the hatches between the Soyuz and the Poisk Mini Research Module were closed at 3:24 p.m., the crew inside the Soyuz has been steadily making their way through their checklist in preparation for their landing tonight. Soon after that hatch closure was confirmed, they took their Soyuz off of the space station's power and put it on autonomous power, then started entering the settings needed for deorbit, such as their state vectors and the change in speed for the deorbit burn. They also depressurized the vestibule between the Soyuz and the Poisk module and performed a series of leak checks. And then they got themselves ready by getting into the so-called spacesuits that they'll be wearing during the journey home. With that done, they're ready to move into the descent module of the Soyuz, which contains the custom seats that they use during launch and landing to soften their touchdown. It also has all the controls and displays necessary for flight, as well as the life support systems, batteries for re-entry and landing. And of course, it also has the parachutes and soft landing rockets that will slow the Soyuz just before its touchdown. It's the only portion that will stay with the crew all the way back to Earth. The orbital module, which is what is directly connected to the station's Poisk module, will separate from the descent module about 28 minutes after the deorbit burn, when the Soyuz is about 87 miles above the Earth. We're about 10 minutes away from today's scheduled 6:32 p.m. Central Time undocking. is the view coming from the Soyuz, looking out at the space station, and it's what the crew will be seeing as they move away from the space station. Again, that undocking is scheduled to start in about 9 minutes now at 6:32 p.m. Central. That will set the crew on their way for undocking, for a deorbit burn at 9 p.m. and landing at 9:55 p.m.
Москва 2:24:00, включили передачу плюс.
Moscow at 2:24:00. We activated the closed transmitter. Copy.
Передатчик основной.
The main transmitter.
Включаю дисплей. Принято.
And activating display plus TV. And I'm ready to issue the E2 command.
Да, подтверждаем выдачу команды 02:25.
We confirm at 02:25:00. We confirm the command.
Выдал 2:02:25:00.
02:25:00. Command has been sent. We have pressurization, accelerometer.
Принято.
We copy.
Так, есть цепка. Коммуникаторный режим.
We have indicator mode.
Принято.
Copy.
Разворот. Весов пока нет.
We don't have GSO yet.
Принято.
Not in attitude yet. The CADO parameters.
I promised earlier that we would try and answer some of your questions over the course of the night, and we've had a few people sending those in using the hashtag AskNASA. You can keep doing so on social media if you have a question about the Expedition 63 undocking and landing, but we're going to go ahead and take a few of the ones that have already come in now. The first one is coming from Caitlin, who's asking what happens between hatch closure and undocking. There are a number of things that the crew needs to do once they get the hatches between the two vehicles closed. One of the main things is they need to get into their spacesuits, the SOCOL launch and entry suits that the crew wears both when they launch into space and for their return home. It would protect them in the case of an emergency, and is one of the key things that they have to do before they get into their seats to come home. Also conduct a number of leak checks between the two vehicles, so make sure that both of them are going to be safe once they separate from each other, and then begin entering some of the information that they'll need for today's deorbit, leading to that 9:55 p.m. landing.
And 02:29:30 is the next command.
Next up, we have Jake, who is asking how many G-forces would the crew feel on re-entry. That is about 5 Gs for Soyuz landing. It can vary a little bit, but in general, crew members seem to say that the harder part is the actual touchdown. That has been compared to a soft car crash. Even with the parachutes and soft landing jets slowing the Soyuz down, it can be a bit of a wild ride once they do land on the steppes of Kazakhstan. Jonathan Haley is asking, with Expedition 63 returning to Earth, who is going to be staying behind on the space station? That is the Expedition 64 crew. They are going to be alone there for a couple of weeks at least. That is NASA astronaut Kate Rubins, as well as Roscosmos cosmonauts Sergei Ryzhikov and Sergei Kuzberchkov. They'll have the space station to themselves for just a little while until the SpaceX Crew 1 arrives. That is going to be the 4 astronauts coming up on board the first operational SpaceX Crew Dragon mission. They are scheduled to launch in November, and that will be bringing up Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi. Kat is asking, is there anything specific or exciting that the Soyuz is bringing back to Earth from space station? And the main thing that the Soyuz brings back to Earth is the astronauts themselves. There's not just a whole lot of room. As I mentioned earlier, the 2 modules that actually we'll see backing away from the space station will separate, and only the descent module will return to Earth with the crew members inside. So there's not much room for cargo, but the astronauts do manage to bring back a little bit of science and research, in particular their own science and research, since they are one of the main guinea pigs on board the space station. So that is one of the first things that the teams on the ground will do once the crew is safely off and out of the Soyuz, is pick up those science samples and make sure that they get safely returned. And if you follow Chris Cassidy on social media at @astro_seal, you can see a picture of some of the science that he personally collected earlier today.
29:30, docking and internal transfer system power on.
And final question for now is from Jason, asking when will the next SpaceX Crew Dragon arrive at the space station? As I mentioned, that is going to be bringing up Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi, and it is currently scheduled to launch in November. We'll be taking a look at that mission and making a final call on the launch date sometime soon.
And the time is 02:30:30. Transfer hatches are closed. The indicator is also illuminated.
We're just a couple minutes away from undocking now.
I issued the command to open the hooks and
Anatoly Ivanishin, the Soyuz commander there, confirming that he sent the command to undock. That sets the undocking in motion, but will still take 2 minutes before the undocking actually occurs.
And S-13 command is no longer illuminated. Electrical connectors mated.
Merci. 3141.
02:31:41. Mechanical connection is no longer illuminated at 02:31:41.
And there you see, undocking right on time at 6:32 p.m. Central, while the Soyuz station are 263 miles above Russia. Expedition 63 crew officially on its way home now. They arrived at the space station on April 9th and have spent 196 days living and working there, greeting the first commercial spacecraft to launch humans into space and completing another link in the almost 20-year-long chain of continuous human presence at the space station.
The docking port is clean of any debris.
And this view coming from the crosshairs from the video camera on board the Soyuz itself. Looking at that Poisk module as it grows further and further away. This view coming from the International Space Station. Short drop out of video as the signal is handed over from one satellite to another, but we should be getting that back in just a moment. Coming up in just a moment, at 3 minutes after undocking, we'll have that first separation burn. That'll begin moving the Soyuz further out from the space station, getting it to a safe distance. And there's our video back. This again coming from the Soyuz itself, a view of what the crew sees as they back away from the space station.
We are standing by for thruster activation. Plus X. And we confirm dipole thrusters.
There's that first separation burn. Soyuz jets firing for just 8 seconds to ease it further away from the space station at just over a mile per hour.
Data is no longer illuminated, and we confirm the maneuver, start of the maneuver.
Team on the ground reports a good separation burn. Soyuz MS-16 now moving away from the space station, about 1.2 miles per hour, and coming up, the second separation burn.
Я скачаю дипол. 2, 4, 5, 6.
5, 6, unintelligible.
10, 11, 12, 13, 14, 15. Отработали 15 секунд.
All right, thruster firing time is 15 seconds. Burn is 15 seconds.
That second separation burn lasting, as you heard there, 15 seconds. That'll speed the spacecraft up by 3.5 miles per hour. Still not moving too fast, but certainly will be coming up later in their journey.
And we sent the E1 command, unintelligible. Moscow, how do you copy?
На связи. 02-37-20. Выдал за пределы динамических режимов. Принято.
You can see the Soyuz moving out there. That second burn puts them a safe distance away from the space station for the ultimate deorbit burn that will drop them back into the Earth's atmosphere at 9 p.m. Put them on a return course for Kazakhstan, landing at 9:55 p.m. Central.
Принято.
A1 command sent.
Выдаем Д8. Да, 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 да. Д8. Давай. 0238, 00 отключил. ССВП.
I am deactivating the docking and internal transfer system at 0238.
Выдаем В18. Давай. Отключил визор причал. Отключаю.
I am activating the headlight
Принято.
and deactivating visor pre-chow.
Отключил.
I have deactivated the headlights and the
Переводим рут транспорт.
translational hand controller is in transport position.
Everything continuing to go smoothly as the Soyuz MS-16 backs away with Chris Cassidy, Anatoly Ivanishin, and Ivan Wagner in tow, setting them on their final section of this journey of their mission, the 196 days in space.
170, 171. And then 466.
Так. Телевизор отключаем.
Do we want to deactivate visor?
Секундочку. Пока не отключаем. Ждем указаний. Приняли до указания.
We're standing by for your recommendations, Moscow.
Another view from the International Space Station cameras of the Soyuz getting further and further away. Two vehicles are now about 263 miles above the Pacific Ocean, east of Japan, and just about to begin heading southeast on this orbit around the Earth.
Отключаем телевидение, Иркутск. Да, принято. Отключаем телевидение.
Right, we are deactivating the TV system.
Выдал команду отключения ТВ 24130. Есть.
At 2:41:30, I sent the command to deactivate the TV system and display. Affirmative. All right, and rotational hand controller is in transport position.
Иркуты заложили уставки на спуск, и признак спуск на борту есть. Да, наблюдаем признак спуска. Принято. Что у нас со связью?
What's with the comm?
Что у нас со связью?
Guys, what's with the comm?
Помеха каждый раз.
There is so much interference. Okay, and where are we at?
47.
We are moving on to page 47.
секунды. Напоминаю, следующая команда у нас 03:45:00, включение видеокамер GoPro в режим видеозаписи.
Приняли 3:45.
Unintelligible.
Ну и до этого нужно провести подготовку к работе по 48-й.
Still seeing good views of the Sojuz moving further and further away from the space station. These coming from the International Space Station's exterior cameras. Inside that Sojuz MS-16, the Expedition 63 crew now on their way back to Earth for a landing that's scheduled for 9:55 p.m. Central Time today. Again, they undocked at 6:32 p.m. Central, slowly backing away from the International Space Station now, with the aim of getting to a good spot for their deorbit burn that will be taking place at 9 p.m.
Давайте ближе к времени 03:40, наверное, там.
Хорошо, 3:40.
We'll ask again. We're starting to work for page 48 at 0340.
Sojuz MS-16 is now safely backed away from the International Space Station following that 6:32 p.m. Central undocking, and right now the space station itself is maneuvering into its post-undocking attitude. So at that point, we're going to take a break in our coverage. We are going to be back at 8:30 p.m. Central Time for the Sojuz's 5-minute and 20-second deorbit burn that's scheduled for 9 p.m. Central Time. And from that point, we'll stay with you until the crew has landed and is out of their vehicle. Again, that landing is scheduled for 9:55 p.m. Central Time. So we are hoping that you'll be back with us in just about an hour and 45 minutes for our continuing coverage of the Sojuz MS-16 landing today at 9:55 p.m. Central. We'll see you back at 8:30 p.m. for continuing coverage, and this is Mission Control Houston. Good evening and welcome back to the International Space Station Flight Control Room. The MS-16 Sojuz is currently still docked to the Russian Poisk module of the International Space Station, but not for long. Here in the Space Station Flight Control Room, the team is preparing for undocking of the Sojuz MS-16 and the 3 crew members it's carrying inside. But that is still a few minutes away. That's coming up at 6:32 p.m. Central Time. And I'm Brandy Dean. NASA's Expedition 63 Commander Chris Cassidy, along with Sojuz Commander Anatoly Ivanishin and Flight Engineer Ivan Wagner, both of Roscosmos, closed hatches between the rest of the International Space Station at 3:24 p.m. Central. Since then, the station has maneuvered into undocking attitude, and the crew has been working through the last leak checks, getting into their so-called spacesuits that they'll wear for landing, and working through the other activities that have to happen before today's undocking. Despite a slight delay in the hatch closing, while the crew did some troubleshooting with a video camera, all the work since then has gone pretty smoothly, and we're now standing by for the Sojuz's undocking, again scheduled for 6:32 p.m. Central Time, coming up in just 31 minutes. That undocking will be followed by their deorbit burn at 9 p.m., which will put them on course for a landing southeast of Jeskistan, Kazakhstan at 9:55 p.m. Central Time today. That's going to wrap up a 196-day stay at the space station and mark the official transition from Expedition 63 to 64. As Expedition 63 Commander Chris Cassidy transferred authority to Expedition 64 Commander Sergei Ryzhikov ceremonially on Tuesday, but that won't be official until they undock. It's still Expedition 63 until the Sojuz MS-16 has left the space station. And it was a very busy and historic mission. Over the course of those 196 days, the crew welcomed 5 visiting vehicles, including the first commercial vehicle to deliver crew members to the space station, the SpaceX Dragon, with NASA astronauts Bob Behnken and Doug Hurley on board. They joined Cassidy, Ivanishyn, and Wagner for 2 months of the expedition during their flight test of the spacecraft, which launched on May 30th and landed on August 2nd. Other than that, the 3 astronauts have been on their own, except for about a week at the very beginning of their stay in space, before they relieved the Expedition 62 crew members, Andrew Morgan, Jessica Meir, and Oleg Skropochka, and also for the past week when they've been handing over to their own relief. Expedition 64, made up of NASA's Kate Rubins and Roscosmos's Sergei Ryzhikov and Sergei Kudskirchkov.
Irkut, the next measurement.
In addition to all those spacecraft carrying people on board, they saw the arrival and departure of a number of cargo vehicles as well. They were on hand to say goodbye to Russian Progress 74 and Northrop Grumman Cygnus 13, and to greet their replacements, Progress 76 and Cygnus 14. They were also present for both the arrival and departure of the Japan Aerospace Exploration Vehicle's HTV, or Exploration Agency HTV vehicle number 9. Amidst all that traffic, the crew still managed to get a great deal of work done. While the Crew Dragon was at the space station, Cassidy conducted 4 spacewalks with Bob Behnken, spending a total of 23 hours and 37 minutes outside in the vacuum of space, while the 2 replaced aging nickel-hydrogen batteries with new lithium-ion batteries. That brought Cassidy's spacewalking total to 54 hours and 51 minutes over 10 spacewalks that spanned his 3 missions. With that, he is tied for most spacewalks by U.S. astronaut and is 9th on the all-time list of time spent spacewalking. Cassidy also worked on a number of science experiments during his time at the space station. Just to name a few examples, he helped to investigate cancer therapies using microgravity as part of the OncoSelectors experiment. He also contributed to research on water droplet formation and water flow as part of the droplet formation study, and worked with the cube-shaped free-flying robots Astrobee to test out their use as an astronaut assistant for routine duties. With his landing coming up at 9:55 p.m. Central today, Cassidy will have spent a total of 378 days in space over his 3 space missions, putting him at 5th place on the list of most time spent in space by a U.S. astronaut. And just a reminder for those of you following along at home, we'd love to answer some of your questions over the course of our coverage tonight. If you have a question about Expedition 63's undocking and landing, you can send it to us on social media using the hashtag AskNASA. We'll try and answer a few of those over the course of the night. So again, go ahead and start sending those to us using the hashtag AskNASA, and we'll be watching for them. Here in the Space Station Flight Control Room, Flight Director Chris Edelin is leading the team for tonight's activities, with Dave Marschke beside him manning the Capcom console. Team here is getting ready to perform their go, no-go poll for the Sojuz undocking, ensuring that they are ready to support from here in Houston. And in Kazakhstan, a number of officials and vehicles are standing by in preparation for the landing. A total of 12 Mi-8 helicopters will be deployed for Soyuz landings to various areas to await touchdown. 8 are at the expected landing site southeast of Jezkazgan. 2 more will be ready about 250 miles away in the area where touchdown would occur if a ballistic entry occurred. And a final 2 helicopters will loiter midway between the 2. We are, of course, not expecting a ballistic entry, but as always, we will be prepared for one. Also deployed for landing are 6 all-terrain vehicles and 3 Antonov airplanes that serve as flying command centers. They'll have direct communication with the crew and will relay those communications back to the flight control team outside of Moscow. That whole team should have pretty good weather for all of their activities. The weather forecast at the landing site is for temperatures around 45 degrees Fahrenheit. And they'll have a few clouds at 5,000 feet, scattered clouds at 20,000 feet, and winds out of the west at 14 knots. Visibility should be about 6 miles or more at the landing site by the time the Soyuz arrive. Again, that's scheduled for 9:55 p.m. Central Time. So definitely not a bad day as temperatures go in Kazakhstan in the fall. However, the crew won't have to spend a great deal of time outside regardless. As usual, the landing team will quickly erect a medical tent at the landing site so that the crew can work through their regular post-landing checkouts before boarding helicopters to Jezkazgan, where they'll get on airplanes to take them home. Final wrap-up of Expedition 63 began on Tuesday afternoon when Expedition 63 Commander Chris Cassidy handed authority for the space station over ceremonially to Expedition 64 Commander Sergei Ryzhikov. That handover will become official when Soyuz undocks from the space station in about 24 minutes. But in the meantime, let's take a look back at that change of command ceremony.
Welcome aboard the International Space Station to the Expedition 63 to 64 crew change of command. I'm NASA astronaut Chris Cassidy here, and with all 6 of us, it's an honor to be with this event with you guys right now. You know, Expedition 63 has gone by super fast. We joke around that there's only Mondays and Fridays, and it's a big blur of time between. And when we started the mission, the pandemic on Earth was just starting, and now we are returning to Earth, and our fellow crewmates here had to train through those 6 months. Our time on board has been very interesting. We've had some time as a 3-person crew. We had some time as a 6-person crew, both at the beginning with Drew and Jessica and Oleg, and now with Sergei, and Kate. And then in the middle, we had a time as a 5-person crew with Bob and Doug, and we had the privilege of welcoming the SpaceX demo mission on board the International Space Station. Sprinkle in there some spacewalks and some Progress cargo vehicles and some American cargo vehicles and some crazy situations with the space station systems. It's just been an incredible 6 months of our lives. But experiences are nothing without the people that you enjoy those experiences with. And I must say, it's been really an honor to be with my friend Tolia and Ivan. Couldn't have asked for a better team of people to be here with. And when we had just a crew of 3, we spent several cozy days in just the service module, and it was just a wonderful, wonderful time. I also want to give a shout out, as I mentioned, to Drew, Jessica, and Oleg. It was great to be with them. Bob and Doug, certainly we had 2 wonderful months, and then this week has gone by super fast with Sergei, and Kate. Thank you for being part of it with us. And so with that, we have this small tradition where there's a key to the International Space Station, which didn't exist when I was here 7 years ago. I don't remember this, but now we have this, and I think it's very cool. It symbolizes the tool that we use on the Russian hatches to open and close the hatches, and it's a very appropriate key of the space station. It symbolizes the camaraderie that we have between all of the space agencies. And Sergei, it's with great pleasure and honor that I present you this key and command of the International Space Station. Congratulations.
Thank you. Thank you very much. It's a great day. It's an unforgettable event, and this key remind me time when I was a pilot and we kept key of sky, and now we keep key of space, and it's very interesting, very honorable for me, and we are very happy to join our crewmates and left this week together, and our mission is going to be very to have many events, many activity, and we are ready to continue tradition to show how on board people have example for people on Earth, how we work together, how we help together, and how we like to be on board station. So thank you very much, whole ground team, and we are looking forward to work with you upcoming 6 months. Thank you.
Thank you very much, Houston. We appreciate your support, and over to you.
Station Houston, we are thrilled to be with you today as we mark the end of this amazing increment. Expedition 63, thank you for your hard work and accomplishments. You've all set an impressive example with your work ethic and dedication to the mission. Chris, Anatoly, and Ivan, safe travels home tomorrow. And Sergei, and Kate, we are looking forward to a great increment with working with you.
That again was video from yesterday's change of command ceremony. The next step for the crew was this afternoon's hatch closing, which occurred at 3:24 p.m. Central Time. We weren't able to see that video in real time because of a misconfiguration on orbit, but that issue has since been fixed, and the crew was able to send down recorded video of those final moments together. That's what you're seeing here.
Pressure now. 4.2 is the CO2.
Kay Rubin's in the foreground getting some photos with Chris Cassidy just floating up next to Anatoly Ivanishin there in the hatch of the Sojuz. Again, this is recorded video from just around 3:20 p.m. Central Time, and you can see the hatch being closed. Again, that occurred this afternoon at 3:24 p.m. Central Time. That is the Sojuz hatch there that you see closing. Next step was also to close the space station side of the hatch, so that when the Sojuz moves away, the space station will also be protected. That occurred just a couple minutes later at 3:26 p.m. Central. And there's the new space station commander closing the space station side of the hatch. That's Sergei Ryzhikov there. Again, the Soyuz hatch closure took place at 3:24 p.m. Central Time today, with the space station hatch following at 3:26, and that was some recorded video of those activities that we weren't able to see real time. That activity set the stage for Expedition 64 crew members, NASA astronaut Kate Rubins and Roscosmos cosmonaut Sergei Ryzhikov and Sergei Kudzverchkov to stay behind today as their Expedition 63 crewmates return to Earth. The next step on the journey will, of course, be undocking. Again, that's coming up at 6:32 p.m. Central Time, just about 14 minutes away now. Once the appointed time arrives, Soyuz Commander Anatoly Ivanishin will send a command to open the hooks and latches between the Soyuz and the Poisk Mini Research Module 2, where it's been docked at the space station since April. Once the two vehicles are disconnected, the Soyuz thrusters will automatically fire and back the spacecraft away from the Poisk at a speed of just over 1/4 mile per hour. Within 3 minutes of undocking, the Soyuz will be about 50 feet away from the space station, at which point Ivanishin will be able to conduct the first separation burn, firing the Soyuz jets for about 8 seconds to begin moving away from the space station at a rate of about 1.2 miles per hour. You can see a graphic here of how that will look. When it's almost 200 feet away, in about 4.5 minutes after undocking, the engines fire again for 15 seconds, speeding the spacecraft up to 3.5 miles per hour. That should get it to a point about 20 miles away in time for the scheduled 9 o'clock deorbit burn. As you can see, after that deorbit burn, the descent module of the spacecraft will be separated from the rest of the spacecraft for the final portion of the landing. Parachutes and then soft landing jets will slow it down for its landing in Kazakhstan at 9:55 p.m. Central. Since the hatches between the Soyuz and the Poisk Mini Research Module were closed at 3:24 p.m., the crew inside the Soyuz has been steadily making their way through their checklist in preparation for their landing tonight. Soon after that hatch closure was confirmed, they took their Soyuz off of the space station's power and put it on autonomous power, then started entering the settings needed for deorbit, such as their state vectors and the change in speed for the deorbit burn. They also depressurized the vestibule between the Soyuz and the Poisk module and performed a series of leak checks. And then they got themselves ready by getting into the so-called spacesuits that they'll be wearing during the journey home. With that done, they're ready to move into the descent module of the Soyuz, which contains the custom seats that they use during launch and landing to soften their touchdown. It also has all the controls and displays necessary for flight, as well as the life support systems, batteries for re-entry and landing. And of course, it also has the parachutes and soft landing rockets that will slow the Soyuz just before its touchdown. It's the only portion that will stay with the crew all the way back to Earth. The orbital module, which is what is directly connected to the station's Poisk module, will separate from the descent module about 28 minutes after the deorbit burn, when the Soyuz is about 87 miles above the Earth. We're about 10 minutes away from today's scheduled 6:32 p.m. Central Time undocking. is the view coming from the Soyuz, looking out at the space station, and it's what the crew will be seeing as they move away from the space station. Again, that undocking is scheduled to start in about 9 minutes now at 6:32 p.m. Central. And that will set the crew on their way for undocking, for a deorbit burn at 9 p.m. and landing at 9:55 p.m.
Москва 2:24:00, включили передачу плюс.
Moscow at 2:24:00. We activated the closed transmitter. Copy.
Передатчик основной.
The main transmitter.
Включаю дисплей. Принято.
And activating display plus TV. And I'm ready to issue the E2 command.
Да, подтверждаем выдачу команды 02:20.
We confirm at 02:25:00. We confirm the command.
Выдал 2:02:25:00.
02:25:00. Command has been sent. We have pressurization, accelerometer.
Принято.
We copy.
Так, есть цепка. Индикаторный режим.
We have indicator mode.
Принято.
Copy.
Разворот. GSO пока нет.
We don't have GSO yet.
Параметр КДУ.
Not in attitude yet. The KDO parameters.
I promised earlier that we would try and answer some of your questions over the course of the night, and we've had a few people sending those in using the hashtag AskNASA. You can keep doing so on social media if you have a question about the Expedition 63 undocking and landing, but we're going to go ahead and take a few of the ones that have already come in now. The first one is coming from Caitlin, who's asking what happens between hatch closure and undocking. There are a number of things that the crew needs to do once they get the hatches between the two vehicles closed. One of the main things is they need to get into their spacesuits, the SOCOL launch and entry suits that the crew wears both when they launch into space and for their return home. It would protect them in the case of an emergency, and is one of the key things that they have to do before they get into their seats to come home. Also conduct a number of leak checks between the two vehicles, so make sure that both of them are going to be safe once they separate from each other, and then begin entering some of the information that they'll need for today's deorbit, leading to that 9:55 p.m. landing.
And 02:29:30 is the next command.
Next up, we have Jake, who is asking how many G-forces would the crew feel on re-entry. That is about 5 Gs for Soyuz landing. It can vary a little bit, but in general, crew members seem to say that the harder part is the actual touchdown. That has been compared to a soft car crash. Even with the parachutes and soft landing jets slowing the Soyuz down, it can be a bit of a wild ride once they do land on the steppes of Kazakhstan. Jonathan Haley is asking, with Expedition 63 returning to Earth, who is going to be staying behind on the space station? That is the Expedition 64 crew. They are going to be alone there for a couple of weeks at least. That is NASA astronaut Kate Rubins, as well as Roscosmos cosmonauts Sergei Ryzhikov and Sergei Kuzbirchkov. They'll have the space station to themselves for just a little while until the SpaceX Crew 1 arrives. That is going to be the 4 astronauts coming up on board the first operational SpaceX Crew Dragon mission. They are scheduled to launch in November, and that will be bringing up Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi. Kat is asking, is there anything specific or exciting that the Soyuz is bringing back to Earth from space station? And the main thing that the Soyuz brings back to Earth is the astronauts themselves. There's not just a whole lot of room. As I mentioned earlier, the 2 modules that actually we'll see backing away from the space station will separate, and only the descent module will return to Earth with the crew members inside. So there's not much room for cargo, but the astronauts do manage to bring back a little bit of science and research, in particular their own science and research, since they are one of the main guinea pigs on board the space station. So that is one of the first things that the teams on the ground will do once the crew is safely off and out of the Soyuz, is pick up those science samples and make sure that they get safely returned. And if you follow Chris Cassidy on social media at astro_seal, you can see a picture of some of the science that he personally collected earlier today.
29:30, docking and internal transfer system power on.
And final question for now is from Jason, asking when will the next SpaceX Crew Dragon arrive at the space station? As I mentioned, that is going to be bringing up Mike Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi, and it is currently scheduled to launch in November. We'll be taking a look at that mission and making a final call on the launch date sometime soon.
And the time is 02:30:30. Transfer hatches are closed. The indicator is also illuminated.
We're just a couple minutes away from undocking now.
I issued the command to open the hooks and
Anatoly Ivanishin, the Soyuz commander there, confirming that he sent the command to undock. That sets the undocking in motion, but will still take 2 minutes before the undocking actually occurs.
And S-13 command is no longer illuminated. Electrical connectors mated. Zero 02:31:41. Mechanical connection is no longer illuminated at 02:31:41.
And there you see, undocking right on time at 6:32 p.m. Central, while the Soyuz station are 263 miles above Russia. Expedition 63 crew officially on its way home now. They arrived at the space station on April 9th and have spent 196 days living and working there, greeting the first commercial spacecraft to launch humans into space and completing another link in the almost 20-year-long chain of continuous human presence at the space station.
The docking port is clean of any debris.
And this view coming from the crosshairs from the video camera on board the Soyuz itself. Looking at that poise module as it grows further and further away. This view coming from the International Space Station. Short drop out of video as the signal is handed over from one satellite to another, but we should be getting that back in just a moment. Coming up in just a moment, at 3 minutes after undocking, we'll have that first separation burn. That'll begin moving the Soyuz further out from the space station, getting it to a safe distance. And there's our video back. This again coming from the Soyuz itself, a view of what the crew sees as they back away from the space station.
To the moon to stay, and this is how.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
The hatches are long since closed and Sojuz has undocked. Now it's time to bring Chris Cassidy and Anatoly Ivanishin and Ivan Wagner home. Welcome back to Mission Control Houston in the International Space Station Flight Control Room, where the team is following along with the Sojuz MS-16's preparation for its upcoming deorbit burn at 9 p.m. even Central Time and landing at 9:55 p.m. southeast of Jeskisgan, Kazakhstan, wrapping up a record-setting mission. This will be the last orbit of the Earth for the Expedition 63 crew members on board the Sojuz. After spending 196 days in space, they'll land today, having orbited the Earth a total of 3,136 orbits and traveled more than 83 million miles. That's enough time to get a lot done, and the Expedition 63 crew certainly has. One of the major highlights was the historical arrival of the first commercial crew vehicle to deliver crew members to the space station. a SpaceX Crew Dragon with NASA astronauts Doug Hurley and Bob Behnken on board. They joined Cassidy, Ivanishин, and Wagner for 2 months of the expedition during their flight test of the Crew Dragon, which launched on May 30th and landed on August 2nd. Other than that, the 3 astronauts have been on their own except for about a week at the very beginning of their stay in space. That's when they relieved Expedition 62 crew members Andrew Morgan, Jessica Meir, and Oleg Skropochka. And the past week as well, when they've been handing over to their own relief, Expedition 64, made up of NASA's Kate Rubins and Roscosmos's Sergei Ryzhikov and Sergei Kuzberchkov. In addition to all those spacecraft carrying people, they've seen a number of cargo spacecraft come and go as well, including Russian Progress Vehicle, Northrop Grumman Cygnuses, and a Japan Aerospace Exploration Agency HTV vehicle. And of course, one of the primary purposes of the International Space Station is science, and Cassidy has been hard at work with a great deal of that too. Just to name a few examples, he's helped with a microgravity investigation of cancer therapies called the OncoSelectors experiment. He also contributed to research on the water droplet formation and water flow as part of the droplet formation study, and worked with the CubeSat free-flying robot Astropy to test out its use as an astronaut assistant for routine duties. And if that wasn't enough, while the Crew Dragon was at the space station, Cassidy also conducted 4 spacewalks with Bob Behnken, spending a total of 23 hours and 37 minutes outside the vacuum of space, while the 2 replaced aging nickel-hydrogen batteries with new lithium-ion batteries. That brought Cassidy's spacewalking total to 54 hours and 51 minutes over 10 spacewalks that spanned his 3 missions. With that, he is tied for most spacewalks by a U.S. astronaut and 9th on the all-time list of time spent spacewalking. With his upcoming landing, Cassidy will have spent a total of 378 days in space over his 3 missions, putting him at 5th place on the list of most time spent in space by a U.S. astronaut. Anatoly Ivanishин has also made 3 trips to space, but since all of his were during long duration, he has a total of 476 days in space, putting him at 25 on the all-time list for time spent in space. And since this was his first space flight, Ivan Wagner will land today with 196 days in space. Cassidy, Ivanishин, and Wagner said goodbye to their crewmates Kate Rubin and Sergei Ryzhikov earlier today with a hatch closing at 3:24 p.m. Central Time. This is some recorded video of that hatch closing. You can see Cassidy there along with Ivanishин. They said goodbye to their crewmates Kate Rubins, Sergei Ryzhikov, and Sergei Kuzberchkov earlier before closing those hatches. And that was the last view that we'll get of them until we see them coming out of the Sojuz on the ground in Kazakhstan. That again was hatch closing at 3:24, and since then, the Soyuz undocked from the International Space Station at 6:32 p.m. Central Time. Before doing that, they were able to get all the required leak checks and preparations done on time, and that set them on their way for today's 9:55 p.m. Central landing. They've since been moving into position about 20 miles away from the space station and are just about ready to go for the deorbit burn, which will take place at 9 p.m. Central, just 24 minutes from now. Here in the International Space Station Flight Control Room, Flight Director Chris Edelin is leading the team here in Houston as they follow along in tonight's activities with European Space Agency astronaut Andreas Mogensen beside him at the Capcom capsule. And in Kazakhstan, a number of officials and vehicles are standing by in preparation for the landing. A total of 12 Mi-8 helicopters deployed to various sites across Kazakhstan for Soyuz landings. 8 are at the expected landing site southeast of Zhezkazgan, Kazakhstan, and 2 more will be ready about 250 miles away in the area where touchdown would take place if a ballistic entry occurred. The final 2 helicopters will loiter midway between the 2. We are not, of course, expecting a ballistic entry, but we do always prepare for one just in case we need to respond to it. So that is part of the standard plan. Also deployed for landing are 6 all-terrain vehicles and 3 Antonov airplanes that serve as flying command centers. They'll have direct communication with the crew and will relay those communications back to Moscow. We've been asking you to send in your questions about tonight's landing using the hashtag AskNASA on social media, and you can keep sending those in, and we'll keep trying to answer them when there's time, starting now. From Isabella, we received the question, what's the current weather at the landing site? Weather-wise, things are looking reasonably nice at the landing site. Temperatures today should be around 45 degrees Fahrenheit and breezy, so it will be cool, but not nearly as cold as it can be at Soyuz landings. They'll also have a few clouds at 5,000 feet, scattered clouds at 20,000 feet, and winds out of the west at 14 knots. Visibility should be 6 miles or more at the landing site by the time Soyuz arrives. But the crew won't actually spend too much time outside regardless. As soon as the helicopters with the landing team arrive at the landing site, they'll begin setting up a medical tent where the crew can work through their regular post-landing checkouts before boarding helicopters to Zhezkazgan, where they'll board airplanes to take them home. Our next question is from Raul, who wants to know how long it will take for the astronauts to reach Earth. Well, from this exact moment, we have got about an hour and 13 minutes before tonight's 9:55 p.m. Central landing, but the point that determines when you land is actually the deorbit burn. That's when the Soyuz fires its engines to slow down and drop back into the Earth's atmosphere, and at that point, there's no going back. But it's a pretty quick trip. Once they've completed the deorbit burn, they'll be on the ground in less than an hour. Next up is Lucy, who wants to know what happens to the rest of the Soyuz module after the descent module separates. Just 18 minutes after the deorbit burn starts, once the Soyuz is on its way back to Earth, the descent module is going to separate from the orbital module and the propulsion module, and the descent module lands back on the Earth with the astronauts inside. The other modules are left to burn up in the Earth's atmosphere. That is actually the fate of much of what is launched into space. In fact, for most of our cargo vehicles, the entire spacecraft is filled with trash and then sent away to burn off as it falls through the Earth's atmosphere. It's a very convenient way to get rid of trash. Scott has a question about Soyuz control. He wants to know if the crew would be able to handle the deorbit and landing procedures on their own without ground assistance if they lost communication with the ground. But actually, there's really very little for the ground or the crew to do. The vehicle does most of the work on its own because most of its actions are automated. But the things that the crew doesn't require, the things that the crew does do not require assistance from the ground. So the answer is yes. And one more from now, this one from Kristen, who wants to know how Chris Cassidy is going to be getting home after landing. This is actually the longer part of the trip for Cassidy. Once he finishes his initial checkouts at the landing site, he and his crewmates are going to be getting on helicopters that deliver them back to Jessica's Gun, which is the nearest town. And there will be planes waiting for them there to take Anatoly Ivanishyn and Ivan Wagner back to Russia, while Cassidy is brought back here to Johnson Space Center in Houston. And for Cassidy, that trip will take almost another day. So that is all for now, but keep sending in your questions, and we will keep trying to answer a few before we get done for the night. You can get yours to us on social media using the hashtag AskNASA. We're now less than 15 minutes away from the Sojuz MS-16's deorbit burn. That's scheduled for 9 p.m. Central Time, when the Sojuz will be about 20 miles away from the space station. That burn is going to last 5 minutes and 20 seconds, during which the thrusters firing will act as a brake on the Sojuz vehicle while it's still 260 miles above the Earth, slowing it down by 128 meters per second, or 268 miles per hour, and dropping it out of orbit. You can see a graphic of how that will work here. Basically flips around, turns and fires its thrusters into the direction that it was traveling to slow it down and drop it out of orbit. About 23 minutes later, at 9:28 p.m., that's when the Soyuz is at an altitude of 87 miles above the Earth. The vehicle's computer will command the descent module of the Soyuz to separate from the rest of the spacecraft just above the first traces of the Earth's atmosphere. That's what you saw just there a minute ago. The orbital module on top, which is where the crew has a small amount of room to move around during its flight to the space station after launch, and the instrumentation and propulsion module on the bottom, which house the oxygen storage tanks, attitude control thrusters, avionics, and communications and control equipment. Those will all separate from the descent module in the middle where the crew is seated. The descent module contains personally contoured seats for the crew members used during launch, entry, and landing, as well as all the controls and displays needed for critical flight activities. It also has life support provisions, batteries for re-entry and landing, and parachutes and soft landing rocket engines to slow the vehicle just before touchdown. The orbital module and the instrumentation and propulsion module will burn up, as we mentioned earlier, in the Earth's atmosphere, while the descent module continues on with Cassidy, Evolution, Wagner, and Side. Then 3 minutes later, at 9:31 p.m., 60 miles or 316,000 feet above the Earth, the Soyuz will begin atmospheric re-entry. At that point, the descent module's computers will orient the capsule with its ablative heat shield pointing forward to protect it from the heat as it begins to fly through the Earth's atmosphere. And the crew will begin to feel the first effects of gravity again at that point. That's going to build through about 9:38 p.m. when they'll experience a maximum pressure or G load for the descent. And that will probably briefly cause them to feel 4 to 5 times the force of gravity. Just 2 minutes later, 15 minutes before touchdown, when the Soyuz is 35,105 feet above the Earth and traveling at a speed of about 514 miles per hour, the Soyuz computers will command the first of a series of parachutes to deploy. 2 pilot parachutes will come first, one 6.7 square feet and one 48.4 square feet. And together, they'll drag out the drogue chute, a 258 square foot parachute that slows the Soyuz down to 178 miles per hour. Drogue chute also will create a gentle spin for the Soyuz as it dangles underneath, which will help stabilize the capsule in its final minutes before touchdown. Just before touchdown, that drogue chute will be jettisoned to make way for the deployment of the 3,281-foot main parachute. It continues slowing the capsule down to a speed of about 16 miles per hour. At first, the capsule hangs beneath it at a 30-degree angle to the horizon to help with aerodynamic stability, but after one of the 2 harnesses connecting the parachute to the capsule is severed, the Soyuz will right itself so that it's in a vertical position through touchdown. When the capsule is just 16,000 feet or 3 miles from the Earth's surface, the vehicle's heat shield will be jettisoned and any residual propellant will dissipate. Without the heat shield, the Soyuz altimeter, an instrument that measures altitude by bouncing signals to the ground and back to the Soyuz, will be exposed to the surface of the Earth, and it will be used to provide the capsule's computers updated information on altitude and rate of descent. At that point, the vehicle's computers will also arm the module's seat shock absorbers. When the Soyuz reaches an altitude of about 39 feet, the cockpit displays will tell Anatoly Ivanishin, who's the Soyuz commander, to prepare for the firing of the soft landing engines. Those are 6 solid propellant engines, and they actually will be fired just 3 feet above the ground and 2 seconds before touchdown, allowing the Soyuz to slow down to 5 feet per second, or about 3.5 miles per hour, for a landing at 9:55 p.m. Central Time, or 8:55 a.m. local time in Kazakhstan.
And we see the maneuver.
Принято, есть разворот.
Copy. We see the maneuver. And I am sending the T3 command at I sent the command at 045010 and S9 is illuminated. Bow cooler dry fan off.
Сейчас, секундочку.
And can I send the next command a little bit earlier? G3.
Да, можно выдать G3.
Would be program 3 long com control activation. I am sending the, you have a go to send the command. And we have com session set up at 045352. We copy.
Иркуты, напоминаю.
Иркуты, just a reminder.
Ведем в формате отработанное время.
Please.
Импульс.
Activation and how long it worked for. How long was the burn? Okay, we copy, we remember.
Less than 5 minutes to go now before that 9 p.m. Central Time deorbit burn coming up. That's going to drop the Sojuz MS-16 out of the Earth's atmosphere and begin the journey home for the crew on board. NASA's Chris Cassidy and Roscosmos's Anatoly Ivanishin and Ivan Bogner, who have all spent 196 days on board the International Space Station. We'll be wrapping that up today with a 9:55 p.m. landing.
3-. Two minutes.
Just 2 minutes left now until the deorbit burn begins. It's going to last 5 minutes and 20 seconds, and that will slow the Sojuz down enough to drop it back into the Earth's atmosphere and allow it to continue on its journey towards the steppe of Kazakhstan, where they'll be landing today.
And 1 minute, we do confirm. Sojuz ready, and SKD covers are open. Orbital maneuver engine covers are open.
Crew reporting all systems are ready for the deorbit burn to begin. That's less than 30 seconds away now. And again, that's going to last 5 minutes and 20 seconds.
Okay, propellant is 423. And we're not wasting any propellant here for all the 8 seconds. We have a third
burn has begun now.
On the nozzles, thruster nozzles. Inaudible. 30 seconds, 13 meters. Copy. KDU parameters are nominal. The combined propulsion system at 45-19 meters. KDU parameters are nominal, and 13.7 on the nozzles.
1 minute into today's deorbit burn. Again, last 5 minutes and 20 seconds.
KDU parameters are nominal. We have 12.5 on the nozzles. Copy. At 15:32, 0:45, and 12.5, and KDU parameters nominal. Copy. 1 minute, 39.2, 0.45 for Delta V. KDU parameters are nominal. Zero 45 Delta V, 12.6 on the nozzles. KDU parameters are nominal. Copy.
2 minutes into the burn now. As you're hearing, everything continuing to look good.
2 minutes. 59 seconds. Schedule parameters are nominal. 045 for Delta V. And 12.6 on the nozzles. 59.6, 0.46, and 12.6. And schedule parameters are nominal. 236, 0.46 for Delta V, 12.6 on the nozzles, and schedule parameters are nominal. Copy. And next, 0.46 and for the Delta V, and 13 on the nozzles.
Now, 3 minutes into the dual orbit burn, about 2 minutes and 20 seconds left.
And 046 for Delta V. Schedule parameters are nominal. 315, 876, 045, 12.2, and schedule parameters are nominal. 330, 94.1, 045, 12.8, and schedule parameters are nominal. Copy. 345, 045, and 13.2 and 12.8, and schedule parameters are nominal. Copy.
4 minutes in now.
4 minutes.
1 minute and 20 seconds left.
0.9, 0.45 for Delta V. Copy. 415, 113.7, 0.46, and 12.9. Schedule parameters are nominal. Copy. 430, 120.8, 0.46 for Delta V. 4210. We are done with the burn. The burn is complete.
And there you go. Complete deorbit burn now. That was about 5 minutes and 20 seconds long, and that was intended to drop the Sojuz, slow it down and drop it back into the Earth's atmosphere so that it could begin its journey home to the steppe of Kazakhstan today. Crew's now on their way for a 9:55 p.m. Central Time landing.
Bell pressure.
With the orbit burn complete, the next milestone that we'll be watching for is the separation of the Sojuz descent modules from the other parts of the spacecraft. That is going to be coming up at 9:28 p.m. Central Time, and you can see how it works here. That middle portion is where the crew, Cassidy, Ivanishин, and Wagner are all inside of. It separates from the other parts because it has the heat shield that will protect the crew as they return to Earth. Since we've got a little bit of time before the separation of the descent module occurs, we can take a few minutes out for some more questions being sent in by users on social media. If you have a question of your own, you can send it in using the hashtag AskNASA, and we will try and answer a few more before the night's over. Right now, our first question is coming from Rebecca, asking how long it's going to take for the astronauts coming back today to physically reacclimate to life on Earth after their 196 days in space. That is a good question. You will hear from the astronauts that gravity is not a lot of fun to get reused to. Once you get to space, you get used to zero gravity pretty quickly, but getting used to gravity again can take a little bit of adjustment. They have about 2 months, 45 to 60 days set aside for reacclimation and also some technical debriefs. And that is basically their job once they get back to Earth for the first couple of months, just getting back into the groove of life here on the planet. It doesn't take quite that long to get totally reacclimated. That is probably more like a few weeks, although it probably varies from person to person, but they do have that time set aside to really dig into just returning to life on Earth and getting back to normal. Next question is coming from Wilson, who wants to know what the difference between ballistic entry and normal entry is. A ballistic entry, I mentioned earlier that we had some of the landing forces ready to support a ballistic entry if it did occur, and that is when the Sojuz comes in at a steeper attitude than planned for. It is a mode of re-entry that the Sojuz can support, but it's not the preferred one. It's a little bit of a rougher ride and takes the astronauts into a place where there's less landing support staged to help them. So we do always plan for an entry at our regular landing site, but we stage some support at the ballistic landing site just in case it's needed. And we've got a third question now from Ken, who is asking, during re-entry, do the astronauts communicate in English or Russian? So if you've been listening tonight, what you are hearing on NASA TV is an interpreter who is interpreting both the astronauts who are speaking in Russian and the Russian flight controllers on the ground who are talking back to them. So most of what you are hearing is actually taking place in Russian, and then we have a translator who translates both parts of those conversations. So sometimes it sounds a little bit like they're talking to themselves, but that is the full conversation between the two groups occurring entirely in Russian for this, since it is a Russian vehicle and the Russian flight controllers are primarily responsible for it.
I cannot even reach like this.
Иркуты, как нас слышно?
Irkuti, how do you read us? We have interference. We can hardly copy you.
Принято.
Copy.
Насколько мы поняли, давление ВСА стабильно, в БО.
SR pressure stable, we understood, and BO pressure practically zero. Is that correct? We did not copy. You're coming in garbled. In BO we have 20. It's basically zero.
About 15 minutes now until we do hit that point, 9:28 p.m. when the Soyuz descent module separates from the other parts of the Soyuz. Everything continuing to go smoothly as we head towards that. And we're just 40 minutes away now from landing. Once we get to that point, things will start happening pretty quickly with the atmospheric re-entry beginning at 9:31 and then the max G-load for the astronauts following that at 9:38.
Irkut, 15 minutes to separation. Yes, we confirm 15 minutes to separation.
Напоминаю, Иркут, репортаж ведем даже при отсутствии двухсторонних.
Please remember to continue your commentary, even if there is no two-way comment. In BO, we have 0. In the SR descent module, we have the pressure of 767. And after re-entry, in about 5 minutes, there will be a comm session for about 2 minutes. And we will be able to hear you, so you can report on the G-load. Are you ready? Yes?
35 minutes left until today's landing, and just 10 minutes to go until we get to that
10 minutes to separation.
that separation point that you just heard them talking about. That is again when the descent module that the crew members are in, Chris Cassidy, Anatoly Ivanishin, and Ivan Bogner, separates from the other elements of the Soyuz. The descent module has both the heat shield and the parachutes, which are key components of a safe landing, of course. So separation of the modules allows those elements to be exposed and then used during landing.
Сейчас.
Иркуты до разделения.
Irkute, 6 minutes, 6.5 minutes to separation.
Закройте гермошлемы, включите.
Please close your visors, activate the rescue automated system,
Также напоминаю о том, что надо отжать
and release
тангенты, отключить
your
передачу.
PTTs, deactivate your transmitters,
Тангенты без фиксатора.
and then you have to talk to us by pushing the PTT button without securing it.
Just 5 more minutes left before we get to that descent module separation, and we're going to take a few more questions while we have a minute from the Ask NASA group on social media. You can send yours in using that hashtag AskNASA. And our first one is from NASA Wanderer, who's asking what happens after the astronauts land. There will be a few minutes after they land while the helicopters with all the support personnel and the ATVs will move in to meet them. So they'll be on their own for a few minutes before they are then converged on, and the crew who's there to meet them begins working to get them out. They'll set up a ladder to help pull them out of the capsule, and then they'll be moved into chairs where they can sit and collect themselves a few minutes. We'll be able to hopefully see all that from the videographer who will be on site. They will all gather in 3 chairs in front of the small crowd that meets them, and then be taken to the medical tents after they are given the chance to make a few phone calls. And the medical tents will have a few checkups, and then they will go on the helicopters that met them there and move to Jessica's gone, where planes will be waiting to meet them and take them to either Moscow or Houston as appropriate. Next question from Jane, asking, are the American astronauts fluent in Russian, and how long does it take them to learn? All of the astronauts who go to the International Space Station, regardless of nationality, have to be fluent in both English and Russian. Those are the 2 official languages on the International Space Station, so even our international partners from Japan and Europe and Canada, all of them have to learn English and Russian as well, if they don't already know one of their other. That does take a long time, and a lot of the astronauts will tell you that that's one of the harder parts of their training. They begin that as soon as they are chosen as astronaut candidates, and spend a lot of their first 2 years of training getting the basics down, but they continue that training once they're assigned to a mission to make sure that they are ready before they get to the International Space Station and able to communicate with some of the ground teams supporting them. And finally, this one from Elizabeth, asking whether or not how many times the Sojuz capsules are reused. And the Sojuz is only used the one time. We do have some spacecraft that are reusable. Of course, the space shuttles were reused over and over, and now the SpaceX Crew Dragons are also going to be reused now that we are beginning to use them. But the Sojuz just the one time. That is all that we have time for now before the module separation begins, but you can go ahead and be pulling those in, sending those in to us using the hashtag AskNASA on social media.
Иркуты прошла метка разделения минус 214. Принято. Есть программа разделения.
Irkut separation program. Copy.
Иркуты минута.
Irkut 1 minute to separation. Prepare for separation of modules.
At this point, the Soyuz descent module is separating from the orbital module and the instrumentation and propulsion module, while the vehicle is about 87 miles above the Earth. Orbital module and instrumentation and propulsion modules are going to burn up in the Earth's atmosphere, while the descent module with the crew inside goes on towards that landing site in Kazakhstan. And confirmation here on the ground that we did get module separation.
We see separation on our telemetry, and 2.5 minutes till atmospheric reentry.
And that next milestone coming up at 9:31 p.m. Central Time. By that point, the Soyuz will be 62 miles above the Earth, and that's when atmospheric entry begins. The crew will begin to feel the first effects of gravity since they left Earth 196 days ago. Just about a minute left to go before we do reach that atmospheric entry point. Meanwhile, teams here on the ground are reporting that all the support teams are in place and will be ready when the Soyuz arrives back on Earth in Kazakhstan.
Иркуты, 30 секунд до входа в атмосферу.
Irkutsk, 30 seconds till atmospheric reentry.
Now at that point where the Soyuz capsule is going to be experiencing the atmosphere again. Again, this is when the crew will first begin feeling gravity again, 62 miles above the Earth. It's also when the descent module's computer will be orienting the capsule so that the heat shield is pointing forward, protecting it from the heat generated as it begins to experience the Earth's atmosphere.
Unintelligible.
At this point, the Soyuz is beginning to enter the plasma as it makes its way through the Earth's atmosphere. That does cause the communications with the ground to get a bit broken at some points. At this point, it's about 80 kilometers above the Earth, or 50 miles.
Unintelligible.
Still about 4 minutes before the Soyuz exits this area where it's going through plasma, as the Soyuz begins to experience Earth's atmosphere again, and the air around it heats up as it's moving through the atmosphere. That will end at about 9:38 p.m. Central Time. That's also when the crew will begin experiencing the heaviest G loads as they make their way back to Earth. Everything's still quiet as the Soyuz still in this period where it's going through the plasma and the Earth's atmosphere. Just about 3 minutes left of this, but everything going as planned, heading towards that 9:55 p.m. Central Time landing in Kazakhstan, southeast of Jeskivka. On board, of course, Commander Expedition 63 Commander Chris Cassidy and flight engineers Anatoly Ivanishin and Ivan Wagner, about to land back on Earth after 196 days in space.
Unintelligible.
Little less than a minute before the Soyuz exits the plasma and the crew experiences the heaviest G loads that they will get on their trip back. Soyuz MS-16 should be coming out of the plasma now. Again, the crew will be experiencing the highest G loads of their trip back to Earth, about 4 to 5 times what we experience in regular gravity on the ground.
Unintelligible.
Just 15 minutes now until the Soyuz MS-16 touches down in Kazakhstan. At this point, they're about 35,105 feet above the Earth, traveling at a speed just under 514 miles per hour. The computers will be commanding the first parachutes to deploy. Two pilot chutes, one 6.7 square feet and one 48.4 square feet. Those will pull out eventually the 258 square foot drogue chute, which will slow down the Soyuz to 178 miles per hour in only about 16 seconds and begin stabilizing the capsule. Less than 12 minutes to go now until the Soyuz MS-16 touchdown in Kazakhstan. That's coming up at 9:55 p.m. Central Time. As the Soyuz makes its way back towards Earth, the drogue parachutes will jettison and make way for the 3,281-foot main parachute, which slows the Soyuz down to about 15.6 miles per hour. 10 minutes now to go until today's 9:55 p.m. Central Time touchdown. You can hear that we're experiencing some bad audio right now, but waiting some confirmations from the teams at the landing site.
Atmosphere.
Nine minutes to go now. Hearing a little bit more audio. Hopefully that'll continue improving and we'll be able to get some additional updates. Again, we're heading towards that 9:55 p.m. Central Time landing. Teams here on the ground hearing from the forces, the landing team that is gathering at the landing site, that one of them does now have the crew in sight and everything is looking nominal. Just 7.5 minutes away from today's landing time. Again, getting reports from the team who is at the landing site that all is looking well.
VHF-1 is unintelligible.
Six minutes now until today's landing time, 9:55 p.m. Central Time. As you can tell, we don't have great audio connections with the crew at the moment, and no video yet. So we are relying on reports from the landing team who is gathering at the landing site to let us know what's going on. They did report that all is nominal, looking well, as the crew makes its way down towards that landing site. We hope to get some video for you. We'll keep trying on that, and as soon as we have it, we'll be sure to share it. In addition to reports from the team who is gathering at the landing site that everything is going well and nominally, they are also reporting that they have good communication back and forth with the crew, despite the fact that we can't hear it at the moment. So we'll continue giving you these updates as we get them, and hopefully we'll be able to see it for ourselves before too long. Again, we are heading down toward that 9:55 p.m. Central Time planned landing. That's 4.5 minutes from now. And reports are that everything is going nominally. Three minutes left to go before today's touchdown. Again, although we don't have good communication with the crew here, we do have reports that the team on the ground has good communication with them, and that everything looks nominal at this point. Still continuing on towards that landing at 9:55 p.m. A minute and a half left to go until touchdown. We still don't have video from the landing site at this point, so we'll be waiting on confirmations from the team on the ground. We'll pass those on as soon as we do hear them, and if we are able to get video in the meantime, we will definitely put that out as well. Just a little over a minute to go now. And there's the video we've been waiting on. Sojuz under its parachute, making its way down for today's landing. That should be coming up very soon at this point. Just before landing, ignition will get a notice from the computers to prepare to fire 6 solid propellant engines called the soft landing engines and slow the Sojuz down to 5 feet per second, or about 3.5 miles per hour. And you can see Sojuz has now touched down in Kazakhstan, 9:54 p.m. Central Time. After 196 days in space, 3,136 orbits, and 83 million miles, Chris Cassidy, Anatoly Ivanishin, and Ivan Bogner are home. Again, that landing coming at 9:54 p.m. Central Time, just a smidge early. Crew now safely on the ground. 9:54 p.m. Central Time was the landing point. That wraps up Chris Cassidy's third trip to space and his second long-duration mission. He spent 15 days in space during STS-127 in July of 2009, and another 166 days during Expedition 25 in 2013. With 196 days he added on with this trip, Cassidy now has a cumulative total of 378 days spent in space, earning him the 5th spot on the list of most time spent in space by an American. He also added 4 spacewalks to his previous 6, and with a total of 10 is now tied for most spacewalks by a NASA astronaut and 9th for all astronauts. He has spent a total of 54 hours and 51 minutes spacewalking over the course of his 3 spaceflights. Anatoly Ivanishin also had 2 previous days in space, and they were both long-duration missions, so he is coming home with a total of 476 days in space, enough to earn him the 25th place on the all-time list of time spent in space. And this flight was a first for Ivan Wagner, his first trip to space, so he has racked up a total of 196 days on this mission. Again, the crew landed safely in Kazakhstan at 9:54 p.m. Central Time. Saw them touch down here on the steppe of Kazakhstan. Landing crews now will be moving in and making way to meet the crew, help them out of the capsule, and then eventually into the medical tents, where they'll go through some preliminary tests and procedures, and then get on helicopters to take them back to planes that will take them home. You can see some of the helicopters beginning to make their way to the landing site now. Total of 8 Mi-8 helicopters with television equipment and that inflatable medical tent, as well as a number of NASA representatives on their way. Once again, the Sojuz MS-16 did touch down at 9:54 p.m. Central Time. That's 8:54 a.m. in Kazakhstan, where it landed. You can see the recovery team making its way to the landing spot. They'll begin landing and moving in to meet the crew, help them out of the capsule in the next few minutes. Once they do, hopefully we'll be able to get some video from the landing site. Again, there's a total of about 8 of those helicopters that are moving in towards the landing site with a number of NASA and Roscosmos representatives on board to help with various aspects of the landing procedures. Once they do arrive, a portable medical tent will be set up near the capsule where the crew will be able to change out of their launch and entry suits. And then Russian technicians will open the Sojuz hatch and help the crew members out. Since they've been living in zero gravity for the past 196 days, they'll be feeling the effects of being back on the Earth's surface. And so they'll be seated in special reclining chairs near the capsule for some medical tests. As soon as those have wrapped up and the crew is ready to go, they'll be helped into helicopters for a flight back to a staging site in Zhezkazgan before boarding their planes and coming home to Houston or Moscow as appropriate. Sojuz MS-16 and its 3 crew members have been on the ground for about 10 minutes now. Currently seeing a view of the steppe Kazakhstan in the early morning, southeast of Zhezkazgan. Can't really make it out here, but just beyond what we can see, the Sojuz did touch down at 9:54 p.m. Central Time. That's 8:54 in the morning local time. And the Sojuz, the landing team has been steadily moving in. We saw many of the helicopters land, and so they should be setting up around the Sojuz, getting ready to help the crew members out. And hopefully among them, a videographer that will be able to send us some video back of the crew as they get out of the Sojuz. As soon as we are able to get that, we'll get you that view as well. There are a few fewer people than normal out at the landing site today, with the various quarantine-related restrictions due to COVID. That does cut down on the number of people we send out. Among the people who are there, we have the Deputy Chief Astronaut Reed Wiseman and Flight Surgeon Joe Schmidt. Some of the people who are normally there who are not include the NASA photographer Bill Ingalls and NASA Public Affairs spokesperson Rob Navius. They weren't able to make it out to the landing site, although Navius is in Kazakhstan and may be able to give us a little bit of an update later. He won't be on site with the crew at this point. He will be waiting for them, and Jessica's gone. But hopefully we will still be able to get some video as the team gets set up there at the landing site. Again, they touch down at 9:54 p.m. Central Time. Commander Chris Cassidy of Expedition 63 and flight engineers Anatoly Ivanishin and Ivan Wagner. Teams here on the ground are getting reports from the team members at the landing site that the Sojuz MS-16 did land vertically. It can, of course, also land safely on its side, but in this case it landed upright. That will help the crew members get out in the normal fashion. And they also passed on that the crew is doing well, feeling good, and everything is looking nominal at that landing site. We've been taking questions over the course of the night from social media using the hashtag AskNASA, and you can send in your own question if you'd like. We'll try and get a few more of them answered before we wrap up our coverage. While we are waiting for a closer view of the crew, we'll answer a couple of that have come in the last few minutes First one coming from IDK, who is asking, why is there a communication blackout during the descent? That is, communication on this particular mission was a little worse than usual. We didn't have very good audio for a good part of the descent, but in general, that is because when the Sojuz is going through the plasma period, where it's beginning to experience the Earth's atmosphere again, and the capsule begins to heat up, and the air around it begins to heat up, that can cause a communication blackout as it engulfs the capsule. So that is kind of an expected part of the trip home for Sojuz, or really most capsules. But again, this particular case, the audio and communication was a little rougher even than we normally expect. And we also have a question from Victoria asking, what type of prep do the astronauts do before they suit up and get ready to head out? And that, I assume, is for launch. They do get to have a good breakfast before they suit up, and then once they do head out to the launch site, they are able to do some. Once they have suited up, rather, they do some leak checks and things like that before they get one final salute to the ground teams who prepare them, and also are able to get onto their vehicle and into the capsule for launch. All right, another question coming in from social media. Again, send your own questions in using the hashtag AskNASA. This one coming from Maggie and asking, will the astronauts be able to see their families right away, or do they have to be in quarantine for a period of time? The astronauts, they'll all be returning to their home bases, basically. For Chris Cassidy, that is NASA, and he will be able to see at least some of his family members who have been in quarantine themselves, so that they can have access to him right away. People who haven't been able to quarantine for various reasons would need to spend a little bit of extra time away from the astronauts coming home to make sure that they don't expose them to any illnesses or germs while they are in a state that we would consider immunocompromised. Having been on the space station where they don't have exposure to germs on a regular basis like we do here on the ground, we want to be sure that once they are back on Earth and start to experience that again, that they are eased back into that situation carefully. Again, you can send in your own questions for us using the hashtag AskNASA. Hopefully we'll get a chance to answer a few more before the night's over. And it's now been about 20 minutes since the Sojuz MS-16 touched down in Kazakhstan. Although we can't quite see them in this view, we can see the area that they landed in, and hopefully we'll get a closer view before too long. We have gotten reports from the teams that met them there on the ground that the capsule landed upright and that the crew on board is feeling good and doing well. As I mentioned earlier, Public Affairs Specialist Rob Navius is in Kazakhstan, although he's not able to be at the landing site for this particular landing. We do have him on the phone, though, to give us a report from what he is hearing there in Jezkazgan. Rob, can you hear us?
Hi, Brandy, and good evening to everybody. We're actually in Karaganda at the airport. I am aboard the NASA Gulfstream jet, preparing to take off for a short flight to the forward staging city of Jezkazgan, where other NASA personnel and search and recovery forces belonging to the Russian Rosaviatsa search and recovery team deployed from in helicopters to the landing site a few hours ago. We will be airborne very shortly for that brief flight to Jezkazgan. There is a Gagarin Cosmonaut Training Center aircraft that is parked right next to us. It too will be airborne for Jezkazgan, where we will meet the crew. This is going to be a quick and dirty recovery operation of the crew members today. The Russians have elected to scale down the usual hoopla that surrounds the return of crew members due to COVID cautionary procedures that they are operating under, with everybody wearing masks, maintaining as much social distancing as possible. What will happen is Cassidy, Ivanishин, and Wagner will emerge from the Sojuz MS-16. They'll be loaded into individual helicopters after medical tests in a nearby erected medical tent, and then they'll be flown from the landing site to Jezkazgan, about a 40-minute helicopter flight that will facilitate and hasten their ability to get on these respective planes, Cassidy on the NASA plane, Ivanishин and Wagner on the Gagarin Cosmonaut Training Center aircraft, fly back to their respective homes. We'll be flying back, of course, to Houston. They will be flying back to Star City, to the Gagarin Cosmonaut Training Center outside of Moscow. Everything has gone extremely smoothly. The NASA team deployed yesterday with other Russian search and recovery officials for an overnight, a quick overnight in Jezkazgan, which has been a familiar landing staging city. Jezkazgan lies to the southwest of Karaganda, which is where everybody had gathered earlier in the week for landing team briefings and other preparations. Brandy?
Hey, thanks, Rob. We appreciate that. And it looks like in Moscow, the flight control team there is beginning to get some video from the actual landing site. We just saw Chris Cassidy being helped out of the Soyuz capsule and onto the tarp where he and the other crew members will be gathering over the next few minutes. Try and get this video for you directly as well, but that was great to see him emerging from the capsule. Rob, I know that this is a little bit different for you. What kind of information are you able to get there?
We're getting information as it becomes available on a moment-by-moment basis. No problem getting information from the landing site through a variety of sources. And we heard the descent of the Soyuz under its chutes all the way down to touchdown. Just about the same time we arrived at the airport for boarding the NASA plane to head down to Jezkazgan. So it's basically the astronauts coming to meet us in Jezkazgan, with Cassidy climbing aboard the G5. There will be a pair of NASA flight surgeons attending to him on the flight all the way back to Houston with one refueling stop. And we should be back in Houston on Thursday evening, Central Time.
That'll be a long trip, but I'm sure it'll be good for him to be home. We're getting a little bit more video now as the crew continues to be extracted. Now seeing Yvonne Wagner. This again coming from Roscosmos. Looks like we've got 2 of the 3 crew members out now, and we'll keep watching for Anatoly Ivanishin, who should be up next. You can see a few of the NASA personnel who are gathered out at the landing site. All of these groups will be making their way back to Rob Navius and meeting them, and Jessica's gone, as he mentioned a moment ago. And there is an Anatoly Ivanishin as well out of the capsule. All the crew members looking good. As you can see, as Rob mentioned, all of the people who are meeting them there wearing masks to help protect them, an additional layer of protection, and beyond the quarantine that these members of the landing team would have gone through as well. Rob, if you're still there, I don't know what it is for you in Karaganda, but it looks like the weather's pretty pleasant for the team at the landing site.
Yeah, the landing time temperature, Brandy, was about 45 degrees Fahrenheit. A cold front moved through this region late yesterday and overnight and passed just to the east of the landing zone, just in time for touchdown. It is cloudy here in Karaganda, but in Jezkazgan, where we're headed here a short time from now, the sun should be out. The landing occurring 1 hour and 3 minutes after sunrise. And as we speak, the pilots, the NASA pilots out of Bellington Field nearby the Johnson Space Center, are revving up the engines to this NASA Gulfstream jet, and we'll be taking off a short time from now.
It's looking like the crew members might be moving into the medical tent before too long as well. We just saw the landing team there pausing for a group photo. Again, everybody looking really good for having just spent 196 days in space. Though we didn't get video of the landing itself, we did get reports, and you can just make it out there in the background behind the crowd. The Sojuz did land upright, and we're able to get confirmation from the teams who met them that the crew was feeling well. Now we're able to see that for ourselves. Everybody looking like they are feeling good and should be able to move on to the medical tent before too long. Rob, do you know if Cassidy has made any special requests for food that the team members might have ready for him on the plane?
That's a great question, Brandy, and actually, in true SEAL fashion, he made no request. He said whatever was on board would be just fine. As I mentioned, we will have one refueling stop en route to Houston, in which there'll be some catering of food for the passengers on board, including Cassidy. I think he's just happy to be home after 196 days in space.
Seeing Anatoly Ivanishin right now, but yes, all the crew members are looking pretty happy to be home. Team members still unloading some of the limited cargo that the Soyuz is able to carry as well. And Evolution there, being the first to move off towards the medical tent. This again is a tent that is brought with the team that meets the Sojuz at the landing site so that they can get into a protected area to change out of their Sokol spacesuits and go through a few preliminary tests before they then will get on the helicopters for that 40-minute ride that Rob mentioned back to Jessica's where they'll be met by planes to take them back to their various homes. Evolution and Wagner both on their way now to the medical tent. You can see what that tent looks like in this view. Chris Cassidy, it looks like making a phone call back to home and now on his way to the tent as well. Crew members are carried in the chairs just to be extra safe and prevent any possibility of a trip as they are experiencing gravity again for the first time in 196 days. So there, the crew members making their way into the medical tent. That is the last that we'll see of them tonight. Once again, today's landing wraps up a 196-day stay in space for the members of the Expedition 63 crew. With that 196 days added to his total, Chris Cassidy has now spent 378 days in space over the course of 3 missions. That puts him at number 5 on the list of time spent in space for U.S. astronauts. Anatoly Ivanishyn, meanwhile, also having made 3 journeys to space now has a total of 476 days in space, landing him a spot on the all-time list at the 25th place. And Ivan Wagner just completing his first space flight, now with 196 days on his total. with the crew safely in the medical tent and undergoing the final preparations before they get on their helicopters that are the first leg of their journey back to their homes. We are ready to wrap up our coverage for the night. We have the crew again safely landing in Kazakhstan at 9:54 p.m. Central Time today. That's 8:54 a.m. in Kazakhstan. And now they will begin making their way back to Moscow and, in the case of Chris Cassidy, Houston. It's been a momentous night of coverage with the hatch closure and undocking, deorbit, and landing. So we will be recapping all of that for you in a video file that will be airing at 1 a.m. Central Time here on NASA TV. So if you haven't gotten enough yet, you can take a look at that a little later tonight. And with that, we are going to wrap up our coverage of the Expedition 63 landing in Kazakhstan. Again, Chris Cassidy, Anatoly Ivanishin, and Ivan Bogner now safely home after 196 days in space. Thanks so much for joining us. This is Mission Control Houston.
Many pilots today don't go out with an immediate concern on their flight that they're going to run into the ground.
There is a problem in aviation of controlled flight into terrain.
Controlled flight into terrain is a case where you have a perfectly healthy aircraft that is what's called under controlled flight. In other words, it hasn't stalled. The pilot has full control ability of that aircraft. Yet, the aircraft ends up running into the ground in some way.
We're developing an automatic system to avoid a ground collision in the case of a fully functional aircraft,
which will automatically take control of the aircraft and automatically fly that aircraft away from the ground to save the pilot and the vehicle.
You don't need a multi-million-dollar fighter with digital fly-by-wire flight controls and very expensive hardware to implement a system like this.
We can put these algorithms that determine if there's an imminent ground collision. We can put them on a phone, which we've demonstrated with the droid, and give out that application.
When you go from an F-16 to something like a small UAV, we unplug the F-16 model, we plug in the small UAV model, and the rest of the system remains fairly much the same.
The technology that we're developing is important. We all have friends and colleagues who aren't with us anymore because they've run into the ground.
In the fighter area, there were about 1 or 2 people dying a year in the Air Force alone due to this controlled flight in terrain problem.
And that is when an airplane in perfectly good health crashes into the ground due to either pilot error or possibly the pilot is unconscious. As in fighter jets pulling high G, they may lose consciousness.
This is something that is not just confined to military aircraft, and it's not confined to UAVs. General aviation aircraft have a big problem with running to the ground. Pilots do for whatever reason. They're distracted, they can't see, they're in a fog bank.
Another case is where they are spatially disoriented. A good example of this is the JFK Jr. mishap that happened out on the East Coast a number of years ago.
They fly in sometimes extreme landing and takeoff locations up on mountains and things where their aircrafts don't have the aerodynamic ability to climb like they think they should.
A number of years ago, the Defense Safety Oversight Council, out of the Undersecretary of Defense for Personnel and Readiness, saw this problem and asked us to begin addressing it for fighters. In conjunction with the Air Force Research Lab, and Lockheed, We went out and did an initial program on the F-16 that would help address the problem on all Air Force fighters.
The ground collision avoidance maneuver chosen for the F-16 is a wings level climb. It climbs really well and it doesn't turn very well. So we don't try to turn in front of an obstacle, we try to climb up over the top of the obstacle. So regardless of what position you are in the F-16, if there's an impending collision, the airplane will roll to wings level and begin a 5 to 6 G wings level pull to clear the local terrain.
Okay, you're going to roll inverted, pull the nose down. It's going to roll itself upright and pull. Bingo. That's all automatic.
When you have that kind of automatic computer actuation of a decision, and you have to take into consideration a few more things than a warning system would. Don't make things worse is the first requirement. The second one is don't get in the way of normal piloting activities. And then the third is actually avoid collisions.
You got an autopilot that has the ability to really move this airplane around. We have the ability to put 6 Gs on this airplane. 6 Gs is not an easy thing to withstand. Fighter pilots get used to it, but still, 6 Gs when you didn't ask for it is a surprise, and it's really going to get somebody upset if it didn't have to happen.
Pull up, pull up, pull
It's
up,
just downright
pull
annoying.
up. Altitude.
What ends up happening is, after a few false warnings in the cockpit, a pilot either tunes out the warnings or turns the system off, and now that warning system provides no benefit.
In a fighter airplane, these collision avoidance maneuvers are very aggressive, so when they happen when they shouldn't, it's going to get away of the mission and it's going to upset the pilot severely. So avoiding nuisances in a fighter airplane is extremely important.
Their concern was that they weren't going to be able to carry out their mission and that the system was going to interfere. When they were shown that they could still do their mission and the system would actually wait longer than they would before initiating a recovery, they realized that this is not going to be a problem.
We believe that the system we developed in the ACAP program that's being fielded in the F-16 now will prevent above 90%, maybe as much as 98% of the mishaps.
We went out and tested the system against every historical category of controlled flight and terrain mishap that the F-16 has seen and based them on actual mishap cases. And we showed that across the envelope of operation of the system, it prevented every single mishap. We wanted to set up a system that would be easy to adapt to any different aircraft. At the heart of that is a modular software architecture.
And these pieces could be replaced, like an F-16 piece could be removed from the system and then a UAV piece inserted in, and then the rest of the algorithms could remain the same.
The F-16 represents the high performance top end of the performance spectrum. Airplanes that go real fast, climb real well, have great climb performance, but because they're going fast, their lateral turn performance is not as good.
In the case of a small UAV aircraft, like the Droid, we have a limited climb performance, something very typical of a general aviation aircraft. That performance model is very different.
And hopefully by anchoring both ends of that spectrum, we cover everything in between.
I think it makes it a lot more plausible that we could move to a different aircraft all across the spectrum of aviation.
One of the main costs in bringing any kind of a capability to an aircraft is the actual hardware.
A very small difference in where the airplane actually goes.
We had an eye in the future, and we recognized that eventually we wanted to get this into the general aviation community. And the best way to get something into the general aviation community would be to put something on tools that would be readily accessible to them.
So we moved the software from high-dollar fighter hardware processors to cell phone. And we've now migrated it onto a cell phone app.
At bare minimum, an app that would warn you. The more advanced versions would tie into an autopilot and actually take control and recover the aircraft. Not all general aviation airplanes have the autopilot that would be necessary, but at the bare minimum, it's an app that you can put on your cell phone and you would get a warning that you're about to run into something.
And that has enabled this technology to be potentially brought to the rest of the public for a much broader application and life savings.
I couldn't tell on that very first run.
The basic pieces that are needed to make this system work are an understanding of where the aircraft is. This is provided through GPS. You also need to know what the terrain is around you. So we have a computer model of the world that is a digital database of elevations. We then, inside the software, have a model of how well the aircraft can perform. And that model is very precisely tuned to that aircraft's performance capability.
Even since they first started developing this capability back in the 90s, capabilities of computers have gotten much, much better. The capabilities of GPS navigation systems have become better. The terrain database that allows the aircraft to know where the ground is, where the mountains and the valleys are, has gotten a lot better.
What we did was, how we kind of overcame that is we had to go to different sources, and we kind of have this mishmash of sources that are at different resolutions and different accuracies, and we put those together into our, a custom database that really I think is tailored more to what we're doing with AutoGCAS than the original databases were.
We have built a utility that compresses this terrain into a rather small file size such that we can carry the entire globe on the phone.
So we got a homogeneous, much more accurate digital terrain database to use now. So by using improved digital terrain, we get improved performance, and then by using an improved navigation system, we know where we are over that terrain much better. So we can predict the airplane to terrain collision geometry much better than we could 10 years ago.
The system monitors the approach of the ground and the aircraft's ability to maneuver to avoid it.
It predicts an escape trajectory that keeps the aircraft on a forward trajectory but pulls it up away from the ground. But it also computes a trajectory that moves the aircraft to the right and one that moves the aircraft to the left.
It compares these two things, the terrain and the aircraft's ability to avoid it.
If the system thinks that the aircraft is in trouble, it will select the last possible option of those three trajectories.
It isn't forced to try and climb over it. It can turn to the side of it. That's unique to the droid system that we've developed, and that is a feature that will likely have a great advantage when we take it and apply it to general aviation aircraft. On a typical day of flight, the team shows up here, and early in the morning we gather all our gear, we load it into our command and control van, head out into the field, assemble the aircraft, set up our systems, and then go through a series of tests.
Our first flight's going to be against that hill, pilot flown through the gap, and we're using 2 VHF frequencies for...
What I've been doing is operating our user interface, which is the link really between us on the ground, the test team, and the phone.
When we do a run, we actually set up the autopilot through the ground and control station. We give it a point that it's going to fly to that's actually under the ground. We're telling it to, really run into the ground. The system is monitoring this, and at the last instant disengages that autopilot system and uses the auto collision avoidance system to take control of the aircraft and avoid hitting the ground. Just over the course of our testing, and we went through our testing as rapidly as we could, there were no fewer than 5 fatalities and 7 mishaps that we could have prevented with that software on the very fighter aircraft that we were trying to design it for.
I think the system we're fielding now with the F-16 isn't perfect, but I think everybody in the field is going to love it, and I think it'll save lives.
Do we have the perfect answer? Of course we don't have the perfect answer, and that's something that's going to evolve over time.
But we're trying to save lives. We're trying to save pilots and passengers' lives from controlled flight and terrain.
NASA's taking the risk, and the Air Force is taking the risk to put the system on, and I really do, that it'll be game-changing and save a lot of lives and really be a benefit to society and really show what's possible.
I think it's a system whose time has come. There's no major obstacles from a technology standpoint. It does take work, it does take development effort, it takes flight tests to prove it.
The technology is out there to do this. It's a matter of bringing all the pieces together and sewing it together with software to make the capability happen.
On a remote peninsula in the South Pacific, a rocket and 10 small satellites are about to launch a new era in spaceflight. Rocket Lab's Electron rocket is a new player in the space arena, and those tiny spacecraft, called CubeSats, represent big dreams.
It's kind of like the preeminent, most exciting mission within the whole company. The whole team is just incredibly excited to have that NASA logo on the side of the vehicle and fly those payloads.
The NASA payload about to launch on the Electron rocket is called ELANA-19. ELANA stands for Educational Launch of Nanosatellites, part of NASA's CubeSat launch initiative. This is the agency's way of providing a path to space for CubeSats, compact satellites that pack a lot of science into a package about the size of a loaf of bread.
Space is no longer just for high-value science or the intelligence community. It is a place for a payload that you can create that can get up to space.
Until now, CubeSats have always launched with larger spacecraft, but flying as a hitchhiker limited where they could go and the science they could do. That's what makes this Rocket Lab flight so historic. It's the first time these small satellites are the stars of their own show, flying on a rocket designed for their needs. The 10 CubeSats flying on ELANA-19 were developed by teams from across the nation, from high schools and universities to NASA field centers. Da Vinci was developed by a student-led team at North Idaho STEM Charter Academy. It's designed to connect to students around the world by broadcasting education-related messages through amateur radio in Morse code. It also carries a Global Star modem and Arducam, allowing users to upload digital messages or see photos of Earth from orbit.
I don't know if anyone remembers like the Ovaltine messages and stuff on the radio way back when, but our goal is to do something like that where they have to tune in every week or every other week to get this new message and decode it and really dive into that information so that they develop an interest in space and they say, oh, hey, I can communicate with something that's not even on this planet.
RSAT was developed by a team of midshipmen from the U.S. Naval Academy in Annapolis, Maryland. This crab-like CubeSat has a pair of robotic arms designed to grab a host satellite and maneuver around it to take photos, or potentially even make repairs if a spacecraft isn't working properly. The CubeSat STF-1, or Simulation to Flight 1, is a collaboration between NASA Independent Verification and Validation Program with West Virginia University and small businesses. STF-1 will monitor space weather over Earth's poles and test the durability of new materials for use in LEDs. But it's also designed to demonstrate a simulation and test platform to aid in the development of future CubeSat missions. These CubeSats show that small satellites have an important and growing role in space exploration. NASA's Venture Class Launch Service was created in 2015 to provide CubeSats their own ride to space, expanding launch and science opportunities for small satellites and sparking a brand new segment of the space launch industry. Rocket Lab's Electron rocket is one of 2 vehicles NASA selected for Venture Class missions. It's smaller and lighter than other launchers in NASA's stable, but that's the whole point.
The intent is for the Venture Class launches to occur at a rapid pace that match the iteration and design cycle that CubeSats can go through. So instead of having a launch for a primary mission once every 2 years, once every 5 years, the real goal is to see Venture Class rockets get to a cadence where they can see regular access to orbit.
Many of the CubeSats on the ELANA-19 mission are designed to benefit future missions. Shields 1 was developed by NASA's Langley Research Center in Hampton, Virginia. Its objective? To test materials that could be used to shield spacecraft against radiation.
This is a radiation effects experiment where we're looking at the performance of the materials and the electronics, and it would have a potentially large impact for improving performance of future spacecraft.
NMTSat was built by approximately 50 undergraduate and graduate students, primarily from New Mexico Tech in Albuquerque, New Mexico. It's designed to use onboard sensors to collect data on Earth's magnetic field, take atmospheric weather measurements, and carry out an optical beacon experiment. The next spacecraft was developed by teams on opposite sides of the country, in Florida and California. It's called CHOMPT, which stands for CubeSat Handling of Multi-System Precision Time Transfer, This mission is a collaboration between the University of Florida in Gainesville and NASA's Ames Research Center in Mountain View, California. CHOMP uses lasers instead of radio waves to demonstrate new ways to navigate and network satellites in deep space. The Advanced Electrical Bus, or ALBUS, was developed by NASA's Glenn Research Center in Cleveland, Ohio. ALBUS will demonstrate shape memory alloy mechanisms for deployable solar arrays. It'll also serve as a pathfinder for high power density CubeSats.
The shape memory alloys themselves are really good technology because they are low mass, they can produce low shock, and we can reset them. So we can actually reset our mechanisms to test it again to deploy it to make sure we're going to have a successful mission.
While the CubeSats are prepared for flight, their ride, the Electron rocket, begins to take shape. Fully assembled, the Electron stands nearly 56 feet tall, a smaller rocket dedicated to launching small payloads. It's a 3-stage carbon composite vehicle topped by a payload fairing to protect the CubeSats during launch. The Electron's engines and avionics are manufactured here in the United States at Rocket Lab's facility in Huntington Beach, California. In fact, the company's Rutherford engine is the first ever oxygen kerosene rocket engine built using 3D printed main components. Then they're sent to Rocket Lab's facility in Auckland, New Zealand. Here, the company puts its engines to the test before final integration. It's also where Rocket Lab manufactures the vehicle's stages and payload fairing. But until the rocket is assembled and tested in New Zealand, the CubeSats will wait in California. It will all come together when the spacecraft arrive from Huntington Beach just a few weeks before launch. CubeSail was built by the University of Illinois at Urbana-Champaign in CU Aerospace. It carries a 250-meter solar sail ribbon, technology that's being evaluated for use on future spacecraft, such as scientific missions to interstellar space.
CubeSail is going to be doing a technology demonstration of the deployment technique as a stepping stone towards even larger missions we have planned on the road, like iSail and UltraSail.
The ISX CubeSat, or Ionospheric Scintillation Explorer, is a collaboration between SRI International and Polysat at Cal Poly San Luis Obispo, California. ISX is designed to take a closer look at plasma fluctuations in the upper atmosphere and learn more about how they affect radio communications with satellites. Up next is Ceres, the CubeSat Compact Radiation Belt Explorer. It was developed by NASA's Goddard Space Flight Center in Greenbelt, Maryland. Ceres will fly into Earth's Van Allen radiation belts to study the high-energy particles streaming toward the Earth from the Sun and learn more about how electrons in their radiation belts are energized and lost.
CubeSats go into the clean room and they do their standalone processing. So that's any sort of checkouts, charging. Basically, they're getting ready to get into that final package, the dispenser. That's the piece of hardware that's actually going to launch them out into space off of the rocket.
November 2018. With the Electron rocket ready for final integration and launch, the CubeSats are shipped from California all the way to Auckland, New Zealand. But the Electron rocket elements and all the Alana 19 CubeSats still have to make one more journey on Earth. It takes a caravan of trucks about 8 hours to make the 575-kilometer journey from Auckland to Rocket Lab's Launch Complex 1 at Mahia Peninsula on the island's east coast. But this remote launch site is worth the drive.
So from one single launch site, we can launch all the way to 39 degrees inclination, that's due east, all the way up to sun synchronous, which is about 98 degrees depending on the altitude. So that's the widest range of inclinations available from any launch site in the world.
On the ground at the Mahia Launch Complex, the rocket stages are carefully brought together and inspected to ensure everything is perfect. The CubeSats are installed on the Electron payload plate, the interface between the rocket and the satellites. Then Alana 19 is encapsulated inside the Electron rocket's payload fairing, where the CubeSats will stay until they're in space. The entire rocket is manually rolled out to the launch pad for a rehearsal of the launch day that's quickly approaching. Liftoff is planned for December 12, 2018, and the vehicle is ready. But dangerously strong winds keep the Electron on the ground for 4 more days. Their fortunes change on December 16th when the winds aloft finally go green.
5, 4, 3,
Mission.
2.
The Electron rocket's 9 Rutherford engines ignite, and history is made. Less than an hour into the flight, the Ilana 19 CubeSats are released. Instead of hitching a ride, these small spacecraft have a dedicated ride that can deploy each one to just the right orbit for maximum science. Ilana gives students and teachers a low-cost pathway to space to test new technologies, make new discoveries, and create new connections to each other and the future. Small satellites, big dreams, and even bigger potential for future CubeSats needing a venture-class ride into space. To launch with Ilana, visit nasa.gov/Ilana.
The safety discipline has a history of learning from the past and ensuring we don't forget those lessons. Sure, safety is built into our name, but every one of us at the Kennedy Space Center has the same responsibility. At NASA, our goals are daring and inherently risky. Sending humans to other planets means we're going to have to take some risks. We all need to ask ourselves, how do I balance risk and ensure mission success?
Okay, so on the mobile launcher here, we have dozens of high-pressure gas panels. They service the cryogenic systems, environmental life support systems, and other facility systems. And on these panels and between the panels, we have literally thousands of tube assemblies. Right now, we're going through our design certification process, and part of that process is to certify the pressure system. So when we do this pressure system certification, we work very closely with SNMA, particularly the Pressure Systems Manager's Office. Engineering prepares certification reports. We submit it to the Pressure Systems Manager's Office for review. They provide feedback to us and ultimately give us the final okay to certify the system. So while we were going through this process, we started submitting reports to the Pressure Systems Manager's Office, and they came back with some feedback for us about the vibration loads and the vibration analysis on tubing in the mobile launcher.
What we were seeing was these panels, even though they're shuttle heritage and they did survive shuttle launch loads, with the SLS rocket, we would have higher vibrational loads going into these panels. So we wanted to ensure that we wouldn't be exceeding the allowable stresses that are in our PVS codes and standards that we have to sign off the certification saying that these panels meet. So what we were thinking, the way to do this accurately would be to do a full finite element analysis. And since all these panels are unique, to pull that off would be an extensive amount of effort based on our analysis guys through engineering. It would take months, if not years, to do it all properly. And the overall benefit was probably low since we had confidence that these panels could survive a launch. We just didn't have the objective evidence to make that claim.
We worked really closely and we came up with basically about half a dozen different geometries and pretty accurately define all the tube assemblies we have in the mobile launcher. So our analysis group did analysis on some worst case scenarios using those different geometries to make sure that all of the supports that we already had installed and all of our tube routing was safe to operate and would survive the vibration loads during an SLS launch.
Right. This analysis was much more truncated than what it would have been required, but it did capture worst case scenario. The outcome of the analysis, we did have to add supports along some of the tubing runs because we found that they were unsupported, that stresses in certain areas would exceed allowables. But it was very minor compared to what the overall impact could have been to the schedule and cost to get us to where we're comfortable with using these panels with the SLS rocket causing the vibration on the ML.
Right, and this saved the engineering team a great deal of time.
Right. NASA. The agency that landed on the moon, launched the Hubble Space Telescope,
And took the first rover selfie? Yeah, that NASA. We also chase fires. This team is in the middle of a recovery operation. The California Department of Forestry and Fire Protection is using NASA satellite data to map the path of destruction after the 2018 Camp Fire.
NASA has the tallest fire towers. With our satellites looking down from space, catching images every day and every night, we're often the first to detect and then share information about fires, especially fires that are burning in remote locations.
That's where we can come in and provide a much better picture. And so I have NASA MODIS and VIIRS stuff, which we always use on Google Earth. You can kind of see the streets here. This is a neighborhood totally burned down.
A NASA Rapid Response grant allowed the team to study the impact of the Camp Fire just 4 months after it was contained. NASA provides crucial tools for both first responders and fire recovery managers, but there are even bigger implications for understanding the future of fire.
The information we collect from satellites helps us understand not just where and when fires are burning, but what kind of changes they're making to the ecosystems on the ground and our atmosphere up above. I'm Doug Morton, and I'm an Earth System Scientist here at NASA's Goddard Space Flight Center.
Doug is one of NASA's go-to scientists when it comes to making sense of how fires affect people and ecosystems.
You need 3 things to make a fire. You need something to burn. You need climate conditions that allow that fire to start and grow large. And you need a source of ignition. Today, the source of ignition is almost always humans. We can use information about rainfall and climate to anticipate landscapes that might become flammable in the future. That kind of predictive power, how we harness our understanding of the Earth system, has really helped us move forward in terms of anticipating and minimizing the risk to landscapes that might be flammable next week or even next season.
But the real work of science may be something that many people don't have a lot of visibility into. When we talk about taking a team of scientists and putting them into the field, that could mean weeks, months, or even years of collecting data.
The first time I spent in the Amazon was in the early parts of the 2000s, just at the peak of deforestation rates in Brazil. And I don't think anyone could make it to the end of that frontier landscape, standing at the edge of a road and looking in all directions and seeing towering columns of black smoke and not feel like there was an opportunity to be careful with our planet. Fires have been burning across the southern Amazon, an area where I've been working for the last 20 years. And so people have looked to me to explain, is this normal? One of the things I can do as a NASA scientist is I can go back in time. Our data record allows us to literally compare activities that are happening every day with these same days and the same kinds of conditions in previous years. From space, we're mapping fires across the entire planet, and that often takes us to remote locations. And the best way to partner and understand those remote locations is with people who live and work in those communities.
So that's what we did. This year, NASA is sending a blitz of missions into the field, and you're coming with us. Climate change is shepherding in a new era of fires that burn hotter and longer. And our pilots, our partners, our scientists and engineers, they've come prepared to meet that challenge.
Some of my days have been 14, 16, and 18 hours.
We don't hesitate to meet challenging conditions. You know, you can tolerate a lot for a day or two.
This mobile laboratory has been deployed for a very specific reason. The Shady Fire is burning nearby, and this team is gathering data that you can only get at night. Over the next several weeks, NASA and NOAA are teaming up in the field to study smoke from wildfires and agricultural burning. Here's what 24 hours looks like in the life of these fire chasers. The team's been keeping a close eye on the Shady Fire, burning just 4 hours northeast of the base of operations. After several days of watching the fire grow, the forecasting team decides to deploy the mobile laboratory and the NASA and NOAA planes. The ground crew and pilots are already preparing the plane by the time the forecasters give their daily briefing.
The more we learn about smoke, the better we'll understand health. My name is Amber Soya, and my role here is to determine what fires we should target. Smoke is related to respiratory illnesses, heart attacks, and even death.
For some of our scientists, understanding pollution has defined the course of their life's work.
I'm a physical chemist, but I'm also from what 60 Minutes called the most polluted city in America, Anniston, Alabama. When the opportunity came along to do this type of work, I really resonated with it.
Dr. Bruce Anderson is the Langley Aerosol Research Group lead and a seasoned veteran when it comes to doing field work in remote places. By 3 p.m., the NASA DC-8 and the mobile laboratory are about ready to go. Bruce and his team begin with a 5-hour drive to reach the fire. We'll catch up with them later. While the ground crew, pilots, and safety techs prepare for what will likely be 6 hours of flying through smoke plume after smoke plume, the scientists ready their instruments to capture data from the notorious Shady Fire. 30 minutes into the flight and the team has already reached the fire. Here's where the work begins. These flights are rare opportunities for scientists, so not a moment is wasted.
I think that studying fire and chemistry, it only comes together when you have a diverse team of scientists.
As the sun starts to set, the plume is harder for the pilots to see, and around 10 p.m., the plane heads home after a successful flight. Smoke sinks lower to the ground at night, and sometimes accumulates in valleys, which is exactly where Bruce and his team are waiting for it.
We'll set out, drive up there, find a place to position the van, then start cranking up instruments. It takes about a half an hour to an hour to get everything running and calibrated. It's a guaranteed bad night's sleep, but you know, you can tolerate a lot for a day or two.
This team of 5 scientists will be up almost every half hour checking measurements, replacing filters, and at one point repositioning the van to capture emissions more effectively. It's a long, cold night, but eventually it's dawn, and time to head back to town. By 7:30, the forecasters have already been awake for at least 2 hours selecting which fires the science team should target that day, including a scheduled return to the Shady Fire. In about 2 hours, the plane will be bustling with scientists preparing their instruments for the day's flight. And the whole cycle will start all over again.
I feel like the work that I do, the knowledge that I'm trying to pull together is important for the human race, you know, for our country.
This seems like an unlikely place for fires. In the winter, the landscape is still, but the warmer months can bring conditions that, combined with fire, can release dangerous amounts of carbon into the atmosphere, and in more ways than one.
What happens in the Arctic does not stay in the Arctic anymore.
I see that you're wearing a hat with a logo on it. Can you describe what that is? You don't have to take your hat off.
Well, that's good.
Kevin, in the orange jacket, is a close NASA collaborator. He and his team are used to getting their hands dirty to collect crucial fire data.
I'm wearing a hat right now from the Above Field campaign, and what you see is a big A, and it stands for, the trees tilting over with thawing permafrost.
Trees aren't the only thing getting warped by thawing permafrost. Buildings and even roads begin to buckle when the ground beneath them literally begins to liquefy. NASA's Above campaign is currently in the Northwest Territories to understand large-scale changes to permafrost.
Permafrost is basically, picture in your mind frozen dirt. Now, if you thaw the permafrost out, it changes from solid like rock or concrete to mud.
If you watched Season 1 of NASA Explorers, then you know that permafrost stores huge amounts of carbon. As a matter of fact, twice as much as what's currently in the atmosphere today. Now, thankfully, permafrost thaws really slowly, and therefore releases carbon really slowly. But here's where it gets complicated.
Fires in the high northern latitudes, permafrost regions, are getting larger, they're getting more frequent, getting more intense.
In the past, permafrost has had a reliable layer of insulation, mostly moss.
But if you have a fire, it burns off the vegetation. The insulation is essentially removed.
To summarize, changing climate means more fires, more thawing, more carbon in the atmosphere, and that accelerates warming. Permafrost is one of those important factors that affects life on Earth, yet it isn't really in the public eye, unless you live on it. But for Kevin, understanding this phenomenon is the best way to make the biggest difference.
See, way back in the 80s when I was in college, my mom got cancer and was dying. And I remember the last time I saw her, we were sitting down and she was in bed very sick. And she asked me, what did I want to do? And until then, of course, I was a typical teenager in college. I had no clue. But then it crystallized in my mind that I wanted to save the planet, and that was the words that I used. And so I decided my path for doing that was to go into spaceflight, save the planet by leaving it, I suppose. But then, circumstances changed, and then I started working on Earth observation. And it opened my eyes to what you can do with remote sensing and satellites, and what you could see and learn about the Earth from looking at it from space. And so I decided to go back to school, and I rethought of what I talked to my mom about, and I decided to go back to school, and I had become a scientist.
The hours are long and the work is hard, but these explorers wouldn't have it any other way.
This is really, tough country. You're really rugged, but it's also a very beautiful country. I think I can speak for nearly every scientist that I've worked with. They do this because they want to help. They want to provide the information and tools to solve problems.
NASA is a big and capable organization, but Earth science is a subject far too big for one country, one agency to tackle all by itself.
After nearly a decade of planning, this field campaign happened to be here just as an unusually dry season led to some of the most intense and large fires the region had experienced in the last 5 years.
We came here to look at the transport of smoke and what smoke does in the environment, particularly as it impacts clouds. And we had an amazingly intense smoke event that carried very high concentrations of smoke into a place called the Sulu Sea.
You might be surprised to learn that fires affect cloud formation, and NASA is studying that dynamic relationship.
NASA is a big and capable organization, but Earth science is a subject far too big for one country, one agency to tackle all by itself.
And when you can't do it by yourself, you call up your colleagues halfway across the globe. We're in the Philippines to better understand how tiny particles from smoke and pollution affect cloud formation. The campaign is called the Cloud Aerosol and Monsoon Processes Philippines Experiment, CAMP-X. The 2 is silent. That's just a joke, but the acronym, that's serious. This project has implications for millions of people.
I'm the program scientist for CAMP-X, and while I'm here, I'm sort of the decision maker of last resort if something comes up.
We caught up with Hal between meetings in the hangar. Along with Jeffrey Reed from the Naval Research Laboratory, he's responsible for overseeing this large collaborative effort in real time, making sure the team is meeting their scientific goals while also keeping researchers from institutions around the US and the Philippines working together smoothly.
A critical part of the process was the relationship built through time. That relationship enabled us to really work together and think about what would be the questions that would be relevant to us in the Philippines and in general to the region. I'm Gemma Teresa Narisma, and I'm the Executive Director of the Manila Observatory.
The Manila Observatory, along with NASA, the Naval Research Laboratory, and a handful of university partners are using 2 research planes and measurements from a ship to look at the properties of clouds to improve satellite measurements in the region.
Satellites find it difficult to see, quote-unquote, this region, and regional climate models are having a hard time capturing these processes.
That basically means planes, ships, and teams on the ground need to fill in the missing details. Which brings us back to the most intense fire season in 5 years.
We were able to get the P3 into that smoke and make absolutely unique and important measurements.
It's important because if we cannot get the historical observations in our model, then we're not so certain whether our climate projections are correct.
When the planes aren't flying, the science teams and flight crews take turns visiting local schools, from elementary up through university.
Elementary school students can understand remarkably complicated concepts. And so it's kind of fun to introduce them to things they may not have known or thought about before. And it's remarkable how quickly they pick up on it.
At these schools, the scientists are treated like rock stars.
We've had just an amazing response from the Philippine students. Many autographs and more selfies than I can count.
Some even said that they want to become meteorologists themselves to help carry on the study of our home planet and how it's changing.
I feel hopeful. We're not getting any younger, and the number of atmospheric scientists in the Philippines, in the world, particularly in the Philippines, is quite small. And the kind of work that needs to be done to understand the different atmospheric processes in the region is quite a lot.
We are so dependent on this earth because we live here, we have to breathe here and find things to eat here. It's important that we understand it so that we don't inadvertently cause damage that could affect us all.
What we're seeing is that areas that have been flammable are becoming more flammable, pushing those systems into either extreme conditions or a year-round fire season where fires are literally possible at any time. I think the choice to study fire generally is a bit of an occupational hazard. It's true. We're not necessarily looking at the verdant green parts of our planet. We're headed to the end of the road. We're looking at areas of rainforests that have been cleared and burned. We're capturing scorched landscapes.
In this series, we've been following the fire season around the world. First in the American West, in the early part of summer, the start of the fire season. Then in high northern latitudes, Canada and Alaska. Then finally in the Philippines, as the summer became fall. In the past, you could count on the fire season eventually coming to an end. But we're now learning that that's not really the case anymore.
What we're seeing is that areas that have been flammable are becoming more flammable, pushing those systems into either extreme conditions or a year-round fire season where fires are literally possible at any time.
We caught up with Dr. Doug Morton to find out the extent of the damage.
Hotter and drier conditions, adding wind, you end up with fires that are moving faster and burning hotter than what we've seen before. Can we better understand, anticipate, and characterize the changes in our planet that come from those extreme fires?
Actually, yes, we can.
Myself and my staff at the GIS Center worked closely with colleagues at Goddard Space Flight Center to make this thing happen.
This is Keith Weber, the wildfire rehabilitation expert that pioneered a new groundbreaking tool. The Rehabilitation Capability Convergence for Ecosystem Recovery includes a function that allows fire responders to triangulate their wildfire response. The tool can geolocate everything from burned areas to potential landslides to impacts on endangered species. But Recover really gained momentum after one fire in particular.
I remember looking at our whiteboard that shows all the real high priority things we need to be doing. And that whiteboard was clear. And I was walking out, I talked to some of my students and I said, I think the wildfire year is done. We got it wrapped up. Well, shouldn't have said that. Because the next day, one of our users in California, Woolsey Fire started going. It became much larger than I think they thought it would because of those big winds, and it really grew very rapidly. Well, at that point, we were working with that team on a daily basis, doing refreshes, as we call it, as the fire grew and grew and grew every day until we had that thing out.
Keith's team is making a tangible difference by saving property, resources, and lives. Innovations like these represent a promising future.
As we move from today's cutting-edge science into tomorrow's prediction, response, and understanding, the work we do today opens up an opportunity to do that so much better going forward. There are so many science topics that today are on the cutting edge of our understanding, and what get me and my science colleagues motivated to go out into the field and keep working on these problems. Can we improve the way that we can forecast, for example, fire risk, not just for tomorrow, but for 10 days from now, that might help managers, communities prepare and respond to changing fire weather conditions?
Like all of us, our NASA explorers and partners in exploration face the daily decision to either choose apathy or get to work. The future is uncertain, but we choose to meet the challenges of this new normal head-on.
Hi, I'm Jacob Bleacher. I'm a geologist. That means I study rocks and dirt on the Earth and planets. This is Ask NASA. I'm here to answer your questions. What is unique about the surface of the moon? Well, the moon is quite unique from the Earth. It has no atmosphere. There's no air to breathe. What that means is that the processes that have occurred on the moon are all preserved there in the rocks. For instance, if you look at the moon from the Earth, you may see circles. Those circles are impact craters. Let me show you. Except, Making craters is really dirty business. I need my crater making poncho. Now we're ready. Let's pretend this is the surface of the moon. It looks a lot like this. That's one crater, but the surface of the moon has many more.
Oh, that was a good one.
On the moon, these craters have formed over time, and as you saw, material from each crater buries the previous ones, making this very rough terrain. In that terrain, at the pole, there are some craters that we believe have water ice trapped there, and they never see the sunlight. That's good for science and could also be a resource that helps our